about the sun, it's about the world. It's about the sun, it's about the sky. It's about the world, it's about you. Spinning around, it's about the
Hola.
world, it's about the sky.
Good morning, everyone. So happy to have you, all of you here. We are going to start the third day of Devcon in Bogotá. I'm Bogotanian, I'm local. I'm so honored to have you, all of you here. And we are going to start with Matt, that is going to present us, and thank you very much for being here.
It's a pleasure.
Become an Ethereum staker and a setup node. Thank you very much, Matt.
Thank you.
Let's go for that.
All right, cool.
And
Thank you,
please.
everyone. All right. Good morning to you all. So, myself, Matt. I'm from BlockSwap, representing the Stakehouse. So, let's begin 60-second journey of Ethereum staking. Right, so what's a Stakehouse? Stakehouse is a meta delegation protocol built for Ethereum staking, in order to onboard mainstream users. Ethereum doesn't have a delegation built in, so we build that protocol on smart contracts so we can enable the node runners to get more users. At the same time, the users can get, safely stake with Ethereum. And it's completely 100% smart contracts and all formally verified. Right, so let's take a step back and see what we can do in 2 minutes in a live. Either you can have a coffee, or you could do a speed run of Ethereum staking. So currently it takes about 2 days to do that Ethereum staking, so that we're going to do that in 2 minutes. So 60-second staking and 60 seconds to set up a run a node. So you guys are ready for that? All right, cool. Let's go for it then. Count it, 2 minutes. That's it, 2 minutes, you become a staker, you got a node up and running, and you're good to go. So what we've seen here is like a complete smart contracts tooling wrapped around Ethereum deposit contract, and you got a node, you have it, you have your coffee, what's next? Now, 2 minutes is a very short time, so we got to do something else. Let's go get some LSD. You want that? I want to get a yes, then only I'm going next slide. All right, cool, let's go. All right, so now we want to get these node runners to get more ETH to stake and get 8 validators for 32 ETH. So you know that you need 32 ETH to get a validator, but can we get that to 8? So that's how we go from 1 to 8x. So how does the LST works? LST is a contract suite that is fully automated that will allow anyone to send their any tokens, ERC20 or ETH, and it will automatically get fed into a node network. So there's two marketplaces. Node operators can simply register with a 4 ETH, and they will be anyone can run this LSD network, let it be DAO or your staking service or anyone, and this pooling will automatically get the DETH back into the user's hands. Remember, the DETH is /free, so the users who are protected, and the slashing is going into the node if they are leaking or do something bad. So this is like an inclusive, fair, and open. It's fully permissionless. Anyone can set it up under 30 minutes. So here we're talking about who can use it. It's completely compatible with dApp node or Ethereum packages or your staking services or liquid staking protocols. Think about, we have Lido, Stakewise, Rocket Pool, and all these guys are doing amazing service. They're providing node running, but you also have solo stakers. And you have institutions like Coinbase and other people. But it's all the fragmentation of liquidity. We're bringing this ETH back. The meta delegation protocol will allow you to the LSD networks. Underlying staked ETH is completely fungible. So no matter which node runners are there, they can all enjoy this. And it's completely redeemable. It's fully smart contract driven. Right. We don't stop there. So Stakehouse will also give you a complete visibility to validator level for stake earning and threat detections. So you know that if something goes bad, you don't really have to go and find out. You'll automatically get it. Everything is on chain. It's complete coming from consensus layer. And you can build webhooks on top of that. So more things are coming there. Right. So if you go to joinstakehouse.com today, if you're a builder, it's 100% down friendly. All things are included. You have templates ready to go. If you're DeFi protocols, you have that. If you're, if you want to do gatekeeping, if you're institutions, you get there. If you're a node operators, you will have all the SDKs are there, and, NPM packages, everything is there. So if you want to do something, if you want to learn more about it, come and find us. You can join our Discord, or you can go to our website. Let's make Ethereum staking accessible for millions of users and make it safer too. That's it. Thank you. I speedrun the time, actually. I got 20 seconds more. It's a good thing to start. All right.
Yeah. Big applause. Thank you very much, Matt.
No problem.
We have some seconds. A quick question. Everyone? Anyone? No? OK. Thank you very much. Again, a big applause for Matt.
All right, cool. Thank you.
In 3 minutes, we are going to start the next talk. We are waiting for the people that want to attend. And yeah, let's wait 2 minutes, please. And we are going to have the next talk is going to be challenges of parallelizability under Ethereum execution model. What a word. It's going to be very interesting. From Peter Garambolgi. I'm trying to do it. I'm doing my best, Peter. So yeah, let's wait 2 minutes, and we'll start with this amazing conference and talk. with the talk Challenges of Parallelizability under Ethereum Execution Model. Welcome, Peter.
Hey everyone, good morning. How is everyone doing? Okay, I know it's pretty early now, so really appreciate that you get up early and come to this talk. So my name is Peter, and I'm going to talk about our work that we did at the Shanghai Blockchain Research Institute. And what we did was we investigated how hard it would be to execute transactions in parallel on the EVM. As you might know, the EVM is designed in a sequential manner. Usually you execute all transactions in a block one by one. So the question is, can we parallelize that? What we found, what I want to talk about today is two challenges that we identified. And the first of those is transaction dependencies. So you're probably all familiar with how Ethereum works. Basically, we have a global shared state, which is the state tree. And then theoretically, a transaction could access any point, any entry in this state tree. That is, whether it can access a slot or not, that's defined by the contract code. So for instance, if we have two transactions from two different accounts, and both of them call the same contract, and that contract reads or writes the same entry, then these transactions will have a conflict or a dependency. Now, on Ethereum, this is not a problem now because we execute transactions sequentially, but if you parallelize them, then this will become a problem because you cannot concurrently execute such transactions. So we did some evaluations. Basically, what we did is we collected some storage traces for a few hundred thousands of blocks from historical data on Ethereum. And we did some simulations with some OCC scheduler. And what we found is that the theoretical maximum speedup is as little as 4 times. So even if you have 8 threads or 16 threads, at least on the VM level, if you don't consider storage, you cannot do much, much better than 4 times. And that's kind of an underwhelming result. So some examples, some simple examples of these dependencies. For instance, if you have 2 transactions to the same ERC20 token, if they send from the same sender or to the same receiver, then they will conflict on the balances mapping. Or if you have 2 transactions swapping tokens on Uniswap, swapping the same token pair, then both of them will modify the reserve variables. So that's also another kind of conflict. Or if 2 transactions are minting an NFT, then, for instance, they can conflict on total supply if the contract is keeping track of that. So we identified this, and this is an issue. I think this severely limits the parallelizability of EVM transactions as they are today. And we have some suggestions how we could improve this. This is kind of early, just some ideas to throw in there. The first idea is to use a sharded counter. So from the examples before, you saw that many of these conflicts are conflicts on a single storage slot, which is like an integer or some counter. And yeah, 2 transactions read and write the same slot. So the idea would be to shard it into multiple slots. So one int is represented by 3, 5, 7 slots. And then we could route transactions based on some heuristic to different slots. Let's say we take the last byte of the hash of the sender address. So 2 transactions from different senders would probably, with a higher probability, they would modify different slots in the contract. And the second idea that we came up with is lazy add opcodes. So in this example, we have a very simple function that's just incrementing a counter. But when you compile it to EVM bytecode, what you have is a storage load operation. Then you do something with that value, and you store it back. So 2 concurrent transactions we'll have a conflict on these like concurrent storage load, storage store operations, and we cannot parallelize them. The idea here is to maybe introduce a new kind of semantics for addition, lazy add or commutative add, and that would be evaluated lazily. So these transactions can execute in parallel, and then we basically batch those 2 updates together into a single update at the end, and that could be executed at the end of the block, for instance. And the second challenge that we identified is that of determinism. So as you might know, in parallel execution, there's a lot of non-determinism. And we can make sure that 2 transactions have the same result, or 2 executions, but there are other types of non-determinism. For instance, here we have 2 executions of 3 different transactions. And let's say transaction 2 depends on transaction 1. So in this case, on node A, 1 and 2 are executed concurrently, so 2 has to abort and be re-executed because there's an update that it could not see. And on node B, they are executed sequentially, so transaction 2 can commit directly. So our idea is that if we have parallel execution, at some point we have to introduce some incentives, because if you can trigger some aborts, that kind of opens up the door for some denial of service attacks. And if we do associate some incentives with aborts, then to these 2 executions in the example, they will yield a different final state. So that is going to be an issue. 2 nodes will diverge. So for this, we kind of came up with a new scheduling framework called optimistic concurrency control with deterministic aborts. And the idea is very simple. Instead of deciding these abort commit decisions during runtime, you make this decision prior to running the transactions in a deterministic way. So these decisions will be deterministically the same on all nodes. And this way, even if you attach incentives to these decisions, the final state that different nodes will arrive on will be the same. So this is the OCCDA framework. Just to summarize kind of the takeaway from this talk. So it's pretty hard to get parallelization done on the EVM because it was not designed with this in mind. But I think it's going to be worth it. For instance, if you manage to scale Ethereum on layer 1 or layer 2 with a higher transaction load, parallel execution will have a very big impact on the overall efficiency of the system. So if you're interested in this research direction, I would encourage you to read up on it, think about it. And we actually have a publication about this topic. So if you're interested in a much detailed discussion about the ideas that I talked about here, you can go ahead and scan the QR code and read the preprint. And that kind of concludes my talk today. Thank you very much for coming.
Thank you very much, Peter. We have time for one quick question if you want to ask in the audience.
I was wondering what your thoughts are on parallelizing just balance transfers, which are much simpler, instead of contract stuff. Just like Ethereum balance transfers, like certain transaction types are radically simpler than contract execution, and I wonder if you had any thoughts on that.
Yeah, that's a good question. So here we only considered contract storage conflicts. But actually, there are different kind of conflicts. Another part of the state tree is the account with the nonce and the balance. So yeah, simple transfers are expected to be much easier to parallelize. And even with contracts with access lists, you get much more information that you can use to parallelize. But I'm not sure. The majority of transactions, I think, are contract calls. So I'm not sure about the impact of this. But I think that's certainly something to look into. Thanks again.
Okay, thank you very much, Peter. An applause for Peter, please. Thanks, man. We're going to continue with the next talk, that is how to use executable consensus PySpect from Xiao. Everything to restart, the computer science strategy to restart everything so everything works. 3 minutes to start the next talk. Our next speaker comes from Taiwan, and she's Xiao Wei Wan, and she's going to talk to us about how to use executable consensus PySpec. You're very welcome.
Thank you. Hello, everyone. I'm Xiao Wei. I work at Ethereum Foundation Consensus R&D team. So this is a lightning talk of the consensus PySpec. So you can find the code base with this URL or the QR code. And this is a CC0 open source Python project. Now we have like more than 100 contributors so far. And most of them are actually Ethereum core devs. And thank you for your contributions. Okay, so this project has three main purposes. So first, this is the center of Ethereum core consensus space. And second, it is also an executable and verifiable Python program that you can use it to run the consensus logic with. And the third, it's also our test vector generators for the CL clients, the consensus layer clients, to test their implementations with. Okay. And so if there's a new features that we are thinking about to apply it in the consensus side, like the beacon chain side, so you might try to prototype it with the markdown files that I will introduce later. And we implement it in markdown files, and we'll do the test. And the test vectors would be generated with the Python programs test case, like the PyTest, if you have used Python before. And for clients, they can download the test vectors to test their implementations. So if you understand this process, you can see that, the spec is now important and unique component in the whole CL R&D process. And it also helps us to find some very basic bugs that before clients started to program, to actually prototype and test it. Also, it helps clients to sync with the core specs more efficiently. The reason why we chose Python instead of other language was that because it's probably, I think Python is probably the most readable programming language for most developers. Like you can say, like Python are just pseudocodes. And okay, now let's see how to read it. Oh, so I shouldn't stand it. So this is the specs folders, and here you can see some. The blue ones are the mainly hard forks that will already be implied, and the yellow-green parts are the work in progress features. And also inside one of the directory, you can find that the specs are actually written in the markdown files. And like the most important entry might be the beacon chain spec, and there's also like fork choice or P2P interface in it. And we can define the constants and configurations just like you are writing markdown and in the tables. So looks like this. And we also define the classes, the SSE containers. So listed objects are for the consensus objects because we use it to do the serialization in the consensus object. Okay, and also this is the example of the state transition functions. We can just write down the write down the Python functions in the code block in the markdown files. And also you can see there are some assertions. So if the input is, if the assertion throws exceptions, then we could say that, okay, the input is invalid because it doesn't pass the test. Okay, there are some more useful links for you to understand more about the spec itself. And also, so this is a ELF, I so call it ELF in the PySpec in the setup.py file. So it is the program that helps us to parse the markdown files and convert them into a Python program. And so the readers, they don't have to read in the .py file, they can just read the markdown files, which are more readable. Example of, so if the phase 0 is the base layer of all consensus specs. And Altair, if you want to understand Altair, you have to extend the phase 0 specs and the new features in the Altair. So, and as well, the Bellatrix, they have to merge 3 of them. So I have 1 minute left to do how to use PySpec. And so installation is easy, just install from PyAPI or from source code with this command. And okay, hope you can see it. Okay, this is a very basic hello world example. And this is an example to, you can just write hello world into the gravity of the beacon block. And in the first line is you can import the whole many Bellatrix specs as rename it to spec like that. So you can use it as a playground and see the example code in PySpec to try to play with it. Okay, this is how to write your first PySpec test case. Okay, there are already some existing helper functions to help you to prepare the beacon block or to manipulate the beacon state with. And there are some assertions here that are for us to set our test scores of this test case. Like, and important part is here, like you can see there are some yield, Python yield comments. It is for us to output the test vectors. For example, this one, we output the pre-state and the side beacon blocks and the post-state. Okay. So output file will be there, and the list is the pure functions for the clients to test with. Okay, documents, if you want to see more documents, please see the URLs. And okay, so this is the most important page actually. So how to contribute with PySpec. If you are interested in helping with consensus layer R&D, I think PySpec is a really good start to learn and contribute with. And there are some different labels that you can participate in. Sorry. And you can do it from just fixing a little typo or to submitting a bug report. And if it's got accepted, I think the EF will be happy to give you the rewards. Okay, and we also have looking for some in-house resource for PySpec implementations. So if you are interested, and feel free to reach out to me, or if you want to participate or have any questions. Okay, thank you.
Thank you, Shaw. If you want to ask some question to Shaw, I invite you to do it. So this talk, because we have to continue with our next speaker. Very welcome, Peter Davis. You're going to find your microphone. Oh, yeah, the same microphone could be. And Peter is going to present EELS, the future of execution layer specifications. Whenever you want, Peter, you're very welcome. Thank you for coming to Bogotá.
Hello, thank you. Hello, I'm Peter. I'm from the EELS team. EELS is an acronym for Ethereum Execution Layer Specifications. And we're working on the future of how do you specify the execution layer. So we've just heard about how the consensus layer do their specifications in Python. If you think what I'm talking about is similar, it's because that's where we got the idea from. Before I begin, I want to talk about what I mean by the execution layer. We're only here interested in the state transition function. So you have like a long chain of blocks, you have some state, you add in some new state, and the question is, firstly, is that block valid? Are you allowed to add it to the state? And secondly, what is the new state afterwards? We don't care about anything else. We don't care about networking. We don't care how you implement reorgs. We only care about what is this state transition function. So currently, let's suppose you're like someone you want to know about the state transition function, the execution layer, how it works. Where would you go for information? Well, the first place you could go is the yellow paper. Well, I have the yellow paper here. This is a lovely extract that explains what the header validity conditions are. And some people think this is readable. They are in the minority. If you're curious about the weird mountains, they're not mountains. That's how mathematicians write and. The other problem with the yellow paper is that it's actually really out of date. This is the Berlin version. The reason it's the Berlin version is because no one's implemented London yet. Secondly, you can look at EIPs. EIPs are individual slices of changes, they're specific change proposals, and they're you can look at them and you see the history, but they don't tell you about the relationship. They only tell you about individual changes in isolation. So if you, for example, if you can read EIPs where it's well, this thing says this and this thing says this, but how do those two things interact? And you just can't get that from EIPs. At that point, you can then go, okay, well, I'll look at the test suite. And the test suite is great. It is full of loads and loads of tests, but ultimately, it's just a pile of tests. It's not particularly well organized. And if you want to find some behavior, maybe you can find somewhere in the test suite where that behavior is tested, but it's not specifying anything. And then you can just give up and look at the Geth source code. Fundamentally, if you've got to the point where you're having to read the client source code to work out how the execution layer works, we have failed at specifying it. These clients, they are big, complicated, high-performance pieces of code. They're not designed for the reader. The other thing about specifications is they need to be part of a standards process. You can't just say, oh, well, we're going to implement all this stuff and then we're going to update the specifications later. This is the big problem with the yellow paper, is that it's not part of it. No one proposes a change by saying, this is how I would change the yellow paper. And so the yellow paper just gets updated later on as an afterthought. The other problem is that the yellow paper is just like a document. It's not executable. You can't test whether it works. And this applies to EIPs as well. So this here is a sample from the EIP that changes how the cost of the mod X precompile works. It was proposed, it was accepted, and you're like, this is nice. There's a nice piece of easily readable Python that says exactly what it does. Problem is this Python is wrong. No one has ever executed this Python. Because if they had, they would discover that it doesn't really make any sense. And, I mean, as Donald Koo said, beware bugs in the above code. I have only proved it correct. I haven't executed it. So you need so this is our approach. We want to start with a code-first approach to specifications. We take Python, and we're not just writing any old Python. We're trying to create the Python that if you opened some programming book and someone had an example algorithm, it's that Python. So we don't use classes. It's just methods and effectively structs. This is the common language. All programmers speak this. Anyone who's done any programming will immediately know what this is. You don't need to understand pure mathematics like you do with the yellow paper. And crucially, it can be executed. We can test it. If you want to know what the Python does, you can run it. If you want to compare it to a client, you can run this. You can run the client. Do they do the same thing? We're purely here interested in readability. We don't care about performance. It's extremely slow. It can sync mainnet. I think it takes probably going to take about 6 to 9 months if you want to start from Genesis and get to the head of the chain. It's not a viable client. We also make some very weird design choices. We look at hard forks in isolation. So if you go, you'll see it's Ethereum /Ethereum /Frontier and /Homestead, and each of those is an independent implementation of those hard forks. So this is like terrible for like code duplication. Like literally every time we implement a new hard fork, there's like this massive copying of like thousands of lines of code. But it's great if you're like a reader. If you want to read it, you can see like how Homestead works completely in isolation. You don't have to think about how it relates to other things. Whereas if you read a real client, it's just a pile of like, if we're later than Spurious Dragon, do this thing, otherwise do this thing. If you do want to look at comparisons, though, we're developing specialist diff tools. And those diff tools allow you to compare, like, this is exactly what happened. This is the specification for Frontier. This is the specification for Homestead. This is what changed exactly line by line in code that we have tested. So here's a sample. This is the sload opcode to give you like a feel. A number of things here. First, you can immediately see we've really tried to make it as readable as possible. We've also divided it up into these like individual sections, which we've given headers. This actually like matters. There are a number of quite subtle semantics that the EVM has that relates from the fact that gas calculations are done before any computation is done. And you can get very confused about some of the subtleties of particularly the call opcodes if you don't realize this. Now I want to move on to like, now we have these things, how can that like affect the development process? How does having these specifications make improving and building on the EVM better? And I think it's helpful here to think about two sides of the development process. On one hand, you have like your R&D people, think Vitalik, and on the other hand, you have implementers, think Peter, who's the Geth team lead. The R&D people, they're doing research. They want to throw together some simple Python. They don't really care about the performance. They just want to write it, test it, and think, is this a way we should do this thing? On the other hand, you have the implementers who are trying to write a robust production-ready system. They want to know every single subtle detail of every single thing that has to happen, because if they get it wrong, that's a major security incident. And also, they have to like spend all their time thinking about the subtleties of like DB disk performance, which is an endless bugbear for anyone who has worked on the execution layer. And EELS provides a common framework. It allows these two sides to talk to each other. It's a common language. Your R&D people, they can write that Python, and this is what they do already. When they're doing their research, they write little Python models. Well, now you have these specs. If you've written that little Python model, you can like stick it in EELS, you can implement it in EELS. It's not much more work, and already you have something that you can then show to the implementers. This leads to this sort of development process. You have your R&D people, they develop their idea, they prototype it in EELS. You then give it to us at the EELS team, and we, as part of like the governance process, integrate all of those things together. We make a hard fork. Exactly what goes in, obviously, is like a thing for all core devs. It's not like we're taking all the power here. And critically, once you've done that, there's a whole bunch of things you can do because you have an executable spec. Our executable spec will be able to fill all the test vectors. It might even be able to like run its own very miniature, like 2 million gas a block test nets. That means that you can have tests and precise specs before you've even written a line of code in your production clients. This like frees up production clients to not have to be also the R&D playground that they sometimes are. This is not like a perfect thing. Like often you have to go and implement models in production clients to deal with performance issues. There are networking issues we don't deal with. But currently, like anyone who wants to propose any like significant change, they like implement it in Geth or wherever. Whereas now you have this playground to do it in. And critically, this is like a sort of parallelization stage, because like currently, currently you have this like situation where like the implementers and the R&D people like have to like interact much more tightly. If you have this like EELS process, you can like separate that out and do these in parallel, so that you can like have the implementers finishing up one hard fork while EELS are like getting ready to prepare the next hard fork. Whereas if you're like busy modeling things in Geth and the implementers are also tied into doing the R&D, you just don't get the same parallel efficiency. I should now talk a bit about where we're at. We have implemented all the hard forks. The merge is still a PR, but we're nearly there. We're going to need to do a bunch of like refactoring, and then we need to freeze the code, because we're asking people to like build it. We're saying if you want to take an EIP and you want to build on top of that, change it, you have to take our our latest fork, copy it, implement your own changes. And we can't ask people to do that sort of thing until we've freezed the code and said we're not going to like refactor it under you, and we're not quite there yet. Once we've done that, we're planning to like shadow the current governance process for Shanghai. So Shanghai is going to go through in exactly the way that all previous like hard forks have gone through, but we're going to also be working with a whole bunch of people to try and implement those changes as EEL's proposals, and then we're going to like see how the governance process works. And then hopefully we can like improve on that and talk about moving away from some of these legacy approaches to specifying execution there. Finally, there's the question of how you can help. Firstly, we don't actually need your help yet. We're still coding. We need to finish that. Once we've done that, we ask you to like implement your favorite AIP. And like give us feedback, like how was it? Because we don't want this to be a world where we as like the EELS team can like develop develop things and we can propose changes but no one else understands it. I don't want to be in the situation that you're currently in with the yellow paper where actually only a really quite small minority of people know how to write tech and how to change the yellow paper. So I want this to be like an open process where anyone who's like, oh, I want to propose something, to just clone our repository, run the new fork tool, and implement their change and like produce a proposal without being burdened by having to think about like how the GefDB works or whatever else they're going to do their modeling. That's the end of my talk. We have plenty of time, so do people have any questions?
Big applause for Peter. I see some questions there.
Okay. Has there been any thought or consideration, because the yellow paper talks about things like state growth and those sort of things. It'd be nice. Oh, can you hear me, by the way?
Not quite. Can you speak up a little bit?
Okay, well, I can like, can you hear me now?
No, you turned it off.
Okay. Can you hear me now?
Yeah, I can hear you now.
Okay. State growth. So if I make a commit to the execution spec and I want to see how that influences state growth over time, and like the capability to run a node and things like that. Have those sort of things, those mutations, been thought about from a, metrics gathering level?
I mean, this is a thing that like people who implement this like think about this all the time. I mean, yes, because we hold the whole state, you can like model that sort of thing. I think a lot of that is mostly about gas pricing and gas accounting. And like there are advantages here. So for example, there was a proposal about how withdrawals worked. And because I had the execution specs, I could like look up the table of gas prices in the execution spec and say, well, this is how much this sort of thing should cost. And like, yeah, but I don't think our tool is like particularly useful for like modeling state growth particularly. You just need to understand like what actions can cause state growth and how much gas those cost. Yeah, great. Next question.
How is this going to interact with the reference tests that the EELs? There's a lot of crazy edge cases in reference tests, such as integer boundaries and other strange things.
Oh yeah, I mean, I've had a lot of fun with crazy edge cases. I should do a talk on crazy edge cases once. At some point, they are amazing. I mean, firstly, we run all of the reference tests. So if you go in our test suite, you type tox, the automatic test suite will run all of the reference tests. And so currently we pass every single one of them. And I have learned an awful lot about the crazy edge cases of the EVM. We actually hope to go further than that. We want to be the canonical builder of the execution tests. So currently, for those who are not familiar, we have test fillers, which are they're not like complete tests. They say, here is what the pre-state's like. Here are some assertions about what it should be like per state. Then you take a client, it's usually Gef, and you run a filling process that gives you a completed reference test. That reference test, and it tells you what the state root is, and it tells you basically exactly what the block should be after you can perform its execution. We will think that we should be like the canonical filler of those tests. We can fill them before the execution clients had even implemented those tests. And then we can, if you want to, and that means that clients can use the test to build their clients, whereas currently, until you've implemented something, you can't fill the reference tests in. You have to implement it in a production client. There is also, and I haven't thought about it in great detail, the question of whether we should use whether we can like analyze the structure of eels to like generate new reference tests and basically do some sort of path analysis and say, well, these are the possible paths through this sort of code base. Can we follow every possible path and make sure there's a reference test that follows every possible path? But that's like R&D that we like haven't done yet. Next.
Hello?
Hello? Yeah, what was your question?
You mentioned you implemented, you care only about state transition function, and that means you implemented your own EVM, and you can fill the test, and you provide the post-state hash.
Yeah.
Cool.
Yeah, like if you have a chain, and you have a block, and your proposal is to add that block to the end of that chain and update the state, we could tell you, our test specifies exactly whether that block is valid. Are you allowed to do that? Because blocks, I mean, particularly random blocks, tend to be invalid. In that case, you're just not allowed to do it. And if it is valid, it tells you what the state changes are, and then you can do the next thing. We don't do anything else. That's the only question we answer.
We must meet.
Hello. So this is obviously inspired by the consensus specs, or the Pi spec. Are there any particular architecture changes or learnings you've gotten from the Pi specs?
Oh yeah, that's a really good question. Okay, so there's a couple of differences here. The first one is that the Pi spec, the consensus Pi spec, is a document that can be is a bunch of documentation that can be compiled to code. So if you look at the Pi spec, it's a bunch of MD files with some code in, then there's a compilation process that spits out code. We are a bunch of code that is you can then compile using standard documentation tools to documentation. The second big change is the Pi spec does this like incremental building stage, where in the Pi spec you have phase 0 and then you have Altair, and the Altair documentation just adds a few changes to the phase 0. Whereas what we did was we copy the entire thing and create a new version that contains everything, which means that, because otherwise what would happen is if you wanted to know how the merge worked, Paris worked, you'd have to read Paris, which would say these are the changes versus London, and then London would say, well, these are the changes versus Berlin, then Berlin would say, well, these are the changes versus Istanbul, and it would just keep going on and on. And so we don't think that's a particularly good way, especially because a lot of the historical details are really quite legacy and not things that people need to be concerned with nowadays because they've been changed out. And so we just like they're completely isolated files. This causes like a whole bunch of code duplication issues and complexity, but it does mean it's like really simple. You can read a particular fork completely in isolation from any other fork, whereas if you can't do that with the consensus specs. Cool. Anyone else?
Thank you for the presentation. I was wondering, for the executable specs, how do you think it might change and improve like the EIP process of Ethereum? There was lots of conversation in terms of governance of how when you're proposing an EIP, maybe this should be like a requirement to kind of speed up the testing process, but would love to hear your thoughts on how it could be integrated and what parts of it could improve to change that EIP flow.
Oh, there's a lot of opinions on this. I will present. So on the one, so there are some people who think that we should get rid of the EIP process for the execution layer. We should abolish EIPs for the execution layer, and instead you should have whatever EELS proposals are called, and it should just be, if you want to change the execution layer, you write an EELS proposal, you might write a small amount of ancillary documentation, but mostly you just write a PR. There are other people who think that we should do a like hybrid process where there is a EIP, and the EIP comes with, as like a mandatory component, a EELS change. I actually don't have a particularly strong opinion of this. I can see the argument for both sides. Yeah, but there's lots of thought on this. I generally take the attitude that I'm going to wait until like we've started using this and people have like seen it in production, and then they can start talking about what they actually want to do.
We have time for a last question, if someone is interested.
Anyone else?
If no, thank you very much, Peter.
Thank you.
Amazing presentation. I love your shirt. Amazing one.
Thank you.
It looks so good in this stage. Our next talk will start at 11 o'clock in 4 minutes, and is going to be hybrid PBS from CL's perspective of Terence Zhao. So be prepared, Terence, please. 4 minutes. We're going to be back here. Okay, we're going to continue with this amazing agenda in the third day of Devcon VI in Bogotá. And our next speaker is Ethereum Zhao, and he's going to talk us to hybrid PVS from CL's perspective. Please, an applause for Ethereum. Very welcome.
Hello. Thank you for the warm intro. All right, let's get started. Where's my slide? That's my slide. Hybrid PBS in consensus layer. I'm Terrence. I'm a core dev. And as of earlier this week, we are part of Off-Chain Labs, so I had to change my name real quick before I get in trouble. So let's get started. So this talk is about consensus layer interfacing with hybrid PBS. It's not so much your like searcher, builder, your typical MEV talks. So we want to understand more like what does it mean when consensus layer interface with hybrid PBS from the its externality such as latency, file, and censorship. Then we'll also talk about like mitigations. So just to reiterate what I said, everything in the purple, we will go over it. We'll have relayers, Math Boost, which is a relayer aggregator. We have consensus layer client, execution layer client, and validator client. And this is what we have been, me and my team and other teams have been working on over the last few months. So background, why are we here, right? So there's options, and options are nice. So the first options, which most people use these days, is normal block processing. So as the consensus layer client, you know which validators you're serving. You know when validators are proposing a block. So you will build the block for the validator. And post-merge, we utilize execution layer client to prepare payload. So consensus layer client uses execution layer client to prepare payload. They put the payload in the block. That passes to the validator. Validator signs it, return the block. And consensus layer client broadcasts the block. So here, the separation of concern is nice here because like execution layer client and consensus layer client, they're both like very complicated piece of software, but they only need to know each other through the engine API. And so the separation of concern is very nice. The second option, which people are starting to use more and more now, is that I can outsource block production, right? As a consensus layer client, if I want to participate in the MEV game, I can utilize the relay network. I can, hey, relay network, can you propose a block for me? And the blocks are usually more profitable. And also in the background, consensus layer client can also talk to the execution layer client, like, hey, can you make me a backup block in the event that the relay network doesn't work? I can still use it. And this is kind of the paradigm that we're heading towards. And it's important to understand, like, what does this mean? So this is today's number, and hopefully you guys can see it. I captured it this morning. There are 55% of the network participation is using MEV block production. It is outsourcing their block. And then out of the 55%, 81% are dominated by flashbox relayers, and there's 7 active relayers. So let's talk about the first risk, latency, right? So when you propose a block normally under your local setup, you have your consensus layer client, execution client, validator client. So how does this work? You ask execution layer client to prepare a payload, and then you pass the payload to validator client to sign it. Validator client sign the payload, and then you broadcast the payload. Simple, easy, very easy to reason about, right? But with MEV block processing, it's a commit and reveal approach, right? Why is it commit and reveal? Because like, as a relay, as a builder, you don't want validator client to steal your transaction if it's in the clear text. So you made them sign it first, then return the signature, and then you give the full transaction. So given it's a commit and reveal approach, there's a more like steps in the middle, right? First you get the header, the relay network return the header, then you sign the header, and then you submit the signed header, and the relay network return the full payload, which is transaction in clear text. So as you can see, there's like 2 more steps here, right? And besides that, it's just like it's also on a different network, right? It's not local anymore. So ideally, like you want the relay network to broadcast the block as fast as possible instead of giving it back to you and then you broadcast it. So hopefully, like most of the relayers have been like publishing blocks like by themselves instead of just passing back. So for that, you do save some latency, which is nice. So let's ask ourselves, right, do the additional round trip and latency matter? Because like I said before, when you have your EL and your CL, they are both in the local setup, it's lightning fast. It is reliable because they just go through hardware. They just go through electron circuits, right? But if with the relay network, it's slightly different. You are actually talking to some like infra provider, GCP or AWS on some regions. And so this is, I was able to capture some numbers. Unfortunately, I haven't been home for like the last 2 weeks, so these numbers are slightly old. But on Gordy, with 1,000 validators, there are not many validators, but yeah, just 1,000 validators. But given it's Gordy, the network topology may be slightly different, but I mean, I hope we can get a picture here, right? Here, I'm not even using MEV boost. I'm just talking to the relay directly. It takes about 3 times slower to propose a block, given the additional latencies, right? So what does this mean when there's additional latency? Because when you propose a block, usually how it works is that you run a for choice to get head, then you build a block based on the head, then you get a payload from the execution engine, then you broadcast the block, right? And then at the 4-second mod, which is 1/3 of the seconds per slot, attesters will vote, right, what is the head of the chain. And if the attesters did not see your block, then your block may get orphaned, and that's not ideal. You do not want to lose a block, right? So this is what we don't want. We don't want something that's taking up so much in the middle with the get header, second header, and suddenly blind block, right? So this to me is worrying. And then let's look at some more numbers on block arrival latency differences. This is actually captured on mainnet. This is my at-home setup at home with 300 megabit bandwidth. So this is as at-home setup as possible. And then we capture over 15,000 samples and then the MEV block took about 500 milliseconds longer, right? And what does this mean from the submit attestation timeline? It just means that if the block takes longer to arrive, then attesters will unfortunately miss it, like that, right? If you're waiting like in the front like for that long, then you will essentially eat up the time that you have. So you don't want to be the lazy block. You don't want to be the late block because you will get orphaned, right? At the top example, block C was supposed to build on block B, but it built on block A. And then because the block B was late. On the bottom example, block E, instead of building on block D because of proposed boost or something, it was supposed to be the head, but it's not the head. So block E built on block B, therefore C and D got orphaned, right? So another set of numbers. 50% of the orphan block actually came from relayer from September 17 to 27. And there's the orphan block slot, the relays they're using, validator ID, the entities, right? And that's unfortunate. I mean, you could ask that, okay, well, maybe it was gonna get orphaned one or another, we don't know, but still, like 50% of it come from the relayers. So it's not just like sunshine, rainbow, and butterfly, right? This is I mean, there is risk to this, right? I mean, like we often told people, hey, we should use the relayer because it's more profitable, but it also comes with risk, right? If using a relayer makes your block 2 to 3 times more profitable, but you get orphaned 10% of the time, is it worth it? That's something that you have to ask yourself about. And another risk, I think, with latency is just centralization, right? The whole point of MEV boost is like to make validator decentralized because now we can extract MEV at home, so it gives everyone equal access to MEV. You don't want it to look like this, right? You don't want people to start realizing, oh, well, if I have better latency, then I won't get orphaned, so I'm gonna move my at-home staking node close to the relayer, so it becomes a negative externality. This is what we don't want. So what's the takeaway with this, right? The takeaway is latency matters both for hybrid or even maybe for little PBS, right? And latency can lead to centralization risk, which we have known a long time already. And it's actually really hard to optimize towards network latency, right? At the client level, like, I don't think there's much we can do. I think on the MacBook side, there's talks about, like, instead of Marshall or Marshall JSON, we Marshall or Marshall SSD. There's some improvement there. From the relay perspective, I hope like they have really good network config. They have a lot more peers. I feel like they have a robust like infrastructure there. I think that's as much as we can do, because unfortunately, if someone just have a slower internet connection, they want to use a relayer, I mean, this is going to be affected, right? It's important we educate these risks. So besides latency, there's also faults too, right? So what does fault mean? Fault here means that, sorry, the slide got a little messed up there. So when you ask for the header, the relay network failed to return the header. So that's the commit phase. Or the fault can happen when you submit the header, the relay failed to reply the payload. So that's the second fault. So we'll focus on these two types of faults here, right? So the first category of faults is just get header faults. When you get header, and then the relay network failed to reply. And they can be categorized as like you have a mail form header, you have a consensus invalid header, you have a payment invalid header, or you have a non-conforming header. So we'll go over them one by one. So what does it mean when like a header is mail form, right? It just means that it is syntactically invalid. It has an invalid structure, it has invalid signature. Can the consensus, can the CL client detect it? Yes, it can, right? Because when you marshal it, if it's not the right structure, then, well, you know it's wrong. You also can verify the signature. So this type of like faults we can detect and then we can mitigate. So this is fine. Another type of fault is just consensus invalid header. So that just means that the block hash is invalid, the transaction is invalid. But for this, we unfortunately cannot validate because we cannot see the full transactions, right? We cannot calculate the block hash ourselves. So that's something that we just have to trust blindly. That's unfortunate, but it is what it is. Then you have payment invalid header. So at this type of fault, it just means that, well, the builder was promised to pay the validated proposer some ETH, but it failed to pay. So consensus layer client cannot detect that type of fault. This we rely relay. We trust relay to simulate it. That's why relayer is trusted for us. And then there's also the non-conforming header. It just means that when the validator register, it basically say, hey, this is the guess limit I want to use, but the guess limit is incorrect, the timestamp is incorrect, the block hash is incorrect, right? Can consensus layer client detect that? Yes, it can. So those are like what we say the commit faults. So now we'll jump into reveal faults. So this is the second type of faults, right? So what are some like reveal faults? So the payload could be invalid or the payload is unavailable. And keep in mind, there's no falling back for this. Like, because you signed the signature already, right? So at this point, you can complain on Twitter. You can probably like complain something else. But there's not much you can do here to basically make the block as a whole. So a mail form payload similar to a mail form header, it just means that it is invalid, like the block, the full payload does not match the header. Can the consensus layer client validate? Yes, it can, but hey, it's too late, right? At that point, you lost the block already. There's not much you can do. And it's the same with consensus invalid payload. You can validate the transactions now because we see everything, but hey, it doesn't work, too late, sorry. Then unavailable, this means that the relay network just went to sleep. When malicious decided to turn off, it did not reply back the header to you. So it did not fulfill its commitment, right? And then you know when it does that because it never replied, you never received the payload. And there's nothing you can do there because you already signed something, your signature is out there. So we have this concept of falling back to execution layer client. Just if get header goes wrong, you can produce with your local execution client. That's probably fine. But if the get payload fails, then you cannot produce with your local execution client. Just you don't want to double sign. So the return header, the first commit, can fail two ways. You can either fault or timeout, right? We do prefer fault better, just because like you get the response right away. You can start propose the block right away. If the timeout, it kind of sucks because you have to wait for them to time out. You wait for them for a second, then you lost a second of like your precious time there. So let's go through some mainnet incidents. I don't want to sound like I'm like pointing out their fault incidents, but I do think it's important to go over this type of incidents so that we can learn as a community, right? The first type of incident, so the first incident is September 16, Flashbots Relay. They failed to a Marshall deposit for the payload reply. The damage, we missed 3 blocks. The second one, blocks ROS relay. This one is when the relay did not validate the block, and then they replied. The consensus is melted. We missed 88 blocks here. The third one is blocks ROS again. This is consensus invalid payload, and the damage of that is 15 blocks was missed. So this type of things do happen, right? Faults happen, and then it seems like it's mostly happen on the commit and then also the reveal phase. So we need some mitigations like a circuit breaker. And for example, as a beacon client, I can detect when there's a liveness failure, and then when the liveness failure is determined by clients, say if you miss 3 slots in a row, or or the chain misses 8 slots of the 32 slots, if that type of thing trigger, then we just default to local execution engine, right? So this is to prevent like a dominant relay builder go offline. And it doesn't solve like the cases like I mentioned before, just because like those happen maybe like 0.1% of the time. For this happens all the, but for this, like this is a stronger defense. Then you have your relay monitor, for example, such that you can monitor relays based on performance, such as behavior, which is like safety and liveness, and performance, which is latency. And people can see how the relays are performing, and people can figure out, okay, based on that, do I want to connect to the relay? So it just makes the information more available. Then we have features like bit filtering. So as a proposer, you can say, hey, I only want to use a relayer if they give me something that's over this value, right? So there's some nice things you can do there. So what is takeaways, right? We're still early, but we need more robust relay, and also we need a way to hold relays more accountable, right? For example, a simple idea is just you monitor all the missing slots and the orphan slots live, and then you pull the API, the relay API, and then if you see, hey, the missing slots is coming from the relay, okay, I'm gonna just like shout out loud, Twitter or something, so that people know, hey, there is an incident right there, it's happening live. You need to turn off your relay, or you need to switch local processing. In terms of just like faults, timeout, I think I prefer get header faults, then I prefer get header timeout, then I prefer get payload faults, just because like with get header faults, you can propose a block just like still, and then it's most likely fine. And I do believe that relay quality will improve over time, just because like it's still relatively early-ish. So I mean, they're still learning, and we're still learning, and something that will improve over time. So, okay, last section, censorship. That's something that we have been talking a lot about. So as of today, let's see, what number? 49% of the mainnet blocks have some sort of OFAC compliance building, and that's unfortunate, just that's already over half, right? So we have to understand like who is censor, right? Like who can censor? Builder can censor, right? If you're a builder, you don't want to build blocks that can send like OFAC compliant transaction, you can censor. Or the relay can censor as well, right? So therefore, it's really hard. It's really hard. So what's the problem here? The problem here is that MMA Boost is a neutral piece of software. It doesn't care about censorship, right? And then the UX of just figuring out like how do we defend censorship is still early. Right now, it just essentially everyone chooses the relay that's non-censoring. That's it, right? But then it's hard to figure out who is censoring at a given time. It's like you don't know who is censoring. I mean, we just look at the news, we do Google search, and that's it. We need more like information there. So potential solutions, right? These are very experimental ideas that I just have been thinking on top of my head, right? You can have some active inclusion, such as map boost CR this. You can have some sort of censorship oracle. So for active inclusion, right, high level, how it works is just like a proposal, you express the intent to like force transactions into the payload, right? And the relayer has to present those like transactions to the builder, and the proposal will only accept those transactions if they are included or the block has been full, right? So for this, you do require some sort of multi-proof to make sure that, hey, the transactions are actually included, and then consensus layer client can do the validation. So what's the downside with that, right? Downside that we just like there's more timing, because now as a proposer at the previous slot, you do need to send the transactions. You want to send the transactions during the previous slot, so you need to figure out what's the timing for that. And now the proposers also need access to the mempool, to the execution layer state. There's also some latency complexity here, just because like now it may take longer to propose a block, and then yeah. And then you can also have like, this is like a poor man version of just like censorship, like filtering. Basically like proposer, you just monitor the mempool for like the top N transactions. That's based on gas fee at the given time. And then when the relayer reply, the relayer also have to show a proof that, hey, this top N gas transaction are included unless that the gas is at this price at the given time, right? So we don't really try to force transactions inside, but we just want to make sure that the top N transactions are actually getting in. And then here we're assuming that, okay, if someone's doing censor, someone will probably use a higher gas fee and stuff. So it's not ideal because you kind of loses like this inclusion control, but it's probably easier to implement. Then there's also like ideas like censorship oracle. You can introduce like a new actor to produce censorship, kind of like relay monitor. And now as a proposer and maybe boost, when I receive a header, I can ask this oracle, this new actor, be like, hey, is this a censor one? If they reply yes, then I won't use it, right? But then again, you're putting trust on like a new actor, and that's obviously not ideal because who is gonna monitor the censorship oracle? And there's always that problem. So there has been a lot more research going on, which I'm really happy to see, right? Vitalik posted a research a couple of weeks ago on just like how do we constrain builders without bringing block proposer burdens to the proposer. There's ideas like using block prefix and stuff, and I highly recommend you to take a look at that. And then there's like from Barnaby, I think it came like last week, which I haven't had time to read it. It basically enforces like proposal commitments on chain, and then I think that's very neat. I definitely want to take a look at that very soon. So what are the takeaways, right? I think the takeaway with this is just like it's important to figure out like who can censor and then who can figure out the censorship, because there is so many actors in the picture. There's proposers, there is MEV boost, and then there's also the relayer, right? It's important to figure out like who does what. And then I do think like we need to leverage the Builder API a lot more, because the Builder API is probably the best thing we have today. It's the best defense. We use Builder API a lot more. We can like provide more ways to basically organize defenses against censorship, such as like inclusion list, block prefix. And then there is like a spectrum of solutions, and then out there which we're thinking. But the simplest solution typically has like more trusted assumption. So I'm not sure if that's the way that we want to go. So some final thoughts. I think like for me, I think censorship resistance should be the highest priority aside from scaling and withdrawal. Like what is Ethereum if 50% of the transactions are censored, right? That's something that we have to ask ourselves about, right? And I do think the hybrid PBS is basically our best toolbox to defend against that, because it allows fast iterations. And then before we enshrine into full protocol PBS, then we kind of lose this step because everything will be hard-fork based, right? For hybrid PBS, you have the Builder API, then you can play around with that, and then we can figure out like what works best and what doesn't work best. And then I know like people that have been working on hybrid PBS, such as Matt Boost, Relays, Builders, they have been getting a lot of like bashing and stuff. And I don't think it should be that way. I think we should be like working together as one team and to basically advance this censorship thing forward. So yeah, definitely shout out to all the teams that have been working on that. I mean, they are the real heroes. So yeah, that's all I have today. Thank you so much for having me, and yes.
Thank you, Terence. We have some questions for you after your very interesting presentation.
Thank you.
Hi. So regarding latency
yeah.
The numbers you showed were more or less the same as Danny's in the first day. So if you have 50% of the network proposing through relayers, and 50% of the orphan blocks are coming from relayers, I would have taken that as a sign that latency did not matter. That would be the expected.
Yes, but I do think that we can do better from the orphan point of view, right? Because now, if you look at like 20 blocks gets orphaned a week, if let's say you just have 10 blocks that get orphaned, then it's probably better than 20 blocks that get orphaned, right? It just I'm coming from more like the orphan's perspective, because when something orphaned, then it's obviously not ideal because the transactions should be included, and there may be some UX concerns there, right?
Hey, Terrence, thanks for a super informative talk. Can you say a little bit more about the 3 relay faults that happened recently? Like, how were the malformed headers or payloads generated, and like, how was that mitigated? How do we prevent that in the future? Right, I would say like the relay landscape, there's still a lot of work to do there because they need more testing, they need spec tests, they need more end-to-end tests. And in terms of the fault, right, the first fault is flashball, and then they fail to marshal the deposit. And at that point, it's too late because someone already submitted the header and stuff. They already have the signature, so there's not much you can do there. But then they fail to marshal because they did not test the payload with a full signature embedded. And the second fault and the third fault are basically the second incident and the third incident are basically the same. And I think the block relay the block rock relay did not validate the payload, which is what they're supposed to do. They're supposed to make sure the payload is validated before they pass it to the proposal, but they just did not validate. Yeah.
Hi, Terrence. Thanks for the talk. I was curious about the out-of-protocol CR lists and the proofs of transaction inclusion. Have you done any research into it? Is it practical? Like, would the builders or the relayers be actually able to calculate the proofs in time?
Yeah, that's something still under research. I think like Chris from Flashbox does just open a PR, so I need to look at it. But high level, I think like how it should work is just that, say you're proposing a slot N, at slot N-1, you have access to the mempool, and then you see some transactions that get filtered. You basically, at slot N-1, you send those. You basically present those transactions to the relayer, and the relayer will also present those transactions to the builder, and then the builder will essentially build a block, just include those transactions real quick, and then send it back to the relayer. And then, so at the end, after the signature is done, when you get the payload, right? They can include like a multi-proof to basically prove that the signatures, to make sure that the transactions are indeed are basically indeed included in the payload. Yeah. I don't know yet. That's something still under research. Yeah.
Hi, Alex Mead, Coinmetrics. Thank you so much for your talk. Really loved it. Just wondering if you would comment on your opinion about maybe non-public relays. Do they exist? Is this a possibility? Just wondering.
As for now, I don't know any non-public relay. I only know the 7 relay that was presented in mvvboost.org. And I also think that if there is non-public relay, it's probably hard for us to know, just because if Coinbase is using a relay there, it's tracking MEV, they're not open to public. I mean, that's not something that we can easily find out.
Why do we think that proofs help in that, like what he was talking about before, proof of inclusion of transactions? Why can't you just, if the things that are not included, once you see the actual payload, disconnect from the relay? Because I mean, the relay, even if there is a proof, could always just not release the block, or the block could be invalid, or there could be all kinds of faults that make the proof kind of meaningless. And what you end up doing is anyway disconnecting from the relay in either case. So just, can we just make it simpler on ourselves and just, you say, please include these transactions. If they don't, you disconnect from them, and next time that won't happen.
No, I think, I mean, I fully agree. I think that's possible, and I think there may be a better solution. Yeah, I think, yeah. Interesting.
Hey, apologies if I already missed this before, but you said that 50% of the network is making use of MEV Boost. Do you have more like fine-grained numbers in terms of like whether or not like what the numbers of institutional stakers versus like home stakers. I just know like in the institution that I work at, there are security considerations. MEV Boost is sort of like a centralized actor at the moment.
Yeah, there is a site for that. I'm happy to share with you after. But yeah, there's a site that actually actively track, like, for example, Lido, Coinbase, Binance, like the top 3, like just like what relays are they using and stuff like that, and what percentage for each relay. Yeah, there is active tracking on that, but I don't have the data in the slides. Sorry. Yeah, but there is a site for that. Just one in the front.
The last one, that we are out of time, please.
Thank you, Terence. Given all of this, a validator that's deciding whether they should run MEV Boost or use MEV or not, what would be your advice to them?
I would say this is a hard question for me personally, and then me and my team have different debates. I think for now, it's too early to be using this type of technology unless you know what you're doing, just because we don't have any like public infra out there. I will give you an example, just like, for example, for the second incident, right, when the block rod relay has a bug, it took them 6 hours to turn off the relay, which they could turn off right away. But as a public validators, like, we don't know, right? I don't have the access information, be like, hey, there's something wrong. I basically need to shut up MEV Boost. The best thing can do, people can go to Twitter, but I'm not sure that's like the best like media for this type of things, right? So I would say wait. Yeah, that's my advice.
Okay, the last one.
Last one. Sorry.
So you mentioned at some point that if you can't reach the relayer, your execution client, the consensus client will reach out to your execution client and build your unblock. It'll default to that. So that makes sense if you can't get the header right. But you mentioned there were 2 situations. Yeah. One where you sign the header and return it, and then you can't get a receipt of that. Is that not a slashing risk?
No, you cannot get it right. So once you sign the header, you basically pass the header to the relayer. You don't want to use your local block anymore, because now it's a slashing risk, because now you're signing 2 blocks.
So you don't default to building your own block in that situation?
No.
Okay, I misunderstood.
Yeah.
Good.
Right.
Thank you very much, Terence. Amazing talk. And thank you all of you for the so interesting questions. We are ready for our last talk of this morning. And the next talk, it's about reducing Beacon chain bandwidth for institutional and home stakers. And please, an applause for Adrian Manning from Australia and Diva, that I'm surprised to say, that is Colombian.
Cheers, thanks. I'll just give a quick intro. So my name's Adrian. I'm joined with Diva. We're both from Sigma Prime. We work on the Lighthouse client. So we're going to be talking about reducing beacon chain bandwidth for institutional and home stakers. And I'm going to leave it up to Diva, who's a Bogotá local and our peer-to-peer network expert, to kick us off.
Hello, is this on? Yes? Hello, everyone. First, sorry if I'm very nervous. This is my first talk. So yeah, let's get started. Okay, so first thing that we need to check in order to analyze how to reduce bandwidth for institutional and home stakers is what does the bandwidth look like right now? So we are going to be looking at data from Lighthouse. Like Ash said, we work on Lighthouse. It's one of the production beacon nodes. There are many others. Teku, Prism, Nimbus, Lodestar. We are the second most popular one. And while the data we're going to be looking at is Lighthouse, we are certain that this applies to any other client across the network. So have that in mind. First thing to notice is that bandwidth associated to a beacon node is proportional to the number of validators it has attached. You can see that it increases when the number of validators goes up, but then at 64 validators, it stays more or less the same. 64 is going to be a really important number in this talk. Ash is going to explain further why and why it's important. So yeah, we need to remember simply that we are going to stop at 64, and this is where bandwidth is going to be more or less stable. Now, if we look at how many validators does every beacon node on the network has, we're going to have like main three groups. We're going to have those that don't have any validator attached, only simple beacon nodes, node staking beacon nodes. Now we're going to have those that we are going to call home stakers, which have less than 10 validators. In this graph, you're going to see a very big bar. That's the one with 0 validators. I hope you can see it. Those are a very big chunk of the network, almost 60% of the network. Then we have those that we call home stakers. Most of them have just one validator. And then we have those that we call institutional stakers. Those are the ones that have more than 64 validators, which is the big bar at the end. Now, why do we care about bandwidth to begin with? So there are a couple of downsides of high bandwidth. The first one is, of course, an increased cost. This cost comes from running, for example, in the cloud, where you're charged for data transfer. And it's also a matter of diversity, because this means that you're only able to run a full node in devices that support processing all the data that you're receiving from the network, and for people that are able to pay for the services in which these nodes are being running. I see a few devs here, my colleagues, for example. We know that there is going to be an upgrade to the network that is going to bring a big increase in bandwidth, like a lot. So we need to start tackling this problem right now before this happens. That's another big reason why this is important. Also, another really important reason is when we say, for example, a diversity problem, the truth is if you are, for example, a home staker and you're running your beacon node with your single validator attached, and then your brother or your sister starts playing video games, then you're going to have a bandwidth spike, and you might lose attestations. You might miss attestations, blocks. So basically, you're losing money simply because very short spikes in bandwidth. So yeah, we don't want that. Now let's check where is the bandwidth coming from. For the sake of this talk, we're going to separate protocols between discovery and non-discovery. So why is that? Because discovery has its own transport, its own encryption, it's over UDP, whereas all the libp2p, we're going to call them libp2p protocols, they're over TCP. We have gossip sub and the request response. The one we are going to be focusing mainly in this talk is gossip sub. So now that we have this separation between, let's say, discovery and not discovery, let's check where is the bandwidth coming from. This is what the bandwidth, total bandwidth, looks like for one of our nodes for the last couple of days. So is it discovery? Is it libp2p? What is it? So now we have two graphs. The purple one is going to be discovery, is all the discovery bandwidth. And the other one in the bottom is the libp2p bandwidth. Now forget about the scales. This is just like a not very sciencey analysis of the shape of the bandwidth. So I guess we can more or less agree that bandwidth has the shape of the libp2p one, whereas discovery is, well, is very negligible, as we will see. So the total bandwidth is around 250 kilobytes per second. Is it better like this? Yeah? Okay. About 250 kilobytes per second. Then we have libp2p, which is around 200 kilobytes, and then discovery, which is between 40 and 60 kilobytes per second. So for the sake of doing analysis over bandwidth, discovery is really not important. So we're going to focus on libp2p. So I was saying we have gossip sub and request response. We're going to focus on gossip sub. So in gossip sub is a publish subscribe system protocol. We publish messages to the network. Those get disseminated to other peers. And we receive messages to subnets, or to topics to which we are subscribed. We have large amounts of data, and those we split between subnets. Again, here we have 64 attestation subnets, which again, H is going to be talking further in a moment. And then we need to think how many subnets are we subscribed to, since this is the reason why we get so much bandwidth. And the reason is that right now, each beacon node is subscribing to one subnet for each validator that it has attached. And yeah, well, subscribing to a subnet means a lot more of bandwidth. So a very simple example of how gossip sub works. Gossip sub has a lot of parameters, but one that we care a lot is the mesh degree. So this example is the 3 mesh degree. So we are going to start with our guy in the middle. That one, I hope you are seeing the red circle, just right in the middle. So this guy has a validator attached. It's going to publish a block. So it's going to pick 3 peers. It's going to disseminate the message. And then each peer is going to do the same with some other 3 peers. And so on, and so on. So if you think about this for a moment, you're going to realize that it's very likely that a node is going to receive one unique message a lot of times from very different nodes across very different paths in the network from the source to themselves. Okay, so why do we like gossip sub? Or why do we like the way we do this message propagation? So it makes for a very robust network in the sense that we are sure that if we publish a message and we have this kind of topology, the message is going to reach all other nodes in the network in a timely manner. We also know that we have low message latency. That means the time that is spent between the creation of the message in the source node to when you receive it is not very long. And this is, as I was saying, because of lower paths, smaller paths, lower hoops. But then again, we have a lot of duplicates, and this redundancy results in high bandwidth. This is a graph that we have for nodes. So this is like real data for the gossip sub duplicates. Now, this is going to be weird, but I'm going to ask you to focus on this number, the beacon block. So we know we need to publish one block each slot. So we know for this topic we're supposed to receive a single unique message. However, we are getting 6 or 7 messages across the network. That means an amplification factor of about 7. So imagine what happens if we were able to reduce that kind of duplicates. That's like a huge, huge gain there. Okay, so a summary of the current state. So bandwidth is proportional to the number of validators a node has. H is going to speak about how we intend to tackle this. And the other one is the high amplification in gossip sub. How are we going to do to reduce duplicates without harming the network? So I'm going to leave H to continue this talk.
Thanks. Cool. Yeah, thanks, Diva. So I'm going to try and have a crack at explaining how we can potentially reduce some of these. So I'm Australian, and I can see a few Australians in the audience. And I think they'll agree with me that we have terrible internet, like ridiculous internet. I run a validator at home, and someone that watches Netflix in another room causes me to lose attestations. So as a disclaimer, I have a personal vendetta to try and actually reduce this bandwidth so that I stop losing attestations. Yeah. So there's probably two solutions we have to these kinds of problems, which I just want to kind of briefly touch on and give you a feel for what we're trying to work on. One of them is called minimizing topic subscriptions. So let me try and explain that if you haven't already covered some of this kind of stuff before. So a validator in an epoch needs to publish some messages on these things called subnets. In order to do that, you need to have peers to be able to publish those messages on those subnets. Now, the problem with this is that peer discovery is a slow process. It takes a while to actually find some peers. And it's even harder to find a peer on a specific subnet that you need to publish an attestation. So the problem we've got, essentially, is that we need a stable set of peers that exist on each subnet so that we can find them easily when we need to publish a message. So it's not really an easy problem to solve. The way that we currently have this solution, I guess, is that every time a validator is attached or sends a message to your beacon node, that beacon node is required to subscribe to one subnet for a very long period of time. It's about 27 hours or 256 epochs. So what that means is the more validators you have attached to your beacon node, the more subnets you need to subscribe to. And subscribing to a subnet means that you have to get all of the messages on that subnet, you need to verify those messages, and then you need to send them on to other peers. So you're doing this, that's a lot of bandwidth and a lot of processing. So essentially you're supporting the network at the cost of bandwidth on your node. So you're kind of being like a good actor. So there's a number of downsides to this approach. One is that it's not enforceable. So what that means is you as a beacon node, you can essentially lie to us and you say, oh, I don't have any validators, even though you've got like 2,000 attached to you, and you just don't subscribe to any long-lived subnet, so you don't consume any bandwidth. So you're kind of incentivized to do this, and there's no way that any other node on the network can tell whether you're lying to us or not. The next thing is potentially our subnets are oversubscribed. We actually have quite a large number of beacon nodes on mainnet today, and when we originally designed this kind of process, we didn't really realize how many nodes would be participating in the network. So potentially we have more nodes than we need on each of these subnets. So that would lead us to think that we have excess bandwidth on the network that potentially we can remove. So the idea that's being proposed is, why don't just every single beacon node on the network subscribe to one or many subnets? There's some benefits to this, but the general discussion is in this specs repo as an issue. So what would the bandwidth graph look like if we did this? If one beacon node was subscribed to one subnet, rather than having it being proportional to the number of validators attached to you. You would then get this green line on this graph, which hopefully everyone can see. And that green line sits at around 500 kilobytes a second at the moment from what we've measured. So essentially, everybody on the network that has a validator wins in this scenario, except for those that have one. So sorry for the people that only have one validator in this room. You guys then have to, your bandwidth will increase by about 500 to 100 kilobytes. The other benefit that we get from this, so from a quick scan that we did of the DHT or the current nodes on the network, we found that 57% of nodes apparently don't have any validators attached to them. So they're either lying to us or they actually don't have validators attached to them, and they're not participating in any of the subnets. So if we do transition over into this state, they actually have to start participating and helping out, and it lowers the bandwidth for the institutional stakers or the ones that have high number of validators. Yeah, so essentially all the beacon nodes will now contribute to doing to helping with this subnet stability. So it kind of sounds pretty good that we get a massive reduction in bandwidth, but there is a cost, and the cost is what is the density of nodes that you can find that exist on these subnets. So if no one was subscribed to there, we wouldn't be able to find those peers in order to publish our messages on these subnets. So we still need a decent density so that if you just randomly look through the peer set, you can actually find nodes on those subnets and kind of hold on to them. And so this graph here is a distribution of the current density and what the density would look like if we switched to having one beacon node per one topic. So at the moment, it looks roughly like 8%. So you randomly pick a node, there's an 8% chance that it's going to exist on any given subnet. If we switch to one beacon node per one subnet, it drops to about 1.5%. which is 1 on 64, as you would expect. The benefit of that is that it's configurable. We don't have to say 1 beacon node, 1 subnet. We can say 1 beacon node, 2 subnets, 1 beacon node, 3 subnets. So we can adjust that kind of differential. And whether that's feasible is dependent on the number of nodes on the network, so that's something we need to measure. But the benefits that we get from this is essentially for the institutional stakers, which represent roughly like 10% of all the validating nodes on the network, their bandwidth will drop by about over 90%, which is kind of handy. And as I mentioned before, everyone that has more than one validator will have a reduced bandwidth. So fundamentally, we're talking about, do we need all of these nodes on the network to support these subnets at the cost of the huge amount of bandwidth that we're currently using? And so potentially not, and it's customizable. The second thing is it's also enforceable, because we would tag a beacon node's node ID to a subnet, and so when we connect to a beacon node and it's not subscribed to that subnet, then we know that it's being naughty or lying to us, and we can kick it off. So we actually have the enforceability property. Yeah, so that's one solution, and that's kind of a low-hanging fruit. It's kind of easy to do, and we get substantial gains. The other thing that Diva was talking about is message amplification in gossip sub. So if there's anything we can do about that. The idea that we want to try and push forward is a concept called EpiSub. So gossip sub is a protocol that exists in libp2p, as Diva was mentioning, and the libp2p guys, which is kind of run by Protocol Labs, have had a evolution stage of gossip sub. They've talked about EpiSub for quite a period of time. They've done a bunch of research, in particular Viso, or Dimitri, who works for Protocol Labs, has had this kind of vision for EpiSub for a while, but has never had the push or the drive to do it. But now that we're seeing quite substantial amounts of bandwidth, it's probably time we try and realize this thing. So I just want to briefly go over the concept and what it's going to do and how it could help us with bandwidth. Okay, so EpiSub. The biggest problem that we have is that if you have a high mesh degree, as Diva was saying, that means you have a high connectivity of nodes in your network. So every node could be connected to another 10 or 8 other nodes, and then you get huge message amplification. So every time you send one message, most of the network will probably have to download it 8 times. So if you increase that message by 1 megabyte, you're actually increasing it by 8 times, 8 megabytes, because that's the amount of bandwidth that has to be downloaded and then propagated. So naively, you would first think, okay, why don't we just lower the mesh degree? I did try to do that at one point, but as everyone points out, it's not a safe thing to do. We don't really know how the network is going to behave. We can try it on testnets, but the topology or the structure of a testnet doesn't look like mainnet. If we just lowered the mesh degree to 2, for example, a mainnet, you might just not start receiving blocks. So we have to do that with either great care or with a lot of testing. So it's an interesting idea, but we could probably do better. So another idea is to dynamically adjust the connectivity. We also run into a kind of a similar problem, and typically a lot of the people that use our client, they suggest lowering the peer count, which is it's a false. It doesn't quite help you, so that's also not the best solution. So the idea with EpiSub is to try and minimize duplication and latency by making the mesh. It keeps the same connectivity, but making it a little bit more efficient. And by efficient, I mean we're trying to remove the number of duplicates and at the same time either maintain or lower the latency inside the mesh. And the mesh is just a subset of your peers that you're connected to. That's where you receive your messages from. So that kind of sounds like we're trying to win on 2 fronts. We get less bandwidth and higher latency, which kind of doesn't sound like we should be able to do it, but let me explain the general principle, and maybe it makes sense. So the general principle is you're a node on the network. You're receiving all of these messages. A lot of them are duplicates. You want to just start collecting statistics over which nodes are sending you these duplicates and which ones are sending you late duplicates. And you'll end up having some distribution of the number of duplicates you get and the latency. So it could be that Paul over here in the front constantly sends me some late duplicate 3 seconds late, whereas Sean's sending it to me straight away, instantly. So I come up with essentially a choking strategy is what we call it, where we look at all of the distribution of people sending us duplicates and the ones that are late or the ones that have lower latency, and we send a message called a choke. So in this example, we say, I'm going to choke Paul because he is sending me late messages all the time. What the choke message does is it indicates to Paul to no longer send me these messages over the mesh. Instead, he does a process called gossip, where he just sends me like the message ID, which is a much smaller thing. So over time, eventually, based on your choking strategy, you should have a more efficient mesh where you're only receiving the messages with a lower number of duplicates, maybe from just 1 or 2 peers where the rest of them are choked, and you still receive gossip from them. So if the 2 peers that you have in your mesh are slow, and the other ones that you have choked are started sending you message IDs before you send them in the mesh, we have an unchoked message. So we can unchoke them and put them back into the mesh. So ultimately, the idea would be is that you're dynamically changing your mesh and what peers are sending you messages and how fast they're doing it in order to try and make it essentially more efficient. Hopefully that makes sense. I can take questions afterwards. So does this work, I guess, is the question. There's been some preliminary simulations on this. As I mentioned, Viso from Lip2P and Protocol Labs has done some work on this. He's built a generic simulation for the Go version of this with 250, 500, and 1,000 nodes. And so this is with a mesh degree of 6, so there's roughly about a 6 times amplification if you look at the messages in these simulations. But pretty much in all of the simulations, what this graph is showing you is that you get roughly a 50% reduction in the duplicates from Episub. Now, as I said, there's a choking and an unchoking strategy which are left somewhat generic, and I think we can tune this to be significant, especially if we target it for the Ethereum network. I think we can get better versions of this, but at face value, it looks like you can reduce the duplicates by 50% just by adding these kinds of messages. The next thing we probably should talk about is latency. I kind of suggested that we could get reduction in duplicates and reduction in latency. The initial results that Viso has completed in his simulation seems that the latency increases. So on the left is gossip sub latency distribution, where the buckets are like milliseconds since you receive the message, and on the right is Episub. So we receive more messages with higher latency in these simulations. But as I was saying, these are somewhat generic. The topology of these does not look like the Ethereum network that we have, and these can be highly tuned to what we need. There's a lot of research work going in there. There's a few people in the audience where I think that I've promised results for a mainnet version of this. So us at Sigma Prime, we've built essentially a production version of Episub inside Gossip Sub. The advantages are that it's backwards compatible, so we can release it in our clients. It'll work existingly with every other peer and every other Gossip Sub node on the network. But if there happens to be another Episub node on the network, we can start getting this bandwidth minimization. So the fact that it's backwards compatible is super handy. We can kind of just release it whenever we want. We're also working on a mainnet simulation so that we can actually simulate the bandwidth that exists on mainnet and then apply Episub and then get essentially more specific data that's more robust in how we can actually apply this to what it would look like on an Ethereum 2 mainnet. We'll publish results from this very soon, and if you're interested, just let us know. So the title of the talk was reducing, if I can remember the title of the talk, was reducing bandwidth for institutional and home stakers. So if you're an institutional or a home staker and you came here being like, how do I get all these bandwidth gains? What do you need to do in order to get a 90% reduction? The answer is nothing. You just have to wait, we'll release it, maybe run a Lighthouse node, and hopefully, yeah, we'll be able to reduce the bandwidth. But that's the end of our talk. Thank you.
Thank you very much, Adrian and Diva. We have some minutes for questions. If you want to ask some, we have from.
Great talk, guys. Is this something that's backwards compatible, meaning that clients can gradually roll this out as time goes, or is it something that we all have to upgrade at once?
Yeah, you.
So here we're handling basically protocol versions. So we can run against nodes that are Episub compatible, and if they're not, then we're just going to run Episub version 1.1. So yeah, that's what we mean with that.
Yeah, we add a protocol ID into the Gossip Sub, and so when you connect to a peer, you can identify which protocols they support. If they don't support Episub, you don't choke or unchoke them. If they do support it, you can choke and unchoke. So it works perfectly with 1.1 nodes.
Yeah, I was just wanted to ask, why do we want to reduce bandwidth for institutional stakers? Like, isn't it kind of a nice property that there is no economies of scale, at least if if it's enforceable that they have to subscribe to things. It just seems like, I don't know, it's weird to me as a concept to shift the load from institutional stakers to like normal Beacon nodes or like, I don't know, home stakers, even if it's like a little bit, but just yeah, it generally seems like we want those, the lack of economies of scale.
Good part of this is the part that Age mentioned about being enforceable. So having 60%, almost 60% of the network being nodes that don't have any validators, we're not so sure that's true. Those might as well be institutional stakers. So the truth is that this is more like about being fair across the network. So it's more about that than targeting something that is going to be better for institutional stakers. It's just that they happen to get more gains because of this.
So I know with 4844 we're going to be exploding our bandwidth costs. I was curious if you guys knew if that scales with the number of stakers you have, or number of validators you have.
So just the question is that we're going to increase the block size in 4844, and how that applies with here? Like,
if that scales the way that under current gossip sub our bandwidth increases with the number of validators you have, I was curious if that was the case for the increase in 4844 as well.
Yeah, it's not. So the bandwidth increase is due to the subnet subscription. When you increase the block size, everybody feels that because everyone subscribed to the block topic. Yeah, so that's felt uniformly.
Here, the part that matters for what Mark asked is mainly the amplification factor and not that much how it behaves regarding the number of validators. So since we have an amplification factor of about 6, so now with this improvement, we're going to have huge block sizes, which if we continue doing things the way we are going to be sent across the network 6 times each block. So that's insane. But yeah, so it's related more about duplicates, that part, than the number of validators for each node. Is that answering the question?
Sure. Yeah, just a quick one. So you showed that bimodal distribution where there's a lot of one validator nodes, and then there's that 60% that were just regular full nodes, like not validators, and then the institutional nodes with like more than 64. So that I understand how the epi-sub like helps everyone, and it like helps the home staker, helps the Netflix problem. For the institutional stakers, they're all running like data center nodes anyway. So I don't understand as much how the like subscribing to fewer like gossip subtopics helps.
Yeah. So I think this is a very similar question to over here. So I think fundamentally we were looking at as a whole, the network may be consuming more bandwidth than we need to be. Depending on how you build your client, you can be clever about which peers that you connect to. When you have, so at the moment you have these institutional nodes, right? They're not just institutional. Some people, there's usually a parameter I think in most clients which is called subscribe all subnets. So you can, even if you have one validator, you subscribe to all the subnets, and the reason you do that is because you get some benefit from seeing all the attestations. You get a slight increase in performance. So it's not necessarily just institutional people. But the institutional, I forgot my train of thought. No, I forgot what I was saying. I did have a point. Maybe
part of what Edge was saying is that, well, subscribing to a subnet, we also advertise that we are inside the subnet, inside Discovery. So that means that we need to find peers using Discovery that are useful for us. So one strategy that people who have the bandwidth for that use to be sure that they have publishing all in time and everything is timely is subscribing to all subnets regardless of how many validators they have. this is what Edge was saying about maybe it's not exactly true that all nodes that have more than 64 subscribed subnets actually have more than 64 validators attached to them.
Yeah, sorry, I remember my point. My point was that we have these institutional stakers or people that are subscribed to all the subnets, and they become more valuable than every other node on the network from a client perspective. If you have peers that are connecting to you, and one is subscribed to just one subnet, and you have another peer that's subscribed to all 64, you're more inclined to be like, I want to keep a peer connection to that guy because in case I need to send a message on one of the subnets, he or she is connected to that subnet. So you're left with like 10% of these nodes are super valuable nodes across the network, whereas everyone else, you kind of just throw them away. They're not all that valuable. Whereas if we transition over to this thing, one, it's enforceable, which is something that we want. Two, we're not entirely sure whether the amount of bandwidth we're using across the entire network is necessary, so we reduce that as I guess maybe a side effect. And the third example is that all the nodes are equally kind of valuable to you. And because we tie it to the node ID, it makes the node ID specifies which subnet they're supposed to be subscribed to. So when we're doing discovery queries, we can actually search more efficiently for nodes on a specific subnet because it's tied to that node ID. So there's a number of benefits. It's not just we're helping institutional stakers. That's just kind of like a byproduct.
The last question, please.
Oh, yeah. Hey, cool to talk to you guys. Thanks. So you mentioned reducing bandwidth and reducing latency to like avoid missing attestations. Something that we've looked at as well is like effectiveness ratings with validators. Can you guys speak which can result in like penalties or loss reduction in rewards? Can you guys speak to how this would help with effectiveness ratings, if it would?
Yeah. Me? Yeah. So I guess the first one is kind of what I introed with. My personal attestation effectiveness drops when someone watches Netflix. So I imagine for a lot more home stakers that are kind of on the bandwidth limit or their upload speed is quite low, like in Australia, and we reduce the bandwidth requirements a lot. Diva said that when you have these peaks in bandwidth, you can miss attestations. You don't publish them in time, and it's not just missed, but you also get penalized if they're late. So even if they still get included in a block, but later you get less, so that lowers the attestation effectiveness. From a lot of the people that use Lighthouse, we've found that there's a number of main reasons that impact the attestation efficiency, and one is bandwidth, and the other one is CPU limitations like processing. So if you're running a node that's overburdened, and the topic subscription is another thing that can overburden a node, because if you're subscribed to a lot of nodes, let's say you have 5 validators attached to you and you have 5 long-lived subnets, you have to get all the messages and you have to process them. So the processing also kills you and lowers your average effectiveness. So if we get that in there, that should, in principle, improve the effectiveness because of the bandwidth and because it lowers the CPU usage of your node.
I have to make this quick. So would it be possible for a node to detect that it's been choked? If so, could it somehow combine that with being dishonest about its subnet count and either grief or otherwise stall its local node graph?
Sorry, I missed the last part.
If it could combine that with being dishonest about its subnet count connection, could it just stall or otherwise grief its local node graph?
So the question is, can a node lie about its subnet subscription, essentially, right? Or fake it? Sorry?
While detecting that it's choked.
Oh, while it's choked?
Choking is explicit. So a node is actually going to know it's going to be choked. We're asking him to stop sending messages to us. It's not... Yeah, I know it sounds similar to what is happening, for example, in strategies, for example, in, I don't know, file sharing, but it's different in the sense that we're the ones asking the peer to just stop sending the messages. So it's kind of a benefit for them.
Yeah. So when we connect to a peer, let's say in this new regime where we have every node has to subscribe to a topic based on its node ID, we can look at its peer ID, but let's say it's node ID, we know that it's supposed to be subscribed to, let's say, topic 3. The way that when we connect via Gossip Sub, they should send us subscriptions about what it's subscribed to, and if it's not subscribed to that, we know that it's being malicious or faulty straight away, and we can just disconnect it. There's technicalities where it can say that it's subscribed, but then won't let us. So the next phase of the thing is we try and create a mesh network. So if we're connected to, let's say, 100 peers, we only really form a mesh with the mesh degree, with like 3 of them. So in principle, they could always just say, no, you can't go on my mesh, you can't go on my mesh, I'm full. So that's one way to kind of grief us. In that scenario, they still have to forward us Gossip Sub messages. There's a small mechanism inside Gossip Sub that is called Gossip Sub scoring. It's introduced in 1.1, which somehow mitigates attempts to mitigate censoring, so where you just say that you're subscribed but you do nothing, and the whole network essentially tries to kick you out of the mesh. In terms of while being choked, we only choke people that are in our mesh, so only people that are subscribed, and then once they've grafted with us, so we form this mesh connection, which means they have to be subscribed, they have to be sending us messages. If they're not sending us messages, 1.1 scoring will kick them out, and then we choke or unchoke them. In order for them to be malicious and try and cheat that system, the choking strategy is abstract and can be implemented independently on each node. So you don't know on each of your peers what is specifically their choking strategy. They could just pick random nodes on their mesh and choke people. So I think there is an avenue of security to look in there that hasn't been done yet. But I imagine we can probably solve that with some of the scoring parameters in Gossip Sub.
Thank you very much, Diva, and thank you very much, Adrian.
Thanks, guys.
Amazing talk. If you want to ask more questions, they can contact you outside the room, right?
Hang around as well.
Yeah. This is my pleasure. This is the end of the talks of the morning. We're going back to this stage at 1 p.m. So let's have lunch, guys. Enjoy your food. See you at 1 p.m.
I didn't hear anything. How are you? Woo! That's right, okay. I am Crypto D. I'm a medical doctor. Actually, I'm working with Bankless DAO in Spanish. Also, I work for Espacio Crypto Podcast, and I'm actually working with Ethereum Mexico in the core development of the community. I'm very excited about the three themes, the three talks that we are going to have. And it's a pleasure to me to present Cayman, that is going to talk about Lodester, metric-driven development. He is an Ethereum core dev. He's working actually in something that is very passionate for me, because I think that Ethereum needs, in the role of this censorship-resistant blockchain, to be like a lot of nodes, a lot of validators. So they are creating like this JavaScript-driven full project. So sorry, I'm very excited. Just give him a warm recipient.
Hello, hello. Okay, so today I'm going to be talking about Lodestar and metrics, and really just our story and how we've developed Lodestar over the past 3 years. So about us, my name is Cayman. I work at ChainSafe. It is a great company. We're hiring. We basically build blockchains. We have a whole bunch of layer 1 projects. Lodestar is one of them. But if you are interested in getting into core development, we're a really great place, great culture. So Lodestar it's one of these projects at ChainSafe. We're basically an ETH2 or Ethereum consensus ecosystem written entirely in TypeScript. We really take the open source ethos to heart. We have all of our meetings, they're public. Everything we do is public, and we really encourage anyone who wants to contribute. We try to help people out and get people involved. A lot of our team members actually started their work on the project through their open source contributions, and it was kind of like a open source to contract to hire kind of a situation. So we really like that kind of ethos. What we're going to be talking about today is specifically our consensus client and how we got from like prototypical kind of code to something that's like production ready, something that you can really rely on, something that doesn't just blow up all the time. So before I kind of step into our story, I just want to kind of do a very high level of what metrics are. I'm not going to go too deep. If you really want to know more, you can like read the docs about these things. So metrics, in our case, we're using Prometheus. Prometheus basically gives you the tools to build time series data for specific elements that you want to track in your code. The kind of 3 main things that you're tracking is either a counter, a gauge, or a histogram. We'll go into kind of some examples of all of these things, but basically what you want to know about metrics are you have some value, something in your code that you're wanting to track, and Prometheus will kind of query your software over time, and you can get a sense over time of how things are changing, how things are moving. And then you use Grafana to visualize these metrics. So a picture is like 1,000 words, so it's basically the difference between like looking at a bunch of logs and then looking at like pretty graphs that can give you a little bit more insight, give you something at a higher level than just squinting. So our story. Basically, we started with really bad, with not very much infrastructure, not very much of discipline in how we tackled metrics or tackled like the data that we track, and eventually we kind of like over time and like through a lot of pain and suffering, we kind of realized that metrics are the way to go. Metrics give you insights that you'll never get just by looking at logs. So really, metrics aggregate a bunch of information and give you the tools you need to make better decisions about how you release your product, what things to focus on, like what are priorities, and they're also just really pretty, so they're cool. So this is a picture from the early days of Lodestar, from the interop lock-in in Muskogee in 2019. And here's our message. Yeah, we're stuck syncing in some P2P issues. We didn't really know what was going on, like why things are breaking. We were looking at logs. Actually, on the other side of the screen here, we're like, we look happy, but it's like, uh-oh, things are breaking. Here's some funny issues that we had. You can see priority low, adding Prometheus monitoring. We didn't even know what we were doing. Yeah, out of memory, OOM, out of memory. It was just like plaguing a lot of our development. Throughout 2019 into 2020, Lodestar was like very much like a prototype, and we ran into the issues time and time again. Like we would have the same thing happen multiple times, and we weren't like regressions that were happening, and we weren't really like learning our lesson. And kind of the turning point was, starting to take some time to really to take the time to build out these metrics and build out these dashboards. So we had a contributor. I think I can save a new world, maybe with peace. Great. And so throughout 2021, we started going really hardcore into adding a bunch of metrics and taking time to think through what questions that we want to answer, what pieces of code are dark, where are we spending time in our software, where is a bunch of memory being spent, really kind of uncovering all of the complexity of this running software. I mean, blockchains are really complicated software. There's a whole bunch going on, and unless you're really tracking key pieces, you're kind of going blind. And now we're finally kind of at a point where for any new feature that we're adding, we ask for metrics. So it'd be very important to track the retry behavior, meaning add metrics for blank, blank. So that brings me to metrics-driven development. Really, the key thing that we've learned is that every large feature should be documented with metrics. So if you are adding, in the case of a retry mechanism, you're adding some new feature, you need to make sure that it's actually working. And the only way that you can, or maybe not the only way, but the really great way of doing that is being able to show that visually. Being able to show, okay, our cache is now bounded. Let's see that in the metrics. Let's see how that cache is growing over time. Or let's see how many times the retry mechanism is actually being activated. Those are the sorts of things that you really only can find through these graphical methods, through these metrics. You're going to have a really hard time looking at the logs for that. The other thing about metrics-driven development is that any deployed software that you use, you need to be monitoring it very carefully for regressions. So look here, this is the process heap increasing over time. And this is a comment from Lion. For the last 2 days, the leak is clearly visible, an impact of 75 megabytes a day. Yeah, so that's going to be a problem if your blockchain if it's just increasing at 75 megabytes a day continuously, you're going to run out of memory. And we were able to catch this issue before we actually cut a release. So it makes your release process a lot better. Here's another example of a regression. We deployed a version of our software and we saw the cache size grow. It's like, uh-oh, is that a bug? Is it okay? Well, we only actually caught it because we're tracking these things. You probably aren't even going to have a log that's going to show you your cache sizes. So unless you actually measure this, you're going to be blind. The other great thing about dashboards and about metrics is that it lets you correlate different pieces of the code to find out where the problem is. So here we have you can see a bunch of different graphs kind of all at the same time and see, okay, something is affecting the event loop lag. I can see at the same time the active number of handles is growing, the number of requests is growing. So you can kind of solve the mystery in a way that you're not going to be able to do in the logs. Another great strategy is using different versions of your running software. So running like a staging version of your software against a production version or against several recent versions, and being able to overlay data on top of one another, and being able to see, okay, well, it looks like our beta version is using a whole bunch more memory than our unstable version. So being able to kind of compare and contrast, it gives you the tools to do this. And so just kind of like drilling down to a few tips. These are very, very practical kind of tips. Don't abuse the histograms. So I said there's 3 different types of metrics. Just when in doubt, you use the simplest tool possible. Histograms are really only used if you're wanting to see the kind of the distribution of something. So maybe looking at request timing. Maybe you'll want to see like, all right, certain requests are happening very, very quickly, but then others are happening kind of longer. So the classic mistake with histograms is using a label that's unbounded. So if you had a metric that was tracking something per peer ID on the network, well, you might have thousands of peers, and if each new peer is going to be using a new peer ID, it's going to blow the metrics up, and it's going to affect the performance of Prometheus, and you're not going to be able to run the queries that you want to run. Oh, that was tips. Oh, so how do you know which metrics to add? So I showed some of these pretty graphs and everything, but like in your software, how do you know what you want? What do you want to track? So really, what you want to do is think about questions that you couldn't ask otherwise. So a really good example is the size of your internal caches. Another thing you can think about is like, if this feature or if this part of the code would degrade or explode in the kind of bad case, that's a prime candidate for adding metrics around it. And then really just like keep asking questions, and then it's like if you have the data to be able to answer the question, you're good. But otherwise, keep adding metrics until you can answer those questions. So some examples that we've kind of come across. How often are our streams being reset? How many peers do we have? These are the kinds of questions that the metrics can help. And so I'm going to show you just a live demo or a live example of our dashboards, and we can kind of run through some things. And if anyone has any questions about it while I'm going through it, we can do that too. Okay, so this is our dashboard for our fleet of beacon nodes and validators. This is kind of the high-level dashboard. Right now we're looking at an unstable node, but we can go to like a stable version of Lodestar. So this is running version 1.1. We're on the Gurley network. We're synced. It looks like it got restarted about a day ago. Some interesting things, I guess, peer count is looking good. All right, there's nothing, everything looks stable there. We track different types of peers, inbound, outbound, and for us, we really care about the number of peers that we're going to be receiving messages from kind of continuously. Those are our gossip peers. So the number of mesh peers on our core topics, staying about 6 or 7. Which is good. It looks like we're connected to a lot of Lighthouse nodes and a lot of Prism nodes. And there's another Lodestar out there. Let's drill into something a little more detailed here. So one area that we really struggled with, and where we added like a lot of metrics, is in our gossip sub-implementation. We found through adding a few metrics that we weren't getting blocks on time, and it turned out that we didn't have enough peers who were sending us blocks, and then we started asking questions. All right, well, why are they not sending us blocks? It turned out it was because our peer scoring was too low. All right, well, why was the score too low? Well, it turned out it was because there was a specific part of the scoring that was too low. And so we kind of, you start asking questions, and you can build up, you start building the answers to that. Okay, so what you're seeing here is kind of some of what I was talking about. We have breaking out the score into different components, different parameters that are going into your kind of aggregated score for peers. What we were seeing before is, you'd see a graph where the values are like going down and down and down over time, or they're like very negative numbers. Another really useful metric that we check a lot is things related to the VM, so memory, CPU, and disk storage. So looks like our memory is stable. That's great. GC is only taking roughly 7.5%. Things are looking good. Yeah, I think that's enough of a demo here. So at this point, open to questions, and we're also hiring. So if any of this looks cool or interesting, and you know TypeScript, come on in. Questions?
Hello, and thank you for the talk. So I see that you have a ton of metrics, and I believe that most of them are useful. But do you have some kind of an alerting system for you to be able to know when a metric has gone wrong? Because I think it's just unfeasible to go through each of them like daily or something like that. I think you need some automated way to alert you that something is going wrong.
Yeah, absolutely. So that was something I didn't touch on, but it definitely feeds in. So we use PagerDuty. You can basically set up thresholds for certain metrics that trigger either Slack notifications or Discord notifications, or in the case of a critical kind of issue, it'll call you or text you. Yeah, we do have that set up. And I would definitely recommend that if you are running something in production.
Okay. Thank you. Again, there are lots of metrics. Did you guys develop over time a way to, or kind of a mental model or framework to decide where to put them whenever you have a new graph or metric, instead of, or do you just like decide to put it somewhere and then go back and to make it easy to read or to browse the dashboard? I don't know if that makes sense.
Is the question about organizing the?
Yeah, exactly.
Yeah, so I think you probably have to grow it organically. What we did is we started with one dashboard that grew and grew and grew, and eventually it became kind of unsustainable to have everything just piled together, so we started breaking it apart. The other kind of issue that we had initially is we would create a bunch of metrics, but we wouldn't add them to the dashboard. So there was no actual like visual cue for a lot of it, and so it kind of just went unnoticed. And so one thing we would definitely recommend would be like, if you add a metric, also add it to the dashboard at the same time.
Thank you. The question about storage. So again, too much metrics, Prometheus, or what?
Does it affect the storage? Well, so some of it kind of depends on your architecture of how you're deploying this. Let's see. So what we do is we actually have one Prometheus and Grafana server servicing our entire fleet of beacon nodes. So we have a bunch of different machines, and then we have one machine for these write to things. So it doesn't cut into the storage. We retain for a month.
Quick question: are the metrics relevant for like other EVM chains besides Ethereum mainnet, or is it just like specific to Ethereum mainnet?
So yeah, a good question. So I'd say like maybe, I don't know if it's a half and half, but like half the metrics are like more like for like monitoring the chain, something like a block explorer kind of thing. But I would say like a lot of the metrics are specific to the implementation. So, and those are the ones that are, I think, probably more helpful. Just the internal caches and like timings of things that we're really wanting to get right.
Hi, I wanted to know if you think these metrics are useful for other clients and not just the TypeScript one. And if so, would you maybe consider like, putting them in the public domain so like anybody can see them and apply that to new clients they might be considering building?
Right, I know that other clients do have metrics, and I think like the ones that are more user-focused, those are the ones that look more like a block explorer, and maybe with some like validator, like showing your balance ticking up over time. And I think those are public, and there is an effort to standardize metrics across the consensus clients. So I think some of that's happening. But again, to the previous question, like a lot of the metrics will always be implementation specific.
In terms of roles and in team members, who generally looks at which metrics and which graphs, just kind of to get an idea of which metrics and graphs are useful to which team members, or depending on like the role or the type of work that they do.
You're asking if only certain members contribute to these?
No,
or?
more like the looking at the graphs and the browsing the metrics themselves. Like, for example, there are lots of metrics, so not everybody looks at everything. So, it's more what team members look at what kinds of graphs. Or
Right, so for any of these larger feature pull requests, we have the person who is authoring or kind of owning that feature. They're responsible for making the case that it's correct and that it works as intended. And so they're responsible for looking at the metrics and building that case. And then as far as like our release process, we have a checklist of basic things that we look at before we actually release. We have a testing period, so we cut a beta release, we deploy it to our fleet, and we watch it for a few days, and then after a few days we gather, do the checklist and any other kind of ad hoc things that we're noticing then.
Hello. So following on the question of making metrics between client standard, did you take a look at OpenTelemetry?
Sorry, I couldn't hear that. Can you say that again?
Okay. About the question, following up on making metrics standard between multiple clients, did you take a look at OpenTelemetry? Do you know what's that?
No.
Okay, so in Web2 there is a standard of how to consume logs, metrics, and traces, and it's done by the Cloud Native Foundation to make the same pipeline that you have here more standard in a way that's consumed by other tools as well. Did you take a look at that? I would recommend it if not.
Right. I think that's the standardization effort is to build out some kind of baseline of functionality. Like you can have one Prometheus and Grafana running, and then whichever client you want plugged in here, you kind of have some guarantees like it's not breaking and like it's kind of working. So yeah.
That's exactly what OpenTelemetry does. So take a look at it.
Wow. Why we're not clapping, please? Bro, I think I need like two brains. One, to understand everything that you explained, and another to be explode, right? Actually, as I said, I'm a medical doctor, and I think that all the protocol that we are being is like making all the code like being alive, like setting a heart that needs to beat like everything in telemedicine and telemetrics just to be reviewed and to be like understood. I'm really happy. I'm really happy to be here and to hear about all the depths, all the cores that are here. And I don't know if I don't know this smart enough to understand everything that you already said, but I think that we can make a lot of changes just to make to like other people and other like non so smart people like me, just to understand all this new stuff. So as I said before, I think that Loudster is one of the opportunities for all the newbies that we don't know like all the code that needs to be like to deploy another type of clients. So maybe it's a very great opportunity. So we are going to block everything for the other conferences. So please be welcome.
Gracias. Yeah, Kumavas. Kumavas.
Sorry. A little problem here. Okay, I'm very pleased to present Kumavis. Have you ever heard about MetaMask? I think you, but maybe as I said before, for the newbies like I am, MetaMask is like something that we like remember every time that we think about blockchain and about Web3. But I'm very pleased that Kumavis is going to like to make this like a very high presentation, very high level presentation about not only just to keep your keys in your like paper, just to also get like a client or something like that, just to be in like an evolution of the wallets. So thank you, thank you.
All right, cool. Okay, hi everyone, I'm Kumavis. I founded MetaMask with Dan Finley, and now I run the security research team at MetaMask. Today's talk is The Attacker is Inside, JavaScript Supply Chain Security and Love Mode. So yeah, Love Mode, this is what I've been spending the past couple of years working on. First and foremost, it is a set of security tools for any JavaScript application to mitigate software supply chain risks. So what is the software supply chain? It's everything that touches an application or plays a role in its development. Sonatype has this cool website. It's a timeline of supply chain attacks. And you can scroll through it and see how many they are. And a lot of them are from Python and Rust, but a good 50% are from NPM. They're from the JavaScript ecosystem. So why is JavaScript supply chain targeted so frequently? Primarily because it's really popular. This is from the Stack Overflow user survey. And for self-described professional developers, JavaScript's way at the top. And there's TypeScript and Node.js not far behind. So when we're talking about JavaScript supply chain, we're primarily talking about NPM dependencies. So this is your apps dependencies, your dependencies, your build systems dependencies, any other tools you might be using. You might think that these are your dependencies, just the dependencies listed in package.json in your app, but that's just like an inner ring around your application in part of a constellation of your whole dependency graph. So that's why there's so many node modules in the node modules directory. Okay, so to understand what it looks like when it goes wrong, let's look at the Copay wallet hack. Copay wallet was a Bitcoin wallet by BitPay, and this was my primary case study for designing Lava Mode. So at the time, the end of 2018, the Copay wallet hack, also known as the event stream incident, made a lot of news. An attacker got control of a dependency that was used in a Bitcoin wallet, deployed a targeted attack against that wallet, and stole private keys and digital assets from the users of that wallet. It was, I think, 3 versions of the wallet that had the attack in it were published, so they didn't even know it was in there for a while. Okay, so let's look at the build pipeline to understand how it got in there. Now, so this is a non-custodial wallet, so the keys are in the user's application only. They're not on a server or something like this. So the attack happened here at runtime. That's where the secrets were. That's where the private keys were. But the evil dependency wasn't even part of the front-end application. It was part of their build system. So it actually entered in here, and then it went on the disk during build time and modified a dependency that ended up in the web app. But it could have also happened here at the dependency install time. NPM has lifecycle scripts, so after you install a package, it gets a chance to just run any command on your computer to, finish up its install process or whatever. So Jackson Palmer of Dogecoin said, BitPay essentially trusted all the upstream developers to never inject malicious code into their wallet. Upstream developers being the dependency developers in this case. And yeah, he's right. And it sounds pretty scary when you say it in these terms. And was BitPay being particularly unsafe? Well, this is how we make all JavaScript applications today and most wallets, not MetaMask. So when this attack happened, there was all this discussion. How do we fix this? Should we never use dependencies? Are we giving up on open source and collaboration? What about don't roll your own crypto? Like, how does that fit in? Audit all your dependencies always? Yeah, that's a great idea, but how many dependencies do you have? Hundreds, thousands, tens of thousands? And when you need to make a change, are you going to be able to wait and re-audit all those things? So is there nothing else? What else do we have here? So around this time, I met Agoric and learned of their Endo.js hardened JavaScript tool set. So these are tools for working with untrusted JavaScript. And in the core of it, they have this package called SES. And it gives you a couple things for dealing with untrusted JavaScript. So there's a couple things about JavaScript that make it easy to attack. One is everything is mutable by default. All the built-in functionality and everything. So you can just go in and modify array, prototype, and map and change the way JavaScript works. This can also give you access to objects that are being used like on the complete other side of the application of where you got your attack in. So you want to lock this down. And conveniently, SES provides a function called lockdown that does exactly this. By calling lockdown, you're doing what's shown here at the bottom of the screen, basically calling object freeze on all the prototypes, all the built-in parts of JavaScript. OK, that was simple enough. All right, there's this other problem called ambient authority. This means simply by being able to run some JavaScript, you get access to all the powers of that platform, network access or disk access. So say I have some little package. I'm an attacker. I've gotten a hold of some package that's deployed in my victim's code. Now, this package doesn't do very much. It's just formatting strings. But because of ambient authority, I have access to fetch, to network access. I have access to environment variables, and I can send them home to my evil layer. And maybe there's some API keys or something in there. So just because I get to provide a little bit of code, I get to have all powers of the platform. And that's quite dangerous. So SES provides this notion of a compartment. It puts a little container around the JavaScript and limits access to what that code can touch or modify. So for example, if I have some code that needs to make network requests and it needs to know the current location of the web app in the web browser or something, I can give it just those things and not give it disk access or other powerful features of the web browser. And then I can run my code in here, and it will only get access to those things, as well as the basic JavaScript functionality. And you don't need to know the internals, but I think it's really fascinating. And I'd been working with JavaScript for a long time before I saw how this works, and I didn't think it was possible. So let's take a look. It relies on two weird parts of JavaScript that you may not be familiar with. One is the with statement. With the with statement, first you have an object. It has some properties on it. And you have the with keyword, and then you put the object as the target of the with keyword. Then you have this block. Inside the block, all the properties on the object can be accessed as if they were variables in scope. Well, there it is. It's not particularly interesting, but that's what the with statement does. The next piece is the proxy. If you're familiar with getters and setters properties, it's like that for the whole object and any operation on that object. You get various handlers to intercept what those things do. Now, by combining these two things with the with statement and then a proxy in here, we control all the scope access inside this block. So you have your untrusted code here. It's trying to like get network access with fetch. It'll look it up here. It'll go to the proxy. It'll say, do you have fetch? And your proxy can throw a reference error, return undefined, whatever you want, but it can block that lookup. Another way to write this, which is easier to audit, it may be easier to think about, is with two statements. One here, the inner one, you put the untrusted code here, it's trying to look up fetch. It'll look up inside this object first, and that's the object we gave to the compartment when we said you should have access to these things and these things only. If it's in there, it'll just get it. It'll get whatever value you gave it. If it's not in there, it'll go up to the scope terminator, and that thing just always says, no, you don't get it. There's a couple more things you need to make it safe, but you don't really need to think about the implementation. You can just use this API. OK, so SES gives us lockdown and compartment. And I compose these in LavaMoat. LavaMoat wraps packages inside of compartments and only gives them what they need to run. So that little string formatting package we had before, it won't have access to network, and it won't have access to disk, and other powerful features. How you use it, sorry, it's a little small. It's kind of like this. Previously, you might have run node index for your little server. You replace that with LavaMoat index. But first, you put this write auto policy API, and that will generate a policy file of what the packages are allowed to use. And then you just replace node with LavaMoat and run normally. And it will, at runtime, enforce those packages only get what they need. The policy looks something like this. This is a policy for one package. You'll have a bunch of them in your policy file. This is all automatically generated and works 99% of the time without any additional changes. Here in the built-ins, these are built-in packages provided from Node. We're giving them just exactly what they need. For example, we're giving it just read access from the file system and not write access or anything else. Also giving some global variable access, and they're only allowed to import these packages. So that's just an example. But in order to help you review your policy, we have this visualization dashboard. So there's the list of your dependencies on the left and a graph of your dependencies on the right. The purple node is our application here, our example application. And then all these, this graph coming out of it are all the dependencies and the transitive dependencies. And you can dig in and take a look at what these packages are and what their policy is. And the point of this is to help you prioritize the auditing of your dependencies and review your policy. Because remember, without LavaMoat, this is what your app looks like. Every single package is maximally dangerous. Whereas with LavaMoat, we know that some of these are safe. All these green ones, for example, are not importing any globals or any built-ins. They're only composing other packages. This was a static version in case the internet didn't work. OK, so here's the build pipeline again. Install time, build time, and then runtime on your user's machine. So we have in LavaMoat tools for each of these steps. For deps install, we have LavaMoat allow scripts. This will prevent all these dependencies from being able to run a random command on your computer when you install them. And then you can opt into just the ones you want. At build time, you want to run your build process in LavaMoat node. And you want to add to your build process a plugin for your bundler. So we have one for Browserify. We're working on one for Webpack, for React Native, and SWC Swig. So this is in production in MetaMask. We're protecting tens of millions of users now. So we know this can scale. You can use it too. But we do need your help. It's open source, it's free, it's out there. Find it on GitHub. Try it out, let us know if it works. If you run into a bug, open an issue. If we don't have a plugin for your bundler, let us know. And maybe you can help us with that. OK, thank you very much. This has been LavaMoat.
Thank you. Does anyone has any questions? I see over there. A lot of questions.
They're going to bring you a mic in a second.
OK, thanks. So I actually worked at BitPay on a different team.
Oh, cool.
Overlapping the time of the copay hack. And yeah, like you said, it's not necessarily that that company had bad processes. It's sort of that the whole ecosystem doesn't really have a good solution. Since that time, not only at that company did no one really talk about LavaMoat. I mean, I brought it up because I was aware of it at the time. But externally, any side projects I've been on, I've really never had anyone propose using it. So do you think there's something, not at the technical level, but like at the social level, that we should be doing to make this a more common part of stacks, either across the board or when we're working on applications that deal with private keys specifically?
Yeah, great question. So what processes should we put in place, or what tools are out there? I think a lot of people, let's see, there's a lot of projects that are working on preventative measures like CI flows that warn you if there's known vulnerabilities, or some code scanning to see if there's something funny looking like eval. And those are great and fantastic, and you can use them in conjunction here. Like one example is socket.dev. That's a friend's company, and they're doing great scanning work. But it's all preventative at the beginning. That's not the way the security of your operating system works, right? It's making sure that all your applications are safe. So I mean, I was very surprised that no one else was working on runtime protections. Besides the Agoric folks, which we partner on building LavaMoat. So yeah, I think more people need to just know that there's a solution that exists, and you can actually do something about this.
Hi. So I had a question about the auto policy generation. Can you explain the logic behind that a little bit?
Yeah. So we are using static analysis here for convenience and not for the security layer. Static analysis can be faulty. It'll miss things, and it's generally imperfect. But here we use it to generate the policy, so you don't have to write it all by hand. And then we enforce it with the LavaMoat kernel, which is not relying on static analysis. But yeah, basically what it's doing is you give it your entry point. It's walking through all the requires and imports and walking through your graph. It converts the code to an AST. It looks and analyzes it for references, sees when there's global references, sees when there's imports, and it'll actually follow the imports to where they're used, so it can give you just the minimal things that you need, like only using the read power of the file system instead of the write power, for example.
Hello. I was wondering if you can talk a little bit about like the limitations of LavaMoat, specifically like if even if you grant access to like a specific function or feature to a package, like they can still, I guess, use that feature in a malicious way. Yeah, I was just wondering like what else we should watch out for even if we use LavaMoat.
Yeah, absolutely. So it will look at your modules, LavaMoat will look at your modules and generate a policy. And if it sees that network access is used there, it'll put that in the policy. But if it's something that's not supposed to have network access, then we rely on the user, the security engineer, to catch that. Now, it's most likely you don't have a supply chain attack in your app right now, but you might have one in the future. So every time you change your dependencies, you can just run that thing, generate a new policy, and you'll see the diff of your policy, and that's a lot less to review. Some other things, there is a slight performance impact for compute, but if you're relying on network or disk, which is usually what you're bound when you're computing, then it doesn't make a difference for you.
I think we have a lot of time for more questions. It's me. Come on, it's Kumavis. We need to ask everything.
Hello. It is very cool how you solve the problem of executing insecure code with the with and the proxy. Okay, sorry. It is very cool how you solve the problem with running insecure code with the with and the proxy. And I was wondering if there is any difference with doing it with a web worker.
With a what?
A web worker.
A web worker. Yeah, you can use iframes and web workers, and you can use on Node.js, you can use the VM package. But what those create are what we call realms. Let's see, I actually have a slide for it. Let me check you here. It does work, but it's not very good for backwards compatibility. So yes, when you use, oh, I'm not up on the screen. How do I get up there? So we have a lot of jargon when we're talking about this JavaScript language security stuff, but we use this term realm to refer to like a window frame, and so an iframe is another realm. And they're different in a couple of subtle ways. One is inside of the VM or the iframe or the web worker, capital A array is not the same as the capital A array on the outside. We call this problem the identity discontinuity problem. And it breaks things like instance of. So an array from the inside is not an instance of array on the outside. And so this is fine. You can deal with this problem. But it is really bad for backwards compatibility. And that was a primary requirement for LavaMoat. Because this was not built into MetaMask from the beginning. I built it afterwards, and rewriting the app from scratch was not an option.
Hello, congratulations for your product. Currently, there's a proposal in ECMA TC39, to introduce compartments natively in JavaScript. I would like to know if you guys are behind that proposal, and what do you think about the current state?
Yeah, great. So yeah, we're trying to take some of the things that we built here, like the compartment API, and actually get it standardized into the JavaScript language at the TC39 JavaScript standards body. I'm not up to date on what the status is, but it seems to be finding its way in via the loader API, so that when you load modules, you load them in a special compartment.
Hi, thanks for your talk. I would like to ask if you can share some supply chain attacks that might have actually been detected at MetaMask since you started using it.
Great question. We have not detected any supply chain attacks. The day-to-day battles at MetaMask are primarily phishing. But the problem with the supply chain attack is even if it's more rare, less common, it could take down the whole wallet. And that's why this protective system is so important.
I think we have time for another question.
Yeah, my name is Rogelio Morel from Ethereum Swarm. My question for you is, why not use QuickJS with WASM engines instead of the CES from Agoric?
Were you asking about WASM modules?
Yeah, why not use QuickJS with any WASM engine compatibility?
I didn't catch the whole question, but WASM modules have been designed to be sort of self-contained and not have ambient authority, not have access by default to network and disk. So that is fantastic. I'm so glad they designed those things that way.
Blockchain companies use some WASM engines that have some special add-ons that you can enable networking and file system access.
Sorry, I couldn't understand the question.
Sorry, so there were some engines in the market that supports add-ons that give you connection to TensorFlow, file system, and networking.
I heard some cool things like TensorFlow in there, but I still can't make out the whole question. Maybe you could ask someone next to you to repeat it. For whatever reason, I'm not able to hear it.
I don't know if I'm going to butcher question, but I'm a bit closer. So he was asking about inside WASM or the WASM connections, are there any connections to TensorFlow or what's the last one? File system or networking? All three.
Oh, yes. Okay, so how do WASM modules connect to the powers they need, like disk access and network access? Great question. Much like with the compartments, you have to pass them in and make them accessible on the foreign function list that you expose to the WASM. I'm not a WASM expert, so I can't answer perfectly, but you do have to go in and put them there. They don't get it by default.
I have a follow-up question. Well, not directly related, but we were hacking on snaps over the weekend, and I was just wondering, the interface in which Lava Mode interacts with SES and that JavaScript engine, because no, I mean, just on the high level, I was having a hard time differentiating where Lava Mode ended and SES started.
Yeah, great question. We have these compartments from SES. SES is giving us primarily lockdown and compartments. There's a few other features I didn't cover today. And then I, in LavaMote, composed those by putting the compartments around the packages. You also mentioned MetaMask snaps. This is a plugin system we're building for MetaMask to extend the functionality and create new user experiences for MetaMask. But because we're putting outside code inside the wallet, we have to make sure it's safe. And so we're also using SES compartments to limit their powers, like limiting network access, et cetera.
Yeah, that was the last question. You're going to be around here? Because I think that some people needs to ask you some other questions. Mm-hmm. Yes? No, you're going to be around because I want
okay,
to.
Great.
We're to
Thank you so much.
Sorry. Okay. Mm-hmm. Okay. Okay. I'm very excited to know all these people that are like my superheroes. I don't know if you are also your superheroes. Also, when I was reading about the CVs and all the work that they are doing, I was like, wow, this is awesome. We are going to have a panel. We have 6 panelists that we are going to that are going to talk about all these audits that we need to know. Maybe the people that is new, like I am, doesn't know anything about coding, about contracts, or about something like that. Maybe we just look that if the contract is like verified, and it's all that I know. But for other people that has more and more knowledge about crypto and about all these smart contracts, we need to be sure that all our ecosystem is already audited. So I'm sure that we already know all another systems like Paladin, like Haken, so are going to be wrecked or we are going to make it. So the panel is over here, so please give them an applause. Can you guys keep please coming?
DJ AJ.
Okay. So welcome to the future of smart contract security audits. Correct, or we are going to make it. My name is Marlian. First, before we get into it, I want to thank Rajiv, who is the founder of Securium, which is training the upcoming class of auditors. He proposed this panel, put it on, could not make it because of visa issues. Yeah? So I just want to give him the recognition for that. So just really quickly, I work at Optimism. I focus on security in our protocol. I previously was an auditor and co-founded Diligence with Gonzalo, and have had the good fortune of working as a client with these three gentlemen, and not yet Certora, but have had an opportunity to get to know them really well. So I really feel in my element, and I'm excited to have this conversation. So I'll let them introduce themselves quickly. If you could, give us your names and tell us about your firms and what makes you special.
I can go first. Hey, guys. And thank you, Rajiv, if you're watching. We co-founded Consensus Diligence almost 6 years ago now, or going to that. Me and John, who's now at Optimism, unfortunately. And Consensus Diligence is a crypto-native security firm that has, for the entirety of its life, done security services, and has also a product side, which you might have seen. So Methex, and more recently Diligence Fuzzing, and a bunch of other smaller tools that are all open source that you can check on our website.
Hi everyone, my name is Chandra, and I'm from Certora. Certora is an automated auditing company. You can think of it as that way. What we do is we use formal verification techniques to prove certain properties about your smart contracts. And I'm personally more on the R&D side, and one of the things that we are focusing on these days is how do you have more trust on the specifications that you write, because at the end of the day, that's really what we are using as the ground truth for verifying your smart contracts. So if you have any questions about formal verification, I would love to hear about those.
I think they're good.
Hey everyone, my name is Mehdi, co-founder and director of Sigma Prime. We're an information security consultancy focused on blockchain technology, doing a lot of smart contract auditing, as you can imagine, but very comfortable diving deeper into other layers of the stack. As John mentioned, layer 2 systems, new L1s and whatnot. We're also the founders and maintainers of Lighthouse, the Rust implementation of the Ethereum consensus protocol. Some of you here, I'm sure, are running validators. Some of you may be running Lighthouse as well. We had the merge a few weeks ago, massive milestone for everyone, massive milestone for Sigma Prime. And yeah.
Thanks, Maddie. Hi, everybody. I'm Jonathan Alexander. I am CTO at OpenZeppelin. OpenZeppelin, we are a security advisor, security auditor. We also work on OpenZeppelin contracts, OpenZeppelin Defender, and we are core development contributors to Forda.
And hi, everybody. I'm Nick Selby. I'm with Trail of Bits. We are an audit and research company based in New York, but people are all around the world. In addition to audits, we have a research group that mainly works on just sort of pushing the edges of a bunch of different technologies, including blockchain, and where are things going next. And we make some pretty popular open source tools like Slither and Echidna, which probably several of you are familiar with. Thanks. I'm glad to be here.
Awesome. Thanks, everyone. So first question, I think, is like maybe a bit of a softball, just to get us going. And I'll pose this to Mehdi first, and then just let the conversation get going. So it's been 3 years since the last DevCon. What do you see as the biggest changes in that time? Maybe it's something you're excited about, something you're worried about. Would love to hear it.
Yeah, interesting. Let's see. I think what I've been noticing is the quality of the projects that we've been reviewing has somewhat improved over the past 3 years. There's caveats, obviously. We still get the occasional, DeFi project with lack of access control and the typical unsafe external calls and reentrancies. But I'd like to think that thanks to some of the tooling that's been available, Trail of Bits has been doing great work on that front. Developers have a lot of abilities these days to pick up the low-hanging fruits. Contracts are getting more and more complex in the DeFi space particularly. Some of the lending protocols that we've been reviewing are pretty hectic. But yeah, I think, the amount of money getting stolen on a weekly basis these days is probably greater than what it was 3 years ago, I'd say. But it's probably due to the fact that there's just so much more, many more people getting into the field, a lot of new projects being deployed, and obviously, our time is, constrained. We can't, unfortunately, service everyone all the time. But yeah, so goods and bads, I guess.
Okay. Anyone else?
We've seen a lot of projects come and go too, and a lot of money come and go. So yeah, I think that even I fully agree with Mehdi. The quality has definitely improved, and I think the bear market kind of helped at that.
Okay, anybody have something different to say than better quality?
I have a mixed bag.
All right.
So 3 years ago, it was a simpler time. Things were a lot easier to look at. Things were a lot more self-contained. And as you just said, right, the complexity, the maze of dependencies, the complexity has kind of exploded at the same time that there's more and more value, so the stakes are much, much higher. I think on the other hand, you're right, the tooling has gotten a lot better, but it's also, I think all of us here working with firms that we're getting used to we're used to the risks, we're used to the threats, we're inured to the patterns, we can see them a lot more clearly. Everybody here has a lot more experience in finding things. And on the other hand, 3 years ago, I remember describing to board members of a pretty large crypto company about nation-state threats, specifically talking about North Korea, and they kind of looked at me with blank stares, and they were like, well, so what? And I think that over the past 3 years, that nation-state involvement has gone from a kind of a risk to a definite and definable threat.
Yeah. Chandra,
So, well, this is my first Devcon, so I wasn't there in the one 3 years ago. But what I've noticed is that this is a very fast-moving field, and there's new terms, new buzzwords, new concepts that keep getting thrown around a lot. But I think, the main thing that I would, say here is, I think it's important to remember that at the end of the day, companies like Certora or formal verification companies or any company that is building tools for verifying smart contracts, they actually rely on a very fundamental concept. And I think that even though this field is very fast-moving, the fundamentals are still the same. And those ideas go really far. And I'm actually excited. I think that we should be able to scale some of these techniques pretty well to some of the more recent concepts that are coming around in this field.
Nice. Okay, I'll give you the next question, but we'll keep it moving. So we're done with softballs. Jonathan, what responsibility do auditors bear when code they've reviewed has been exploited?
Thanks for. I don't know if that's targeted.
You take a sip of water first.
Yeah, thanks. Well, I think, first of all, I think all of us, because I think everybody up here, we take our work so seriously that the first order of responsibility, of course, is dealing with the issue that's found. And I think that I know we at Open Zeppelin make every effort. If we've had situations, I'm not going to say we've had situations where things we've missed have been found, but customers we work with maybe have a situation arise and you are a trusted security advisor to them, you're going to rally to help them in the situation, and that may be in discussing what are the potential fixes and reviewing fixes and even talking about public communications. And that is I think if you are with a trusted, you know, we view these relationships as partnerships, then that's what we're going to try to do. I think that in a specific case where something is missed in an audit, which sometimes, like we've had some situations where we'll do an audit and then before, thankfully, pre-release, an issue is discovered that was missed in the audit, maybe because there was another, you know, set of eyes on it, or maybe there was internal testing. And in that case, we always view our responsibility as to do a very thorough postmortem on what happened, exactly what was found, have our team analyze itself as well as get other people in our team and get the customer involved so that we can all learn from that and figure out and explain to ourselves and improve our processes going forward. So I think that's the very common approach.
So we've heard from Jonathan that it's. I think this is just like to preface on the same topic, but Jonathan has been open that a top-tier auditor can miss something, and so you're lucky, right? Like it got caught before it hit production. That can happen to anyone. So let's like put that out there. Has anybody on the stage like actually had something they've audited be exploited in a significant way? I'm curious.
Not really, but we've had stuff being disclosed after it's in production.
Yeah.
Like, I think that like we establishing, and we've said this many, many times, we're not insurance companies, right? So that's the baseline. But there's an ethical and moral code that like, that we uphold to, and so if something happens, obviously this is also on a case-by-case basis, it should be analyzed differently, because if it's our, if the problem was created by us specifically, then we might react one way, whether if it was just like a miss, we might react some other way. But at the end of the day, we'll try our best, but we're not obligated to anything, right? Nor can we be, because that actually destroys the entire relationship.
Well, I'll go, because I'm just going to jump onto it. We actually don't, I don't think that we have a different way. I liked what you said about the moral responsibility. I think it's really important. I don't think that we have a different process. We have a pretty stringent process to determine whether something was missed. But much more important is what happened, and how can we help, and how can we reach out proactively. They're going to be in incident response mode. They're going to be, their hair's on fire. There's going to be media involvement. They're in a world of hurt. A lot of us at Trail of Bits have worked in the incident response field, so we're very accustomed to understanding what they need to do right now to stop the burning, to stop the leaking, and get things done. So our first reaction is to refresh ourselves as to what we know about this project, and then reach out to try to offer as much assistance as we can. I'm very, very pleased to say that the entire REC leaderboard does not have our name on it today. That will change, but you know, as of right now. But this is a process that we take very seriously because it can happen. There are no guarantees in audits. We always do our very best, but I think to stick with the customer when they're in a bad time as well as when they're in a good time is the most important thing.
Sorry, Matt, do you want to just give us like an insight into what that process looks like? Like just one or two?
Sorry, I didn't hear you, actually.
The process of choosing whether to help the customer or not in one of those situations.
So the helping the customer, I mean, let me be clear, because I made this same mistake in Stanford. I don't mean free, necessarily, right? Like, we will help, obviously, for nothing. There's certain things that we can do as auditors and as experts in the field where if there's more services required, if it's fixed reviews, if there's other things. But the first thing we want to do is reach out and say, hey, we saw that this happened. Do you need any, do you want to talk to us about stuff that you're doing right now? I think you said that pretty well.
If you don't mind.
Go ahead.
Can we agree that audits is probably one of the worst terms to describe what we actually do? Do we all agree? Yeah, okay, cool. So,
but it's like cyber. We just inherited it and we can't do anything about it.
It's terrible. I feel so bad using the word auditing or audit every time I do, but these are really time-boxed security assessments. Let's just all agree on this. As John was saying, these things are not bulletproof, right? Bugs will be missed. and we allocate a certain amount of time to do our best to find these vulnerabilities in your code. But guess what? If you give us double the amount of time, chances are we'll probably find more bugs. So let's just make sure that we're all clear on what we do up here in terms of security reviews and security assessments.
Okay.
And by the way, that's not just a CYA. It's not. You said the word partnership, or you said the word partnership. People wait a long time for audits. It's a very important part of the process of going live with a product, especially a product where a lot of money, if it goes bad, a lot of money can go out the door. Customers have their own priorities. Customers have budgets. Customers have realities. And usually it ends up that we're not negotiating actually about money, but about time. We're not negotiating about money, but about the number of engineers who can be looking at it. So while we can't guarantee that a 3-week, 2-engineer audit will find all the bugs, we can guarantee that a 3-week, 2-engineer audit will find all the bugs that can be found by 3 engineers, by 2 engineers working for 3 weeks. And that's a different sort of guarantee.
Yeah. Okay. So I think Mehdi set this up well in that by saying like just the semantics of what this is, what we're doing, how is it defined. So we're saying time box security reviews now. Do we need a set of standards to make it clear? Whatever word we choose, do we need to have a set of standards for this? And I'll give it to Chandra to take a crack at it.
So standards for auditors, you mean? Or
I mean, that's a good place to take it as well, if you like. I was thinking more for what an audit is, for what needs to happen during the course of this security review.
Well, so I can perhaps speak from a more automated auditing point of view, but then I think some of the ideas probably also apply to human-based auditing. I think the hardest thing is to come up with the specification, right? Like even when you're auditing, like what are you actually looking for? I think that's one of the main questions that you should very carefully think about, right? And I think one of the things that's kind of difficult for auditing is it's hard to be very precise. And if you're not precise, then you kind of think that you did a proof, or like you have some kind of guarantee that this bug isn't there. But I think, unless it's very easy to feel like you audited really well if you don't have the specification correctly in your head. And perhaps a related thing is in formal verification, there's this notion of trusted computing base. And I think that idea also maps to auditing. Like, what part of the code did you audit? What parts of the code did you not audit, right? And you can only say confidently, well, with some confidence, that the code that you did audit maybe doesn't have some vulnerabilities, but the parts that you didn't, you can't say anything about them, right? So it's very important to be very explicit about what the TCB is and what you verified and what you checked or whatever you audited.
Anyone else?
I would say I'm a little frightened of the word standard in what we do, because I think sometimes it comes from the place of people hoping that we're going to simplify down to some very simple set of rules what needs to be covered, and then anyone could cover it. And so I do think we need common language. We need, and Mehdi just helped us with some of our common language and understanding so that we're working together. But I think what's important is if you're a team and you're engaging auditors, as opposed to, you want to have common language about what will be done, what won't be done, but this is people also, and people with experience. So I think getting to know who are the actual auditors, and not just, I think we were talking about this before, not just the team or the label, but who are the specific people, what is their experience, because those are the people you're going to be working with. And what's more important probably than standards is agreement with who who's going to provide you the security review, and who are those people, and what are their skills, and what's their experience?
Yeah, and so I'm gonna I'm gonna go to the other side of that, the interpretation of the question of standards, and well, I'm gonna just steal the phrasing from Rickard, who I was talking to the other day. He said, "Who audits the auditors?" And so, you know, as a project, and I experience this now as somebody who's audited before and understands the industry far better than most, it's still scary. Like talking to, like trying to evaluate the auditor, like for the code that I have that I want looked at, is this the right audit firm? And do they have the right people available when there's so many moving parts, it's crazy. But back to that, who audits the auditors? Like, is there some way that we can or should be holding? I don't want to go back to like holding auditors accountable and the skin in the game thing that we can go round and round about. But yeah, like how can we help non-auditors evaluate the auditors that they're working with? Should there be some kind of third-party watchdog that's ranking you all, or what?
I think it's a place like this. A good plug here would be like to talk about ETH Trust, and I think we all participated in the standard in one form or another. And I think it's like a dangerous proposition because the proposition of ETH Trust is that there's levels of how secure your code base is. There's like kind of a risk assessment of how your code base will look like after you have done certain things, right? So this is part of the EEA, the Enterprise Ethereum Alliance, and I think it was Tom Lindemann who started it. I think it is a dangerous proposition, but it might actually be helpful if you are not super embedded into the security industry, right? Again, it is useful, but it should be taken with a grain of salt, because like if you take level 3 or like formal verification as a panacea, that will probably be a disservice to you. So I'm mixed bags on getting standards for what a good security practice looks like.
All right, this is a scary one, so, but I'll go ahead. I actually think, in terms of security work, and I think about other niches of technology, the work that, let's say, these teams here do is very public. It's very public. So in some sense, we're watched very closely. And so this idea that, so our reputations are on the line all the time. And honestly, I know all of us up here, we lose sleep over it, right? Like, and I will say too that like at Open Zeppelin, we work in Open Zeppelin contracts and we've had issues. And, you know, so our reputations are very public, and we're all glad we're not on the rec leaderboard. And so we can talk about, I think it's perfectly healthy to have conversations about how could we provide more transparency and more info, but I think we are actually very well watched right now.
Okay.
Yeah. Now there still is the thing about what's the right match for you as a project, and I think that's an important consideration.
Yeah. And I like how you said like you lose sleep over it. I think, you know, everybody in this room loses sleep about either the code that they're running or the code that they're auditing. So we should all go easier on ourselves. So I think it'd be fun to get some questions from the audience. So if you have a question, raise your hand. And meanwhile, while the mics are getting handed out, we're going to try something. Overrated, underrated, lightning round. No people, no firms. These are concepts. Okay, so where should we start? Nick? Plain English specs, overrated or underrated?
Underrated twice.
Okay.
I was actually, Jocelyn Feist is here, who's the head of our blockchain, and he was saying, you know, you can pick the tool. You can pick how it is that you want. If you're not able to put down in English, what are the invariants? What are the things that you're trying to accomplish here? Once you do that, you're 75 or 80% of the way through. it just speaks to a number of things, not just for security review, but also just for your own understanding.
Yeah.
To be able to declare this is what this thing does, you can't put a value on that.
Yeah. Awesome. Let me see. Hello. Great. Gonzalo, overrated or underrated? Contract upgradability.
So overrated.
Okay.
Expanding upgradability is a bug. Not always. We went through this, so there's a longer conversation about this that happened at DeFi Security Summit. I think that is available on YouTube, so I could rant on and on about this. There's also a bunch of articles on the internet about this, but generally speaking, you are just injecting another attack vector in your code base.
Okay. All right. Chandra, how do you feel about, overrated or underrated, reading the code very carefully?
Extremely underrated. I think we should read code extremely
So we can't
carefully.
just write rules? And
You can't just write
no.
rules. No, you definitely
Okay.
need to understand the code before you start writing your rules.
Formal verification is not a silver bullet?
It's definitely not a
Okay.
silver bullet, no.
But really, like, how, it's, how do you know what kind of guarantees you're getting from formal verification?
I mean, yeah, I think this is a very good question, right? Like this kind of goes back to what I was saying before. It's important to think carefully about what you're proving, right? And your spec is really all you have. And when you say that, okay, we have a formal guarantee, you should be very careful when you make these kinds of claims. And I think it's very dangerous to make these claims because, the spec could itself be wrong. And even if the spec is reasonable, I mean, there could be a bug in the formal verification tool. And then that's also bad. And, just because there is a specific bug that you verify your code against does not mean that there's, it's just bulletproof and you can just trust it with your life, right?
Mm-hmm.
So, yeah.
Okay. Mehdi, yep, you're up. Have I asked everybody something? Jonathan, you're up? Okay. All right, so you're after Mehdi. You'll get something, don't worry. Mehdi, alternate virtual machine design, so not the EVM. Overrated or underrated?
Overrated?
Okay.
I don't know.
Do you wish to qualify that, or?
Yeah, I don't know. I've been spending a lot of time on the EVM, so
Yeah.
kind of getting familiar, and it's got its quirks. Obviously.
Stockholm syndrome, basically.
Probably,
Like,
yeah,
me too.
probably, yeah. Look, no, we've definitely done a bunch of security assessments targeting different execution environments. Don't get me wrong, but obviously most developers are operating with Solidity, Viper at the EVM level. It's got its quirks, but it's kind of working. I'd be excited to see the upcoming upgrades, particularly EOF, EVM object files, that might change a lot of things with regards to security guarantees or assumptions that we make with the EVM. But yeah, I don't know. I quite like it by now.
All right. Jonathan, how do you feel about insurance against smart contract vulnerabilities? Overrated, underrated? That's where to start.
I guess if I'd probably say, I'm going to say underrated because I don't really think it's widely adopted and used at this point, and I think it's based on where we're at.
Mm-hmm.
Our risk tolerance is really high, and our skin in the game is really high, and our risk levels are not well understood, so it's hard to get insurance.
Yeah.
If not impossible for a lot of us. So I think that'll change. That's gonna change for sure.
Mm-hmm.
And so that's why I say underrated. I think it'll change, and then, yeah, there'll be hedges and insurance. And I mean, it is happening. It's not like it isn't happening, but I think it will happen more. And hopefully you know, some of the work that some of us do up here will help everybody understand the risk better so that insurance will be obtainable and things like that for those who want it.
Yeah, right? I do like, I will give one, I haven't given many opinions, I don't think, but I think that having somebody try to price risk who is not an auditor, auditors don't want to price risk, they like look for bugs, right? And it's a totally different thing to be an actuary. But there should be actuaries, and maybe they are the ones, maybe they audit the auditors. They have an incentive to do so.
And we're working, what I'm hoping, and we're doing some work with the actuarials and with the insurance companies to make sure that insurance in this industry does not go the route of insurance in, quote, cybersecurity, where, I mean, I thought it was quite hilarious, a week ago when Lloyd's of London got hit with a cyber, and like they can't set actuarial terms if they can't even secure their own systems.
Yeah.
What we're really hoping for is that people doing security reviews can set those standards so that the insurance companies are actually as passionate about what they do, that they're getting into it not just because, oh, look at that, it's a new adjacent market that we can get into, and much more around, wow, this is really innovative stuff, we should get in there to make it safer. And we're working with several people like that, and I'm very hopeful, so I'm with you about underrated.
Interesting. Okay, is the audience ready? Does anybody have a mic and a question?
Yeah, I do.
All right, let's just, Mike, I can hear you, so I'll repeat it. Oh, somebody's set up. Okay, go ahead, please.
Hey, so I was wondering, because of all the monitoring tools that are coming out, like FOTA, for example, and there is also private mempools, is it really overrated?
Oh, so you're using the format. I don't know, who should I give that to? Like,
what's the question?
It's about monitoring. Is monitoring, like mempool monitoring, overrated or underrated?
Specifically mempool monitoring?
I think
or
so.
Just, is your question monitoring in general? Yeah. Is monitoring overrated?
Yeah. So, like for example, like there are products out there that claim that they could like maybe detect hacks and all that, or maybe secure your smart contracts, that kind of a thing. But a hacker could use like a private mempool to like really send these transactions across, and to even to react, right? Your transaction may be front run.
I'm going to say, let's talk after. Not sure it's real, but what I'll say is that I don't think there's anybody claiming that we've solved monitoring in the ecosystem. Nobody's claiming that, or that we can stop threats. But what I will say is that I think there's a lot of agreement that security is not just a time box security review. If that's all you do, good luck. And there are things you should be doing upstream and considering, like formal verification and fuzzing and various techniques. Time box security review is part of it, and there's things you should do. So pre-release, pre-deployment, post-deployment, there's things you should do, and monitoring's part of it. And so there's value to an end-to-end security, and I think that's where we're at. Okay. We're starting to appreciate that.
Anyone want to sneak in quickly while we move the mic over?
Yeah.
Go ahead, Alex. You're up next, Mike. Don't worry.
Hi. Do your clients request public reports? And when you write reports, who do you write the report for?
Take that. Yes.
Yes. So I was telling one of my team members the other day that what we sell effectively is PDFs. Obviously joking a bit, but yeah. Yes, it's critical. The output of the work that we do is a security assessment report, which contains your standard executive summary, detailed description of all the vulnerabilities identified, and recommendations. Who do we write that for? That's an excellent question. We write that for our clients. Now, the problem that we may see quite often in our space is readers sort of going through, well, users of the protocols that we review, going through our reports and not necessarily understanding, again, the concept of a time box security assessment. In a lot of cases, the scope that we actually go through is a limited part of the entire protocol. This happens quite often, particularly with very, very complex systems. And unfortunately, some users may use our security assessment reports and say, look, this protocol is absolutely safe because this auditing firm has only found a couple of mediums and lows and informationals, and they've all been resolved.
Because they passed your audit, right?
Exactly,
So
that's right. They passed the audit, big check mark. None of us here provide any big green check mark in our auditing reports. There's plenty of other firms that do that, unfortunately. So yeah, I think you're absolutely right. The audience of these security assessment reports is a tricky one.
Let me sneak another question in. If a client asks you to remove something, or rephrase something, are you writing it for the client?
Yeah. This happens quite often. I'm sure that it happens quite often. Yeah, I'll take it. No. I mean, a client can argue on the severity of a bug, right? And that's absolutely fine. We're more than happy to have that conversation and be like, okay, why do you think this is not a critical? Like, look, I've got systems off-chain in place to prevent this from happening that I would actually drop down the likelihood of exploitation. And we're like, okay, fair. I'm happy to drop down the likelihood, which would effectively impact the severity of the bug. But removing a bug from a report, if it's valid, hell no.
No, this goes against the trusted advisor role which we play. And how to read our reports, or I think all of our reports, is that it isn't that check mark. And what I want to see from a customer is I want to see them come out with our original report, which we will not change. And so you as the public can look at the report and see the problems that they faced. And then you can look at the fix review report, which is separate, or an appendix, it's different. And see, okay, you can actually watch the progression as they're taking the advice. They're understanding not just how to fix that bug, but how to fix bugs like that from happening at all. And some companies are afraid to do that because people will think that they're not good at security. I look at it as the exact opposite. A company that is proud to say, look, these are the challenges we faced, and here are the innovative solutions that we came up with to address them, that's where I want to look, because now they're actually taking our advice, and they're doing what they should do with an audit.
Is there, I want to, Chandra, is there a difference in the way that a report needs to be presented when it's heavy on formal verification?
I mean, I don't think so. I mean, we have very similar reports, and like Mehdi said, right, we have the severity of the bugs, and we explain exactly what property we wrote and why that corresponds to the bug. And I think the only additional thing that we very much emphasize is that, be careful that don't just take this as this is not a silver bullet. And I think there's no difference, to be honest, in terms of the reports we write.
Okay, Mike, thank you for weighing.
So disclosure, I work with Jonathan at Open Zeppelin, but I didn't tell about the question ahead of time, so there's no front running here. If you could wave your hand and every single developer in the space, but most especially your clients, just automatically followed best practice without you having to tell them ever again, what would it be?
Yeah, it was a bit echoey, but if you could magically, if you could be sure that every client, if there's one best practice that you wish every client would adhere to, what would it be? Who's field? Yeah, all right.
I've got one. Do not change commits mid-reviews. Please. Thank you.
Here. Should I start formal verification at the very beginning and continuously throughout the project, or only at the very end?
That's such a good question.
So the question is, should you start formal verification towards the end or towards the beginning of your development? So this is a very interesting question. You should start as early as you can. That's based on our experience. I think that's the right place to start thinking about formal verification. I think the most important thing there is it really helps you sort of write your code in the most simple, modular way, because that's really what is best suited for formal verification. and it automatically just prevents you from making certain mistakes. And I think it's extremely important, even if you are, no matter what kind of verification technique you're using, the earlier you start, the better. And along the same lines, writing your specs out in English and also gradually making them somewhat more formal, I think the earlier you do it, the better. Like once you've already implemented your code, trying to come up with an invariant or trying to write down the pre and post conditions and stuff, it gets really hard. So
I think there's I like the shift left security meme, which is basically just the idea, if you think of your time and your process as moving from left to right, writing your code, then writing your specs and tests is doing it on the right-hand side. So the more that you can do any of these things, your specs, formal verification, test writing, earlier in the process, generally the better your outcome will be.
absolutely, yeah.
Okay. Anybody else have a question? Yeah.
So I have a question for you. I think Jonathan and Nick were touching upon it, but crypto is a very narrative-driven industry in general, and if we zoom out a little bit and get outside of the security echo chambers, what are some narratives that you want to see, and what are some narratives you want to correct that are floating out right now in terms of security?
Did you catch? I'll try to. So you said we're in an early stage right now. We're in an echo chamber of security conversation, and we need I'm struggling.
Yeah, I was going to say if we make an assumption that security community within crypto is on the table, and there is a broader developer community outside as well, who are all developing, building the tools, who are susceptible to certain narratives. What are some narratives that are floating around security, around how people see security audits, around how people see security in general, that you want to take the chance to correct if you see anything wrong? What are some ways you want to
I think we got it. All right.
So I'll just repeat it for everyone from what I heard, and correct me if I misheard. Bad narratives in our industry that should be corrected, hopefully quickly and early on. Does anybody want to
Gonzalo, I think
got that.
What are you angry about? See, I know him. I know how to to speak to him.
I'm angry about a lot of the raises that happen in the security industry recently. I think that money and capitalism is creating legitimacy for people that have not demonstrated proficiency. So this is a narrative that really grinds my gears, for example.
Wow.
And
yeah, I think that says it. Yeah.
Yeah, I'll give someone else that. I'll sneak in a smart contract availability here.
Well, all right, since Gonzalo started with things that make us angry, I'll do one too. Well, I think that our desire for cost efficiency and time efficiency is not in our best interests, and I mean gas savings and speed of transfer from a layer 2 to a layer 1 through the bridge that was just developed yesterday. And our lack of acceptance on latency on anything so that we could do more security verification. So I think these things work against us, and I understand why we're doing them and how they're helping initially, but I hope the narrative changes so that we aren't as worried about gas savings, and we aren't as worried about speed, and we're a little more worried about security and safety for the users.
Okay, next question.
Hello, everyone. My question is if auditing is good enough, or would you consider alternatives like Open Arena or Bounty Vaults, like Hats Finance, for example? Or maybe deploying 2 medium-tier auditors, or just 1 top-tier auditor per contract, considering timeline? Thank you.
Oh yeah, you guys don't even have
So I'm not sure I fully understood the question, but I think it's, please correct me if I'm wrong, but I think you asked if auditing is good enough, then why do we need the bounties?
Let's
Or,
make
like,
it more
that-
general. We sort of I think we'll get this is like just generally we have some new alternatives to audits that have emerged. Giant bounties, and like Code Arenas and Sherlock doing these like auditing competitions that are a little bit like a time-boxed bounty program. So, how does that like substitute or complement auditing?
Who said auditing was enough?
I don't know if that's. I don't know if anyone said like we might. Yeah.
Well, my answer is back to what I said a little bit before, which is a bounty can give you this bug, which is interesting, but it's not really as interesting as how you are working with. This is a holistic view of all of the code by engineers who are deeply and intimately involved with the code to the same extent that your internal people are, but they're seeing it through a different lens. They're seeing it through the lens of people who have literally watched everything that could go wrong, and being able to see mistakes in everything from documentation to just your overall maturity. It's a different set of things. If you want to find specific bugs and fix those, that's great. There's other things that are outside the general scope of what we do in a security review. I'm not suggesting that audit or security review is the be-all and end-all, but it's also different from a lot of things that I'm seeing out there. And as far as automation goes, we use automation to find sort of low-hanging fruit or to point us in the right direction so that humans can look at it and make educated decisions about what we think. And there's a lot more than just run this tool, see what you get, and hand over the report.
Anyone else quickly? We're running low on time.
So I
No, whoa, sorry, no, that's, I meant on the stage, like if anybody wanted to, okay, and, all right, I'm gonna be selfish too. There's something in the time we have, I really want to plant this idea as much as possible, is that it's not the auditor's job, they're not selling you security, in my opinion. They're selling you like insight into your ability to write secure code. Yeah. So you need to take responsibility for writing secure code, and not act as if like you just get to write code that does cool stuff and then give it to the auditor and they will make it safe for you. So you need to focus on being able to write secure code, whatever process you think that might need, whatever tool you think that requires, and then you give the auditor your code so that you can understand how close you are to being able to write secure code.
Amen.
It took me a long time to get there. So it's a bit of an epiphany, and I'm trying to push it out
Unfortunately,
there.
we see what John was describing way too often. And yeah, it'd be great if we can all collectively shift towards a different definition of what our work here means. Yeah, thank you.
Okay, there was another question, so let's have it.
Yeah, so Foundry, when Foundry first came out, I was surprised by the fact that it included fuzzing. So my question is, when does fuzzing make sense on these code bases which are generally open source and small? And how do you approach fuzzing in your use for auditing?
Fuzzing makes a lot of sense all of the time. We go into the shift left, shift security left narrative and all of that. Like you should use all the tools, literally. You should write specs. If you have specs, fuzzing will work better, right? You should just do it all the time. Use Foundry and use all the other tools. Use Echidna, use Harvey. By the way, forgot to say, I've been announcing this the entire week, but this is the panel. We at Diligence will be open sourcing all our tools, just like Trilobits. We're a bit behind schedule, but at least better late than never. So
even Harvey?
Yeah.
Nice.
All the code bases. So yeah.
Did you?
I guess to add to what Gonzalo said, I think using tools is actually good. So fuzzing makes sense to me. I mean, again, it's not a guarantee, but I think it's just like good software engineering, right? Like you write code and you want to write tests and you want to do fuzzing and you want to write specs, and these are all good software engineering practices, and I think they also just they carry to this domain as well, so it makes sense.
The one comment about that you just made, well, both of you, like that the declaration of things, the ability to set forth a spec, and then fuzz around that. That's really important. That first part is what Jocelyn and Gustavo are going to be doing tomorrow. There's going to be a 2-hour workshop on how do you declare these things, how do you actually set out and describe invariants, and how can you use those to make your fuzzing more effective. So I would really recommend that you go to that.
So just to be fair, I know like we're out of time by this timer. Let's give every speaker like 30 seconds to, sorry? No shit. Okay. All right, so we started the questions way early. We got tons of time. I should have read the manual. Brian, I know Brian had his hand up at one point. And okay, you, please, just like, I'll repeat it through the mic, so go ahead. Interesting. Okay, you guys are excited. Just go ahead, repeat the question and answer it, please.
That's cool. Is there a way to make like the output of audits machine readable? And it's interesting because we do actually.
That's Slither, right?
Yeah. No, I wasn't going to go there. I was going to go. That's really interesting, and I think we're going to take that up and talk to us. Hit us up afterwards.
I think it's going to really depend on the writing style of the security firm that you engage with. But it is something I'd like to think about a bit more, yeah. Perhaps we could parse some of those reports into a readable format or a machine readable format. That shouldn't be too hard to do. We write reports in LaTeX, so it should be pretty trivial for us to do.
So at Certora, actually, we have been working on a related thing. So I don't know if you've ever heard, like, there's things like deoxygen or doxygen, I don't know how to pronounce it. And like, there's also NatSpec is another similar library. So the nice thing about, if you have a formal spec, it's actually a little bit easier to like sort of convert that to a format, because you can annotate your code and then you can automatically generate some kind of a formatted report from that. So I think it's a good idea.
I got one back here. Hey guys, Kevin over here. Hey friends. So having come from sort of the security side and now being protocol engineer and founder, I'm wondering about this line you tread as an author of being very slow, methodical, heavy testing, core protocol, must be super secure, to now, okay, now I'm wanting to move a bit faster. Maybe they're integration contracts or something that's not in my core protocol. How much time am I spending in testing and in auditing? How much money am I spending there versus move fast and see if things work? I wonder if I have my own opinion, but interested to hear what's on the stage.
I'll just quickly, I'll say the most secure code is the code that never hits mainnet, so just keep testing.
I also think it depends on how much money you raised or how much money you have. And now, like, it's a very practical thing, Like, you can spend a lot of time and resources writing tests, but at the end of the day, if you run out of money and you only have the tests, you're probably fucked.
Anyone else? Okay.
Hey, all. Question back here.
Can we get a mic for Brian? I want to hear what he has to say, but go ahead, please.
Okay, cool. It might come off as somewhat pedantic, but I'm curious, looking at the different way that auditing firms do severity or impact, and then difficulty/likelihood. I'll be honest, I prefer likelihood, so that it's like difficulty is low when likelihood is high. So I was just wondering, high likelihood and high impact would equal high severity. Have you seen clients get confused about this different? And without being overly strict, as the industry is still developing, I'm also curious about how we might classify things. Trail of Bits has a nice classification. SWC seems outdated and not updated. as well as, or maybe it could be going forward, are there things that we can do as an industry to improve and start to, I hate to say solidify, but structure our information architecture a little bit more so that clients can understand when they're getting multiple audit reports and reduce confusion?
Right.
Thanks.
I think it's it's a great point, as you said. Well, for us at SIGP, high likelihood, high impact, critical. And I think we all use perhaps similar types of risk rating matrices. It's probably beneficial if we could standardize on how we would rate severity. So as you said, it's typically likelihood of exploitation, impact of exploitation. But there's different levels, so we got 4 of them at SIGP. So informational, low, medium, high, and critical. That's actually 5. But yeah, I think it's a great idea. There's been a lot of initiatives over the past few years on the e-security channel to try to standardize some of this stuff. It's never happened. I don't really know why, but I think it would be quite beneficial.
Okay, great. And I think that, so Brian started that channel, so
Yeah.
what do you got?
I'm going to give you a bit of a left field question. So there's been a few regulatory proposals that includes software security best practices in the proposal. What sorts of standards that are driven by regulations do you think could be damaging to the space, and what ones do you think could be good?
Wow. So almost like, yeah, the typical, like a regular comes out of nowhere and they're maybe a bit naive. What kind of damage could they perhaps do by misunderstanding?
Well, I think, I don't know if it goes to the intent of your question having to do with structure of code. I think we all know we're concerned about regulations that would impose requirements on protocols to be able to block certain parties, as an example. So I think a lot of our concerns are around regulations that would have requirements. I don't know if that goes to your thought about the question having to do with specific developer
I could imagine,
processes.
Your contracts must be upgradable for whatever reason.
Yeah, those things are always damaging. If you're talking about regulations at the code level, I think there's no way they can be good, you know?
I think that, as an example, having worked in security before and in the cloud space, the SOC 2 standard, I believe it has a lot of really good aspects to the software development, the security-focused processes of your software development lifecycle. And I think those are good practices, and if teams were transparent about the processes they follow, I think that's healthy, and if held to a certain standard. All those things always have downsides in terms of the effort that goes into auditing them and proving them. But
yeah, the life cycle of regulation is really tough. Getting regulators and government officials to understand the key areas, they have a goal of what they want to accomplish, but usually they're rather far behind the technology. I think it's up to us, everybody here, we certainly do this, I bet everybody else up here does this. We spend a lot of time talking to regulators about what is possible and what isn't. We spend a lot of time talking about the intent and trying to come up with sort of more open suggestions to industry as opposed to specific, because if you say thou shalt do the following, it's always going to be out of date by the time it passes. And it just becomes very, very difficult. So I think that the best thing that we can do, the most practical thing we can do is educate those people who would regulate us.
Thanks for clarifying, Brian. Yeah, that makes a lot more sense. Just to give you guys maybe an exotic perspective, I was catching up with some of the regulators in Australia a few weeks ago, and this is exactly what they were asking for. They said, what should we be requesting from projects to do in terms of security practices, in terms of security development, secure development, and what should we be regulating in the space. So I try to sort of convince them to go down the educational part, and yeah, this is spot on. I think it's certainly something that is happening, at least in Australia. These people are starting these conversations and are starting to realize the need of. You can't enforce these things on projects, but at least you can have these set of guidelines and point your users, your citizens, to these guidelines and get them to demand these standards, this set of minimum requirements from the projects they interact with.
We must be at time now. Sorry?
Yes, we are. We've run out of time. Thank you, everyone. I just want, if you want to give us a little words.
In case you missed it, we had Nick from Trail of Bits, we had Jonathan from Open Zeppelin, Mehdi was from Sigma Prime, Chandra was from Certora, and Gonzalo was from Consensus Diligence.
Woo! Maybe I could have just 2 words, or 3 or 4 words. I think that this presentation could now be called like, we are gonna be audited. I don't know, but maybe in the social layer, maybe I'm thinking that we need like more knowledge for us, that we are like the beginners. So maybe if we can like get more information about all the auditors that are actually working in this space, maybe it will be like a better and more enforced like a social layer for auditors. Yeah. Awesome. Thank you.
Thanks, everyone. Oh, I'm still on.
To already introduce myself, we had a little MC handover, so I will be MCing the last half of the day today here on the Code Forest stage. Happy to see all of you. In case you didn't see me on Tuesday, my name is Franziska. I work for the Ethereum Foundation, and in the foundation mainly in the Solidity team, but I also do some other stuff. And yeah, in this afternoon we really have a quite cool lineup on developer infrastructure, mostly about Solidity, EVM, assembly. Yeah, we will go pretty deep. And I'm excited to announce the next speaker. It's Alex. He's the team lead of the Ypsilon team at the Ethereum Foundation. Ypsilon is a team that is focusing on improving the EVM. But not only that, Alex was also the co-team lead of the Solidity team and also a very early contributor to the Solidity language and compiler. And that's also the topic that he will be talking about today. He will talk about the magical version 1.0 in Solidity. When will we reach it? How might it look like? And even further, going beyond, how might Solidity 2.0 look like? So please give it up for Alex.
I'm not sure, can you? Yeah, you can hear me, right? And I hope this works as well. Okay, it does. Yes, Francis said, thank you for the intro. And I wanted to also make sure that a lot of this stuff is my opinion. It's not like the opinion of the team. I have been working on Solidity since 2015. And in the past year, I've been kind of like taking a break. And did write a lot of code in Solidity itself. And I think some of this is like a culmination of my experience using the language. But I hope some of these things I'm mentioning may come to fruition. OK, so 0817 is the latest release. It's a 100-second release. We already had more than 100 releases. That is just insane. And we probably have more than like 1,000 nightlies, which is just crazy. Basically, we had 8 breaking releases, a bunch of feature releases, and sometimes we do have like bug fix releases as well. In some of the years, we had releases every 2 weeks. I think lately it's more like monthly. And I hope this is going to continue. Maybe we're going to get back to like bi-weekly releases, but at least monthly releases. And I'm saying this just to show that how active the development of Solidity is. I'm not going to go through all of these. You can find this really nice chart on the soliditylang.org website. And it shows you all the interesting milestones we have accomplished since the beginning. However, it doesn't show anything past 0.6, because we made this 2 years ago. But as you can see, it's a lot of stuff going on. And based on like having over 100 releases, you may ask the question, when do we actually get to 1.0? And you may not be alone asking that question. We do get that question super frequently. Last year, there was like this big debate. This particular issue I'm looking here. The issue is much longer. The description is maybe 10 times as long. And the author of the issue provides a bunch of different reasons why he thinks Solidity should be at 1.0. I summarized like 3 different discussion points we have been debating on this issue. The author said, or had the opinion that the current scheme doesn't actually allow breaking releases, the separation of breaking release and non-breaking releases. In his opinion, every single Solidity release is a breaking release. He also argued that the language is widely used. It has been for a couple of years, and so it should be a 1.0, because that signals that it is ready to be used. In fact, when 1.0 was released, we never signaled, 0.1 was released, we never signaled that it's ready for usage, but the nature of blockchain, people just started to use it, and it's there. It's always going to be there. But also the team had some concerns about this 1.0 stuff. Basically, we have the impression that 1.0 kind of implies that we have to have a long-term maintenance of that version. We have to add new features, non-breaking features, and all kind of changes. And if we still want to do breaking changes, that's going to be like 2.0. And then suddenly we have to like maintain 2 versions. Or we're not going to make breaking releases. So that is the reason we kind of wanted to avoid going to 1.0. I'm not sure how many of you actually know how the versioning system works. Do you want to like give hands on, are you a developer first of all? So many of you. Are you using Solidity? Are you using anything but Solidity? Not many? Any other language besides Solidity? Nice. So I think you should be aware how this versioning system works. We were under the impression that it is semantic versioning. Turned out it is not. Because anything below the major 1, so major 0, is a breaking change. However, we did assume that the three numbers in the version is major, minor, patch. And we assume that if we bump the minor, that is a breaking release. If we bump the patch, that is a non-breaking release. So it's not actually in conformance with semantic versioning, but it kind of works for us. Here's just an example, how this would look like. And now suddenly, once we know what 1.0 could mean, maybe we should talk about how could we get there. Here's an example contract with the latest release. This is actually the Solidity socks contract, which is on mainnet. You can use it to mint socks, both the left and the right-hand side. If you're lucky, you can mint both. And I think the socks are gone at this point, but you could have gotten them a physical version of the sock at the Solidity stand. I think on the floor above, I'm not sure. Now, this is 0817. It is 1.0. Do you see any change? Yeah. I kind of think that actually, for the users, you're not going to see too many changes at 1.0. We may actually have some changes. OK, so that was the non-changed version. Is it skipping one? OK, this is the non-changed version. And this has a few changes. They're not important. Yeah, where is it? Like this stuff. None of this is agreed on. But there may be tiny changes, but I don't think they're going to be big changes. So no major differences if you're a user, but giant differences if you're writing a library. I listed a few things on what you would be able to expect in libraries. We should have like operators and literals for user-defined types, standard library generics, enum data types. I just gave you a few examples now, but actually, Daniel from the Solidity team had an extremely good talk, which you should watch. And I'm going to share the QR code for the video as well. So here's an example of user-defined operators. I cannot say that I actually like the syntax, but the team kind of agreed on it. So without this, you have to use the usual function chaining. But once you have user-defined operators, what you can expect, you can just use them fairly easily. So I think the team kind of agreed that this is going to be a focus project, and I believe this is needed for like 1.0. Another major thing is the standard library, which we have been talking about for years. And the main goal of the standard library is to move out the majority of the compiler code into Solidity itself. But it is also a really good exercise doing it because it shows us what kind of language features are missing. So here's one example. This actually doesn't require anything major. The only thing it requires is this pragma standard lib. And what it does, it just disables the built-in functions. Because if you don't have this pragma standard lib, this function definition is going to fail because there's already a SHA-256 implicitly in the language. If you have this, it's not going to be there, so you can define it. This is the simplest example in the standard library, and this works. Doing anything more complicated going to require a lot of language changes. Here's one example of what we will require for the language changes. It is just generics. This is an extremely old example. And in fact, I copied this example from my talk from 2 years ago, from the Solidity Summit. We were already saying the same things back then. So now I'm going to go any further. If you want to take a photo of the QR code, this is the talk from Daniel. It is a full 30-minute talk, and it did a really good job at explaining the reasoning behind these features and how they're going to work. Okay, now taking a tiny break, these were the changes the team wants and the team agrees on. But I kind of want to ask you, all of you, to look at the repository. These are all the, it's kind of hard to see, but these are all the issues tag language design. And we have 237 issues open. Those are the issues people want as a feature. And I think many of them actually are kind of obsolete at this point. But I ask you to look at this repository, look at all of these issues, or a tiny subset of them, find something what you like, and leave a comment if you want to have it, or leave a comment if you think it is a bad idea. Besides these features that the team wants, I think it would be nice to know what you guys actually want. So I think that's what 1.0 is going to be like. Not many visible changes for the user side. If you're just writing like a token contract, NFT contract, etc. But if you're writing libraries, it's going to be entirely different. Now, 2.0. That is a crazy topic. And we have been actually talking about this for a couple of months at this point, on and off. And actually, 2.0 is two different things. And it has been super confusing at the team even talking about it, because some people meant one or the other. And I just want to highlight it again. Nothing is decided here. A lot of this is just my idea of what I want to have. But I hope some of this is going to happen. So first I'm going to talk about this compiler rewrite, which sounds crazy, right? How many of you actually know the compiler? How does the compiler work? Or a compiler in general? Not many of you. Basically, a compiler has multiple stages. We take the source code, we process the source code into some internal representation. We do a lot of different analysis on that representation. Once we are happy with the code, that it is sound, that it works, we are generating some kind of a next stage. In the first version of the compiler, this generation was directly into EVM. In the current stage, we still have this, but we also have a second pipeline, where instead of directly generating to EVM, we generate to Yule, which is our intermediate language. But you must be familiar with Yule because it is inline assembly, basically. And then we take Yule and generate EVM bytecode. So that is the pipeline. And then these are the different libraries we have in the compiler itself. So this one is just really tiny helpers. Yeah, I'm going to move to the other side. So these are just helpers used by the others. The assembler is kind of separate. It's standalone. It takes in a data structure, like a representation of the assembler source code you want to assemble. It generates EVM bytecode, but it also has optimization steps. Then we have this separate helper for, it's called language utilities, but it's really just helpers for the parsers, because we have two different parsers. We have the Solidity parser and the Yule. So lang utils is used by both of these. The libyule has a parser, has a code gen, has another kind of optimizer. And then libsolidity is a big one. It's a monster. It is the Solidity parser, does all the analysis I mentioned, and does these two different pipelines for code generation. And then we have two smaller libraries. The SMT library is just for the SMT subsystem. But I think that is also split up, so some of it is here, some of it is in this libsolidity directory. And then lastly, the smallest one is libsolc, which is a tiny binding. That is the only library which is C, has a C API. Everything else is C++. So this basically is a wrapper between C and C++. And that is what is compiled through Mscript and into JavaScript if you happen to use any kind of web app that's how Solidity would be used. I listed a few issues and maybe some benefits as well, but one of the bigger problems we are getting into is these libraries, while physically separated into their different directories, they may not be super well separated conceptually or even interface-wise. One example I can give, which is I kind of hate, it's not like a logical issue in there. It's more like just a source code issue. But we have a loop between libyule, libevm, ASM, and the front end. They are interdependent on each other, which is kind of bad if you want to separate these things nicely. The major components, they do have some kind of a clear boundary, but everything is in C++. The clearest external boundary happens in two places. The assembler has a JSON import and export feature. The export feature has been there forever. The import feature is still not merged, but it kind of works. And then Solidity itself has this JSON AST import-export. I think some tools like Scribble may be using it. Basically, you can skip the parser. No, Scribble uses a TypeScript parser. But yeah, some people, we wanted people to use it. Some people use it, but they ended up not using it at the end. But the main issue I kind of see here, all of this is C++, which is kind of hard to integrate with other kind of languages. It is hard to integrate with JavaScript. We have this Mscript layer, and we have the C wrapper. It is hard to integrate with Rust. You need a C layer as well. Although Rust does have a C++ binding generator, it is not really stable. If you want to integrate this into Go, it's the same case. All of the All of the languages, they only work with C. They don't work with C++. So I have a few ideas how could we resolve this. And first of all, we want to just improve the separation of these libraries. We want to have clean interfaces between them, and maybe reduce the number of C++ features that the interfaces are using to make them more compatible with C. Then, parallel to this, because this can happen on the existing code base, parallel to this, we could start working on components in Rust. And we, in fact, already have components in Rust. We have Salty Rust, which is used. It's used by Faye, actually. And I think at some point, Foundry used it, but they were annoyed by the size of the binary and compilation pipeline, so they're not using it anymore. But we do have a bunch of libraries, U libraries in Rust, which is also used by Faye. And some people in the team now are working on some crazy features on top of it. The first useful step could be rewriting the assembler. And the reason behind this is the assembler is one of the oldest components we actually never changed. The parser itself has been mostly rewritten, or at least significantly improved. I think the type system, that is also kind of old, but it had more maintenance. But the assembler, that is the oldest component which has never been significantly improved on. It would be a really good task to rewrite it. And by rewriting it, it may not even need to be rewritten by us, but we could use an existing assembler. And in fact, ETK, the EVM toolkit, EVM assembler toolkit, I don't know what the acronym is for, but it is an assembler toolkit, basically, for EVM. It's written in Rust. We could just use that. In any case, once we have some of these components, we could think about creating a compiler skeleton. So basically just the driver, which drives the compilation process. And this doesn't mean that we would need to rewrite the compiler. All we would need to do is provide Rust bindings to some of those components, and then have this driver which just uses those components. And once this works, we could swap out parts of those components. For example, the assembler, because they are just components. And once this would be working, the biggest change would be actually doing a major rewrite of the front end in Rust. And the front end, by the front end, I mean mostly the parser, the analysis, the type system, etc., and the code generation as well. That is an insane project. And why would you want to do that? Well, you likely don't want to do it for 1.0, but you want to do it for something else. So what is the reasoning behind all of this? The main reason is that we kind of, or at least me, want to turn Solidity, all this code, into a usable compiler framework. I want to make sure that all the optimization steps we have, all of these features, they're not just wasted, they're not just there for Solidity, but they can be used by other languages. Imagine if we would have had this compiler framework earlier on, akin to LLVM for EVM. How long would it have taken for Faye to come to fruition, or half for any of these other languages, if you could just use any of these components? I listed a bunch of different projects which are already in the EVM space working on Rust compiler components. So of course we have Faye. We have the two other Solidity compilers/parsers. So Solang is a full-featured compiler from Solidity to WebAssembly targets. Well, actually, LLVM targets, they started with WebAssembly, but they also support BPF, Solana, and a bunch of other targets. The one thing they don't support is EVM. And in fact, Solang, I believe, is used by Foundry for parsing Solidity because it's in Rust. So they're not using Solidity. Slang is a project by Hardhat. They're trying to write a compiler as well. The motivation is slightly different. They want to have a parser which is flexible and supports every single version of Solidity, because they don't want to swap out the compiler, mid-compilation. And that's the problem with the current compiler. It only supports a single version. So why would we want to do this? Because I want to attract more people to Solidity compiler development. And it seems like C++ is not like a language people like or people are interested in. It has been kind of hard to attract people to write C++ code. But it seems like Rust is extremely thriving. Every other project is in Rust. I've been using Rust for a long time, so I would be happy for this to happen. And if we do some kind of a re-architecting like this, that would mean that we have an opportunity to actually improve the architecture of the compiler and maybe improve the language itself. So that is the next one I'm going to talk about is what kind of language could we have here? You will be surprised or not, but the fact is we have been talking about like this, Rust-inspired changes to the language since 2019, way before some of these other Rust-inspired EVM languages came about. Oh, it's actually another slide. I think the main motivations, the main reasons those discussions were started, because there are a few issues in Solidity itself, or at least a few issues I think should be addressed. One of them is really the storage and the implementation itself is not really separated. So the only thing we have right now is this construct. It can have storage defined anywhere. It can have functions defined anywhere. It can inherit other contracts which also define storage and functions anywhere. And you never know where storage is. It could be handled by any of these imported libraries. It would be nice to actually make this more clear. The other thing would be nice to kind of make clear when state changes or state access can happen. We do have some of this in the language today. We have payable, we have view and pure functions, but that's about it. It would be nice to have like more clarity, even within the functions, when is a state change taking place. Functions can be quite long. I think good code bases started to create small helpers and limit the scope of like state changes to those smaller helpers. But it's still, people can write, no matter what you do, people can write really bad code. But in Solidity especially, people can write like giant pieces of code. And it would be nice to have like clear view where is state access or state modification taking place. And lastly, if we take such a big step, we could even consider removing like inheritance or looking at like a different way of composing the source code. And in fact, if we have like more clear control about the storage, maybe we also have more clear control over storage layout, which has been like a really annoying question. And I know many of you have opened issues. How can we like set like slot numbers, etc.? Some older contracts have like these padding storage items. It's insane. Okay, now finally, what could it look like? So here's an example. I'm not sure if any of you recognize this. It looks like Rust, but more specifically. No, it's not Svay. It's Fay. This is actually Fay, and they started to basically do all these steps we were discussing, which means having a context, which is like a clear separation of state access. OK, this is what's on the website, but yeah, this is another one, which is nice. Not having like special constructs, rather have it tied into state access. And I think they're also like changing it from having a contract and all these things to having separate pieces. Now, here's a real example of what is more like what we discussed under like Rust Solidity. Do you have like a separation of, this could be contract, could be struct. People leaning towards struct. So this would be really just the data, and then that would be the implementation. I mean, it's not too different to what Faye is trying to do now. And this is the stock contract I had as an example before. Yeah, I mean, that's it really. I only have 10 seconds left.
Thank you. I guess we can take one question. If somebody has a question, please raise your hand so that the mic can find you.
Hey, Alex. So, just a simple question. You were talking a lot about Rust, but have you guys given a talk to Carbon? That's like the new language that they are going to upgrade C++.
So which
from Google?
language?
Carbon. It's
Carbon.
interoperable, so you guys could like
Is
reuse.
oh yeah, the new C++, right?
Yeah, that's it's experimental yet, but guys would be able to use everything that's written so far.
I'm not sure what benefit that would bring.
But it's worth a thought.
Yeah, I think I don't think we had a look, but we heard about it.
Unfortunately, time's up. But thank you so much, Alex. And I guess find him for questions somewhere here around if you have more. Okay, moving a little bit from the potential future scenarios of Solidity to the present of Solidity and the present to EVM, I'd like to introduce the next speaker, Hari. He's a contributor to the Solidity language, also an auditor and a coder. And today he will walk us through how symbolic computation works end-to-end in the EVM and in Solidity. He will give insights on problems that can be solved efficiently, how to build custom solvers from scratch, and produce computer proofs. And I'm sharing some alpha. I think we will be saving some gas.
Hello. Okay, perfect. So I want to start my talk with a question. Here's a Solidity code. How do we optimize this code? There is one trick here. What is the trick? Okay, perfect. Yeah, so what he's saying is that this branch is not reachable for whatever reasons. We're going to figure out how we will symbolically figure this out and how we can use symbolic computation to find that this branch is unreachable. So what is symbolic computation? Symbolic computation is about representing properties using mathematical equations. And we use the solutions of these equations to reason about the properties we started with. The property we wanted to know in the previous example is that the reward is unreachable. And we have to figure out a way to convert this Solidity code into a mathematical equation. And I want to give some hint about the climax, which is usually these systems having, the system of equation having a solution means that a property can be violated. And on the contrary, if the system of equations don't have any solution, then it usually means that the property is always true. I mean, this is not generally true, but most of the time, this is what you're trying to do. And now we want to convert code into mathematical equations. How do we do that? So the question is, what do we encode? So we could encode Solidity directly. We could encode Yule, which is an intermediate representation of Solidity. It's a one level down from Solidity. We could also encode EVM, which is at the lowest level. So Solidity is a complex language, and there's, let's maybe skip encoding that because there's too many rules we have to handle. EVM, on the other hand, is too simple, and we have to extract a lot of information about the control flow and encode it. So maybe let's ignore Solidity and EVM for encoding and just deal with Yule. It's in the right middle ground. It's simple enough, and it has enough information about the control flow. So the most fundamental thing to encode would be a variable. And a variable in EVM is a 256-bit integer. Most of the time, you represent variables as an element of integers, z as the notation. If possible, we add the constraint 0 less than or equal to x less than or equal to 2 raised to 256 minus 1. Now that we know how to encode a very simple variable, we need to figure out how do we assign values to the variables. So here's a very simple Yule block with 3 variables, x, y, and z. X is assigned the value 1, Y is assigned call data load 0, and Z is an expression in UL less than XY. So we want to represent each of these assignments by constraints. For X and Y, it's pretty simple. For X, you just have the equation X equal to 1. For Y, we have to just say Y. That's it. It's a simple EVM variable. We can't really like produce any extra constraints from call data load 0 because it can be anything. So we just have to treat Y as a regular EVM variable. And with Z, we have to figure out a way to encode a less than of XY. We will deal with that later. But the big question is that, can we handle every assignment? So here is a different UL block where you assign the value 1 to X, and there's a switch statement which has 3 different control flow branches. So depending on the value of call data load 0, which we don't know what it is, we can assign X, 2, 3, or 4. So the question is, can we actually encode the switch? This brings us to the notion of a single static assignment. So these are variables that are only assigned once. And working with SSA variables simplifies our analysis quite a bit. So here is an example of a different UL block. You have 2 variables, X and Y. Y gets assigned call data load 32 at the beginning and then reassigned something else. By definition, Y is not an SSA variable. It's assigned twice. But it's actually possible to transform this block into another UL block where we introduce a new variable Z, and all these variables are actually SSA variables. So generally speaking, we only want to work with SSA variables because they really simplify our analysis. However, it's not always possible to do a UL to UL transformation such that all the variables are SSA. There was the example like 2 slides ago. The switch example, you cannot encode X as an SSA variable purely in UL. But we can still get a lot done with just taking whatever is SSA, and maybe we also have this step in the UL optimizer called the SSA transform that lets us transform UL into what we call as a pseudo SSA format. So a lot of variables are SSA, but it's not necessarily that every variable is SSA. So whenever we encounter a non-SSA variable during the analysis, we would replace it by a free variable. So a free variable is what we mentioned like 3 slides ago, which is just the basic constraints that you can give to any variable in the EVM. But there is this important caveat here that, whenever we encounter a non-SSA variable, we have to replace it with a fresh variable because the value may have been assigned something else during the 2 reads. But we can, of course, optimize this further, but this is what we'll do now. So now let's think about how do we encode some EVM instructions. So perhaps the most fundamental EVM instruction is addition. You take 2 numbers and you add them and leave it at the stack. So how do we symbolically represent the addition, x plus y? What do you think? Is it just x plus y? Unfortunately, it's not that simple. So if you look at the EVM semantics of addition, addition is defined by x plus y modulo 2 raised to 256. And if you look at high-level Solidity code, since 080, we have the checked arithmetic. So x plus y would revert if x plus y is greater than or equal to 2 raised to 256. So we're already seeing that it's not as simple. It's not that simple to encode add. It's doable, but it's not the easiest. But perhaps here is like an easier set of instructions: less than, greater than, and E0. Here's a formula formal representation of these opcodes. We define when these values take 1 or 0. There are like, if for less than or AB, if A is less than B, the value takes less. The opcode gives 1. In the other case, it gives 0. Almost the opposite for greater than. For is 0, if the value is 0, then you get 1 and 0 otherwise. So let's digress for a bit and talk about difference logic. So let's start with an example. So x, y, and z are integer variables, and let there be constraints. 2 of them, x minus y less than or equal to 4, and x minus z less than or equal to 3. The question is, does the system have a solution? What do you think? It does have a solution. You can just assign x equal to 4, y equal to 0, z equal to 1, and these two constraints are satisfied. So to go back a bit, you can generalize this difference logic by saying, okay, you can have n number of variables, x1 to xn, that are integers, and constraints of the form xi minus xj less than or equal to a constant. But let's look at a different example. You add one more constraint here, which is z minus x less than or equal to minus 8. And the question is, does this have a solution now? Any takers? It actually doesn't have a solution. And how do we prove this? So assume that there is a solution. Let's just add all the variables. So let's add all the equations. So you add x minus y plus y minus z plus z minus x. And the RHS is going to be 4 plus 3 minus 8. And the LHS is going to be 0. So we arrive at something 0 less than or equal to minus 1, which is a contradiction. So there is no solution. But how do we use some graph theory trick to do the same thing? So we try to encode each of these constraints using a graph. Every variable is a node in this graph. So you can see that x, y, and z are 3 nodes. And we assign some weights. These are the weights that come from the equation. So x minus y is less than or equal to 4. That would be the weight of the edge. Similarly for the others. What's important is that it's a directed graph, and the direction follows, So in case of a minus b less than or equal to k, the edge is from b to a and has a weight of k. So the important takeaway here is that if there's a negative cycle in our directed graph, then there are no solutions to our problem. You can see here. There is a negative cycle. So if you add up 4 plus 3 plus minus 8, that is negative 1. So that's what we are looking for. So how do we find negative cycles in a graph? So there is this very classical algorithm called the Bellman-Ford, which can tell you, given a direct graph, is there a negative cycle? You can also use it to find the shortest path between two nodes. That's the classical use case, but it can also tell you if there's a negative cycle. And it's surprisingly easy to implement. You can even implement this in Solidity. Leo has a repo where he implements the Bellman-Ford and much more completely in Solidity. And he's going to have a talk tomorrow at 11 a.m. You can come for the talk for more details. And here is some insight about unsatisfiability. Unsatisfiability is when the set of constraints have no solutions. And a lot of times, we only encode a very small set of what we can actually encode. And we are very generous about ignoring the constraints we can't solve. Like I said already, we ignore non-SSA variables. So as long as we only care about unsatisfiability, we can do this. And we can optimize, and we can usually optimize when the constraints are unsatisfiable. Otherwise, we just leave the code unchanged. So we talked about difference logic, but what does it have to do with all these EVM opcodes? So it turns out that we can represent these 3 EVM opcodes using expressions that would match difference logic. So in case of less than of AB, so when the value is 1, it's only when A minus B is less than or equal to -1, and 0 when B minus A less than or equal to 0. So similarly, you can build these constraints for greater than and is 0. So in the last example, 0 is just a variable that we used to indicate it's 0. There is some like nuance here, but you could just treat 0 as a variable here. So how do we encode YOOL? So a lot of times, we want to know if the value of an expression is always 0 or always non-zero. So if you take this example of if of condition and then something going on in the if statement, we can replace, so the question we want to know is if we can replace condition by 0 or 1. Inside the branch, we can actually replace, we can add the additional constraint that condition equal to true. So to take a, in particular, if you look at if of less than xy, we start by checking if adding the constraint x less than y make the system unsatisfiable. So in difference logic, this is x minus y less than or equal to -1. We just add it to our other set of constraints. And if the system is unsatisfiable, we can replace less than of xy by 0. Similarly, we can check if the system, if the constraint x greater than or equal to y make the system unsatisfiable. In that case, we can replace less than of xy by 1. And inside the if body, we can add the additional constraint that x is less than y. In difference logic, that is x minus y less than or equal to -1. And then we can keep doing our symbolic computation. So going back to the problem from the beginning, here is like a version of the same like Solidity code in YOOL. We have 3 variables, x, y, and z. They all read from call data. They are not 100% equivalent, but more or less this is how the YOOL code would look like. And we have 3 if statements. The first one has less than of x, comma y. The second one is less than of y, comma z. And the third one has less than of z, comma x. And the last one would revert if we can reach there. And the question we want to know is if the last less than of x, z can ever be 0. Sorry, can it ever be true? And if it's never true, we can replace it by if 0, which is what we want. Let's think about how to encode the problem now. So we have 3 variables, x, y, z, that are integers. We don't have any extra conditions for call data law because it's, we can't really tell anything about it. We add a dummy variable 0, as I said before. Now we add the constraints that these variables are 256-bit numbers, that is 0 less than or equal to a less than or equal to the UN max. So the first set of constraints are simply saying that x, y, and z are positive. You can see that. And the second one would say that x, y, and z are bounded by the maximum value of UN 256. And inside the if branch, in the first branch, you can add the first constraint, x minus y less than or equal to -1. Inside the second if branch, we can add the constraint y minus z less than or equal to -1. The third one, we can add a similar one, z minus x less than or equal to -1. And we learned quite a bit here. So how do we represent all these constraints as a single graph? So you can see the nodes x, y, and z. You can also see the node 0. These are the constraints for the positivity and also the boundedness. So here m is the maximum value of a 256-bit number. And this constraint is z minus x less than or equal to -1. Similarly, the others are on the outer edges of the node. And the question we want to ask now is there a negative cycle in this graph? And turns out there is one. The one on the outside is a negative cycle, which means that the system has no solutions. So now we can actually replace this if of less than xz by if of 0. And once we have this if of 0, we can just completely remove this branch, And after that, these branches are simply empty. You could actually remove the entirety of the code. So in case of the difference logic, the solver is very simple. As I said, you can write it in Solidity, Leo's done that. However, in general, the solver can get quite complex, and the question of correctness will always come up. The biggest priority for Solidity is like the correctness of the compiler, and we really want to like minimize trusting external tools as much as possible when they influence the code generated. So in case of a symbolic solver, if there's a way to verify that the result is indeed true, then that is very good for us. So in case of a difference logic, you can ask, is it possible to produce a proof that the system is indeed unsatisfiable, that there are no solutions? Turns out you can actually do that. The proof of unsatisfiability in this case would be just giving a set of constraints where if you add up the left-hand side, it's going to be 0. If you add up the right-hand side, it's going to be a negative number. So you get 0 less than or equal to -1, which is a contradiction. And the solver can just tell you that, oh, these are the constraints that would add up to 0 on the left and a negative number on the right. And this can be verified by whatever tool that is going to use the result of the solver. But in general, you can get proofs for a lot of symbolic logic. You can get proofs from a lot of symbolic solvers. But it's not always possible. Maybe the example was like very simple, like who cares about these 3 if branches? But let's look at a more real-world example where this could be actually useful. As a lot of times, users would like to add their own checks before compiler checks. So here is an array that you just read from the array, and you read from one of the index. And the user wants to check if the index is going to be greater than or equal to array.length, which means there's an out-of-bounds access. And the user wants to like revert by this custom error. However, the compiler will automatically do this check in this code. So doing this check manually is actually like wasting gas and is redundant. But this is like a good pattern. Like sometimes users want to like revert with their own error messages. But we can actually use different logic to see that the second like constraint. Once you get out of this if branch, you can add the constraint that the index is less than array of length because this branch is always terminating. Like if you get into this branch, it's going to revert. But in general, it can also be a branch where it's always going to return. So we can actually add this extra constraint. And if you have this check once again, you can actually prove that this check is going to be unreachable, and then you can optimize out those branches. So how do we improve? Where do we go from the difference logic? So we could only encode less than, greater than, and is 0. But once we graduate from the constraints of the from x less than or equal to y less than or equal to k, sorry, x minus y less than or equal to k, we can think about generalizing this. So one generalization would be constraints of the form a1x plus a2x until a and xn less than or equal to b, where ai and b are constants and xi is a symbolic variable in integers. We can actually solve that using what's called like linear programs and the simplex method. And once you can do that, you can encode addition and subtractions, because addition would be like x1 plus x2, and subtraction would be x1 minus x2. They would satisfy that like form. But there are some nuances here, because addition in EVM has a wrapping behavior. So you have to have some kind of branching to deal with this modulo, but it's doable. We can also encode multiplication and division similarly, where one of them has to be a constant, and the other one can be symbolic. In case of division, the second one has to be constant. In case of multiplication, you can anything. One of the variable has to be symbolic and the other one constant. Yeah, I think that's it from for my talk.
Okay, thank you, Hari. We have some time for questions, so please raise your hand. Yeah, I see a hand over there in the back. A volunteer is coming to you with a mic. 1 second. Oh, and another one there. Nice. Oh, and another one there, yeah.
Hey, I'm wondering, how do you know as a Solidity developer when your checks are redundant, and what can you do to inspect that?
Yeah, I think the only way to do that would be perhaps do both the tests. I mean, write both of them and see if they have the same gas, or check the intermediate representation perhaps, or the assembly and make a diff. I mean, none of the things I mentioned here are implemented so far. There are some branches. These are just mostly experimental features. Sorry, what? Yeah, but it's not much.
Cool. Maybe just to use that as a segue, which parts are already implemented and what else might we see in the future?
So we have an experimental solver that uses an SMT checker, an experimental optimization stage already. It's called a reasoning-based simplifier. It uses the full power of an SMT solver, but it's disabled by default in the compiler, but you can probably enable it if you specify the optimization sequence that includes this one step. So you can still get some of this if you add an extra letter to the optimization sequence, but the rest of, so the whole point of the talk is you can build a very simple logic that can do a small subset of computations. This is not done, this is not in the master yet. But most of the SSA transform, it's already there. No idea.
I thought I saw a third question somewhere. Please raise your hand if you have one. If not, a big round of applause for Hari. Thank you.
We got one more question.
Oh, one more. Okay, one more. Last one.
So you said we should be doing this optimization on UL rather than EVM bytecode or Solidity, or it's more conducive. And I'm wondering, it seems like people would use this sort of analysis to potentially like look at MEV constraints. And I'm wondering how you could apply this to on-chain bytecode, or if that's infeasible.
Yeah, you can probably like decompile EVM into maybe some UL and try to do similar analysis on it. There is this tool that's getting built by Leo and some other people called ULs. You can probably check the status of that. It can do some of this symbolic computation. It doesn't, I mean, it uses like the full power of SMT solvers, not this restricted version, but you can probably check it out. So once you have a translator from EVM to UL, you can apply these tools. Or you can use HEVM, which works on EVM bytecode directly. Another possibility.
Awesome. Thank you so much, Hari. I hope your brains got kind of preheated throughout the last two talks, because now we are going even deeper. We can, I guess, already use the time while I announce the next speaker to set up, because this will be more of a workshop setup. Zina, maybe you want to come up on the stage already to set your infrastructure up. The next speaker we will have here is Zina. He's part of the Go Ethereum team, and in the team his focus lays mostly on tracing, the JSON RPC, and the GraphQL APIs. And today he'll be talking about EVM tracing in Geth. yeah, brace yourselves for a very detailed download on basic tracing, commonly faced problems, as well as an introduction to the more recently shipped features and how to write efficient tracers. Welcome, Zina. Big applause. Devcon. I hope that's fine. Some of you might know that I'm involved in the continuous Devcon, which is basically this idea to make the Devcon experience more holistic, more community empowered and community driven, and generally, yeah, a really nice event and experience for all. That includes the community hubs on the first floor, but also the hacker basement, and also the fact that the event venue is open until 11 p.m. And I thought I could use the time until the guys are set up to show some of the events that are happening tonight that are organized and driven by the community. First of all, we have let me check. By the way, a quick tip for the event app. So if you go to app.devcon.org, you can, of course, see the schedule in your browser as well, but it also is a progressive web app, which means you can download it by adding it to your home screen. The only issue with that is it doesn't automatically update, so it might make sense to sometimes delete it and add it again to get the actual content if something in the schedule has been changed or added. So yeah, I recommend doing that maybe once per day or so, or checking the website on the agenda on the website. So yeah, tonight we have actually an interesting mix of music stuff happening and also some workshops. So at 6 p.m. in the Chiva Lounge, that's this area with the Chiva bus, which is outside but with tents, we have Tomo Saito DJ session. Then also at 6 p.m. in the Ethereum Jungle, that's on the second floor, this decompression room, we have a session by Doing Good, a meditation and public goods workshop. Then in the Hacker Basement at 6 p.m. we today have a live coding session, which I think is pretty cool. It's a mix between art and coding and music, and yeah, you should really check it out. And at 5 p.m. we have the token engineering approach to building communities and membership, also in the Hacker Basement. So if you don't know what to do at 5 p.m. after this workshop, head down to the Hacker Basement. And as per usual, from 6 to 8 p.m. today, we have a happy hour again, which means we will have some drinks, beer, and also a typical Colombian drink, which I recommend you guys trying out, a hot drink with alcohol, sweet sugarcane syrup, and some anise. Yeah, tastes really good. And last but not least, in the workshop rooms at 6:30, we have the Web3 Developer Relations Gathering. So if you're into developer relations, check that out. And then for the rest of the evening, we have more music throughout the evening in the Chiva Lounge. And we have the Attractor LP Migrants performance in the Hacker Basement at 9 p.m. So if you're not the party guy, check out the Hacker Basement. There will be definitely something going on in the evenings as well. Are we now good to go?
I think so.
Okay,
yeah.
Awesome. In case you forget what you were here for, it's Zina from the guest team who will now give a workshop on EVM tracing in Go Ethereum.
Okay, is it on? Yeah. Hey, everyone, I'm Sina. Sorry for the... It's not a presentation if there's no technical failure, so... and unfortunately, like... No, this is wrong, sorry. Yeah, this is going to be a workshop, so I will be working with the terminal. I will show you some code and show you how to use Geth, Geth tracing feature. That's why we specifically needed my laptop. So yeah, sorry for having to wait. Also, yeah, because I will be showing code, it would be great if you guys could come forward if you want to see what's happening, because I imagine the fonts will be small. So yeah, I'm going to give you a bit of time to come forward. And while you're doing that, I want to talk a bit, something a bit personal. So I come from Iran, and I don't know if you heard, but there's some stuff happening there. I just wanted to give a quick shout out to the people who are going to the streets there. They're protesting for their civil liberties, for freedom of speech. So yeah, there's been 3 weeks of protest now. Internet has been disconnected. And it all started when the girl on the left, who is 22 years old, was in custody because of showing a bit of hair, and she somehow happened to die in custody. And this outraged people who went on the streets. And during this protest, close to 200 people have died. Among them, Nika, who was 16 years old, and when running away from the police, she also died. So, yeah, just want to give a quick shout out to them. They're risking their lives, asking for their rights and for freedom. But this is a technical topic, and I don't want to waste your time anymore. So let's get straight to it. So what is tracing? Why would you need tracing? I just want to show you an example of, this is Etherscan. Everybody knows Etherscan, right? And the internal transaction section of Etherscan is basically a trace of that transaction. It shows you what happened within that transaction, every call that happened there, who called who, and so on. And this was actually probably not from a Geth node, but I'm guessing from Open Ethereum or Aragon. But we have a similar feature to this. And this is not the only use case. There's many of them. Just to name a few, like just before coming here, I was talking to somebody who's developing a ZK EVM, who are also heavily dependent on the tracing feature of Geth. I've seen talks from MEV researchers who are using the tracing features, and many more. Yeah, this is also another tab in the Etherscan the details where it shows you the state, like the state difference. We also have, as we will see later, this is also something that you can get from Geth. All right. So before we get to we get into tracing, you know that you can use Geth to execute a call on top of a given state. So you probably know ETH call. You give it a set of parameters, like as if it would be as if you want to send a transaction to the network, but this is actually not sent to the network. It's just executed locally, and you see the result. It's a simulation. So you have to give me a bit of time, because I had to restart my laptop and I lost all my setup. I have to bring up the terminal because I wanted to show you how this actually goes. Oh, no. So. Sorry. For some reason my laptop is misbehaving. Yeah, no, I want to open the terminal, but it's not working. Do you know how I search? Okay, I'm just going to use this. Okay, so I just want to run an instance of gas. It's kind of annoying that I have to. Oh, let me increase the font size also while I'm at it. Can you guys see? Yeah? Okay, that's good. So yeah, I have a girly node on my machine that is kind of synced to the network. Okay, yeah. Is it behind me? Yeah, maybe I move it here. All right, so let's do a call. I have them all stored in a file, so I don't have to type it out because yeah. Yeah, that restart really set me back. I'm sorry. Okay. Yeah, but I also copied the line number. Sorry? Capital V, Y. Oh yeah, true. Yeah, let me mirror the screen. That's so much easier. My my neck is breaking here. Yeah. Okay. Thank you, Francie, for the tip. All right, so now we got it. Now, what was the command you said? Yeah, okay, yeah. No, this is, yeah. Okay, we got it. There we go. Yeah. Okay. Wait, why am I getting 0? Is this the Etherscan? Anyway, I'm losing too much time on this, so I'm just going to go. I already lost a lot of time. You all know how ETH call goes, okay? Let's move on to the next one. I'm just going to explain to you. So basically, this is I'm simulating a call to the wrapped ETH contract on Gurley to get the balance of an account, of account 0, right? This will only give you the result. Like in this case, the result is 0. Like it shouldn't be. I have to figure this out. Like I think I have the wrong address here. Like this address, the 0 address should have some balance. But anyway, what I wanted to show is that when you do an ETH call, you only get the execution result, what is returned from the contract back. But this is oftentimes not enough information. We want usually more information. We want to see what happened inside the transaction, right? And that you can do by doing the same thing, but using a debug method, trace call, which will simulate the call for you and trace it at the same time. It would give you more information. So if I were to run this now, wait, I have to see why this address is wrong. Yeah, no, this is not the wrapped Ether. I think this is the mainnet contract. I was using, I was going to present with mainnet node, but then I found out the Wi-Fi here is not so good, so I can't SSH to my server. There we go. All right, so here we can already see that there is a lot more information. As it basically shows you all the steps that happen during the execution of this transaction. Now my TMX is not working. So, yeah, there's going to be a lot of steps. I'm not going to go to show you all of them, but basically you will see, okay, like what is the first opcode, what is the programming counter at that point, which opcode was executed, how much gas do we have at this point, like what is the storage at this point, and so on. So it will give you almost the full information that the EVM has when it runs through the transaction. No, I mean, yeah, you can ask questions, sure. The stack is before the instruction, yeah. So all of these information are from before we execute the opcode. Here I showed you, in this example, I showed you like tracing a call of my own craft. Like basically, I said, okay, I want to like do from to input and so on. But of course, Geth supports tracing existing transactions, the ones that were already mined on the chain. So historical transactions, so to say. Those you can do via these endpoints. You have a debug trace transaction that traces a historical transaction. You just give it a TX hash. You can also do it at the block level. You can trace a block by using trace block by number or hash. Or you can do even a whole range of blocks by using trace chain. But trace chain, mind you, is a bit different. It's not a simple, like, it's not using the simple JSON RPC request. You have to, it's based on the subscription API, so you have to use WebSocket for it. So the usage of it is a bit different. I'm not going to show you here, but yeah, it's cool for when you need to run over a range of blocks. Yeah. Okay. So what we saw in the previous trace was the default tracer. It's basically the opcode tracer. Like, it shows you every step. But sometimes you need the Etherscan screenshot. You want to see what calls happen, or like you want to get different information. And Get has a bunch of built-in tracers that you can just call them by name and get the information you want. So here, like in this section, I want to show you 3 of them. The first one being the one that we saw. I'm just going to, like, here in this table, you will see all the information that you will get from the opcode tracer, which is, yeah, I'm going to give you a second if you want to see what's in there. But yeah, basically you get the opcode information, all the gas-related information, like how much this opcode costs to execute, or will cost to execute, how much gas there's left, the whole memory snapshot of that transaction, the stack, return data of the last call, like when a call finishes, in the next step you will get the return data for it, storages for the storage slots for the contract, depth of the execution, refund, and if there was any error. But please note that if you want to use this tracer, there are some things to note. As I said, memory, stack, storage, and return data, these are dynamic values, and they can grow large, especially memory. You have to watch out for memory, because mainnet transactions these days are very heavy. So like if you have memory enabled, it can kill the node, basically. Like, yeah, one of our users reported that they tried to trace a block with, on a server with 64 gigabytes of memory, and it crashed, basically. But because of this, the tracer accepts options to disable all these features. So all of the ones that you will see in this list, they can be disabled. Some of them are enabled by default, some are not, but they're all like, you can toggle all of them. Also, if you really need to trace, you need a memory, let's say, and JSON RPC is not sufficient for it, and you control the node, then there's an endpoint standard trace block to file, which will trace a block and save it on a file alongside the node that you can, yeah, you can easily access. So it's not like a JSON RPC request. The next one is the call tracer. This is arguably one of the more most interesting tracers. It will basically give you all the call information, like all the internal calls that happened during the execution. I'm going to show you in the previous example, like basically when we call wrapped ether balance of, what information we will get in return. So it's kind of down here. So you can see that like balance off is a simple call. It's not going to call anything else. And there's one call. It shows you who is the sender, who is the recipient, who's the contract. What is it call or is it create? Was there any value transfer? And what was the call data? What was the input? But yeah, this is a more like boring example, we can, I hope these transaction hashes are okay. I feel like the file wasn't saved. Let's try. Yeah, okay, it works. So I'm just going to run it, show you guys. So here I'm trying, like I'm not doing trace call, but I'm using historical transaction that was mined on Gurley. So I'm using trace transaction endpoint. And this is the transaction hash. And here, like as an option, you can specify, is this working? You can specify which tracer you want to use. So if you don't provide anything, then it will default to the opcode tracer. But you can say, I want to use the call tracer, as we did here. And you will get a bunch of information. Yeah, so this is going to be the main call. And notice that we can already see like this call errored, like it reverted. We can also see since recently, we can see the revert reason, which is system time outdated. This is the solidity revert error that was returned, the input output. And then from here we have the nested calls. So basically the main contract did called another one that we can see here, which also reverted. And like up there you can see like there's more nested calls that it's not being displayed here, but you can get that information also. So yeah, call tracer you would use when you need information about the internal calls. It also, since recently, it accepts a nifty option. So I'm gonna provide here, like you can basically configure the tracers. You can say like I want only top call. This is useful if you need only the top call information, like only if you want to know, okay, why did this transaction revert? Then I don't need to see all the nested call information. I just get the top call and I check the revert reason and I know, okay, there was a time outdated or something. All right, on to the next. This one is the pre-state tracer. It has two modes of execution. By default, when you just say, I want to trace this with the pre-state tracer, then it will give you all the accounts that are needed to execute the call or the transaction. You can think of it something similar to access list or witnesses. So if you somehow need to simulate a transaction and don't store the whole state, you can get the state via the pre-state tracer, and then you can execute your transaction locally. And in the second mode, you can see all the state modifications that happen during the transaction. Basically, you can see, okay, the balance of this account increased to such value, the storage slots changed such and such. Yeah. So if we were to see it live. It's this one. So here I need to change the address. I'm going to execute the same wrapped ether balance of call and pass to see the pre-state. And yeah, as you can see, like the zero address has like shows the balance of the zero address. This is the contract itself has a balance, the code, nonce, and like all the storage slots that were needed to execute these transactions. These are not all the storage slots of this contract, but only those that were required here. And let's say you wanted to see the diff. You just pass a parameter diff mode. And yeah, basically we can see like the biggest change here is that the nonce of, so you have like a pre and post state, and you have to compare them. So you can see here, like we have the zero address. The nonce is omitted because it's 0. So nonce was 0, and now it's 1. So this is the only change that happened in the state during this transaction. But of course, if we were to run it with a more complicated transaction, you would see yeah, you see like there's going to be much more stuff. This is, yeah. And the diff. Yeah, and this is what parts of the state that changed during this particular transaction. Like here we had also balance updates. Yeah, nonce and balance both changed, and balance of zero account changed. And yeah, here we have like the format works as follows. Basically, whenever something is created, let's say a contract is created, it will not show up in the pre-object, it will only show in the post-object. And whenever something is deleted, it will only show up in the pre-object, but not in the post-object. So by comparing these two objects, you can see how the state was modified. Okay, back to the slides. So now I want to talk a bit about how Geth stores state, because it is very relevant when you're doing tracing. Like if you've been tracing, you probably saw this error, required historical state unavailable. Specifically when you want to trace a historical transaction, one that was mined. Now why is this? So first of all, how do we prepare the state for simulating a transaction or rerunning a transaction? It's basically like we have to find, okay, the transaction in block N, so we will fetch the state for block N-1, the post state of block N-1, and start executing all of the transactions within the target block until we reach the transaction that we want. At this point, we have the transaction, we have the state, the pre-state basically for our transaction, and we can execute it. But what happens if the state for this block N-1 is not available in the database? Basically, that's what when you get this error. So now comes the question: the state for which blocks are actually persisted. Let's get the archive node out of the picture because it's the easiest. So for archive node, you have all the states. Next one is full sync. By full sync, I specifically mean that you start executing all of the blocks from Genesis up until the head. Here, it's worth to note that always Geth stores the latest 128 blocks, the state for them, in memory. So you always have, like, while your node is syncing, you always have the state for the last 128 blocks. Now, anything beyond that is stored is persisted to disk only periodically, and that is roughly every 2 hours. So every 2 hours, the state for a block will be persisted to disk. And because we synced from Genesis, that means we have the state of a block roughly every 2 hours from Genesis on until the more recent ones. And the difference between full sync and snap sync is that in snap sync, you won't actually execute the transaction, you won't actually execute the blocks from the beginning, but from some pivot point. So let's say here is the point when you you fetch the state from the network and you start executing transactions. So that's why we only have the checkpoints from this point on. And we cannot execute any transaction that happened before we did the snap sync. So it's important to know, like, based on your use case, which sync mode you should go for. And now we can complete the picture again. So how do we prepare the state for executing a transaction? We fetch the state of the parent block from the database. If it's not available, what do? Geth will go back in the blocks for a number of blocks and checks if it has the state available for any of them on disk. And if so, then it will basically re-execute all of those blocks and prepare the state for your transaction. So here you can see in the error, we have the error and we have some more information, like re-exec equals 128. This means that Geth tried went 128 blocks backwards to find some state on disk that it could use to go forward, but it didn't find any. And this is a parameter that you can give. So basically, when you do trace transaction, you can provide this re-exec parameter and say, okay, I'm willing to go back 2,000 or 2 million blocks to find a state that I can use to execute this transaction. But of course, the more you're willing to go, the more you go back, the longer it's going to take, because all of those blocks have to be re-executed to compute this state. And we have there's a method that you can use to see states for which blocks are actually stored on disk, and that's debug get accessible state. So let's say, like, I want to see like 5,000 blocks behind the head. Do I have any state there? Computing, no state found. So I don't have anything between the last 5,000 and 4,000 blocks. Okay, I can try again, or I can enlarge the search parameters. It's probably also going to say no. Oh, actually no, it found it. So here it says, like, there's this block that I have this state.
Memory area between address 0 and address 0. Developers, this is just a straight line. Wonderful. 25 in our list of opcode of message.value and making sure like you can't send ether to a non-payable function. But that is not really relevant to us because our function isn't payable, so we're going to go ahead and skip that. Great, so on 25, we're going to push 4 onto the stack. Once again, where is this 4 coming from? And then 26, we're going to encounter our first blockchain-specific opcode. And what we're doing here is we're pushing the size of the input data onto the stack. And as you can see, we pushed 4 onto the stack. Now we have 4 on the stack again, so that means our input. So this is awesome. We have everything that we need. We have 8, we have 0. All we have to do now is save this, and we're done, right? But wait a second. We see that in our transaction, we ran dupe2, so we duplicated the second from the top word of the stack, okay? Then we swapped the first and second words on the stack, okay, interesting. And then, all right, great. So now we ran sstore. So sstore, store and storage. We're saving 8 to the 0th storage slot. That's what we initially wanted to do. But then we also have a pop after that because we have this extra 8 on here. And like, what is this 8 doing? Why is it here? This doesn't make a lot of sense, right? Like, why are we duplicating and swapping here? Why are we popping at the end? The Solidity is doing extra memory management that we don't want, right? Because we want to be as gas efficient as possible and be as gas efficient as possible. So we should jump down into Yule and try to optimize this code, right? Let's talk about gas optimization using Yule. If you're not familiar, Yule is simply a language that we use to write assembly code in Solidity. It's not exactly like writing opcode. It's not exactly like writing EVM assembly. It has for loops, if and switch statements, and it also disallows some commands like jump statements because they quickly become very, very difficult to reason about. All right, so we added Yule. We have this optimized set total supply function. It's awesome. We have an sstore with a 0 and an 8, so we're saving 8 to the 0th slot. This is great. This is going to be way better, right? Go ahead and let's go ahead and measure our contract. So once again, let's go ahead and look at the opcode representation of our contract first. So once again, we take a look at the opcodes, and we see that in fact, optimized set total supply does have less opcodes than set total supply. This is fantastic. We know that opcodes cost gas. We see that set total supply and optimized set total supply have the same opcodes, except set total supply has more. We just saved a lot of time and money, right? But let's measure it to be extra sure. So here this is I think hard hat gas reporter, and we've ran the set total supply function 100 times, and we see that the average gas cost is $23,599. Cool. And then, hey, now we ran optimized set total supply, and we see that the gas cost is $23,591. Awesome. gas, we have just saved our users an enormous amount of money, right? Well, not really. I kind of rugged you guys here. If you notice, optimizer enabled is equal to false. If you're not familiar with optimizer, it's something that you can use in hard hat and other tools when you're deploying smart contracts. So let's go ahead and enable our optimizer in hard hat. Rule set runs to 200, enable it, and remeasure. And in fact, when we have the optimizer enabled, it looks like the two functions cost approximately the same amount of gas, right? So all our time spent studying Yule and learning it and learning about sstore was wasted, right? Well, I wouldn't argue that exactly, but I will say that optimizing smart contracts is hard, and chances are that you're not going to do a better job than the compiler unless you really know what you're doing. Contracts containing assembly are generally harder to reason about and harder to audit than contracts written in Solidity and Viper. So what you might gain in gas optimization, you will probably be making a trade-off in contract or user security. And the other thing that's important is if you're writing your own assembly code, always measure and make sure that your implementation is better than the compilers, because chances are there are some very, very, very smart people working on the compilers and optimizers that know something that you don't when it comes to memory management or safety. And I guess that's essentially my last point. Remember, a lot of the memory management stuff Solidity does under the hood is there for safety reasons, and just because an opcode looks like it's unnecessary doesn't mean that it actually is. That being said, optimizing in Yule and in assembly is definitely something that is needed and useful, especially in DeFi and on mainnet, where gas costs are, lower now, but quite higher than a lot of the other chains. But yeah, I guess do so at your own risk. So thank you guys. Once again, my name's Alex. I'm a lead developer at Tallyho. And we are hiring Solidity and TypeScript developers. So if this kind of stuff is interesting to you and you're looking for a change, please reach out. And then finally, I want to give a big thanks to Gilbert Garza. He had a lecture at 0x Macra that inspired this talk. And there are a few resources on here if you would like to dig deeper on any of the topics covered today. Thanks so much.
Thank you. We would have some time for questions if you like.
Sure.
Just offering, in case there are questions. Yes, there are some. So yeah, let's take some questions. Thanks for the talk.
Hello. Oh, okay. Why the optimized function spend the same amount of gas if it has less opcodes?
So the opcodes that we were looking at were for the unoptimized functions, and we were looking at them because it is it's easier and possible to dissect them in a talk. So when we saw those two opcode, I guess of optimized, what was it, set total supply and set total supply, those are the unoptimized opcodes. And then when after the optimizer runs, the opcode representation of those two functions actually becomes the same. Oh,
sorry. So what those two opcodes were doing on the unoptimized function?
I'm sorry, could you repeat your question?
What were those two opcodes, two extra opcodes doing the swaps were doing on the unoptimized compiled version?
So the optimized compile version was effectively the same as our opcodes. Here, I can show you. So let's see. So here we have our unoptimized set total supply and our optimized set total supply in our code where the optimizer has not run before. After the optimizer runs, both of these functions have the same exact opcode. And in fact, even though we have two functions in our contract, the optimizer is smart enough to know that they're doing basically the same thing. So when we were talking earlier about these selectors over here, right? So this selector jumps to a destination, and then there would be a different function selector for another function. For the other function, they would actually both jump to the same destination, because effectively what they are doing is the same.
What would be some good use cases for managing the assembly code within contracts, and do you recommend any good resources for learning Yule?
Yeah, so I think that the best use case that I have seen is a fairly common one, where if you're adding two numbers that you are 100% sure will not overflow the integer limit, then in assembly you can add them with there's an unchecked flag, which basically tells the compiler to not check for integer overflow. I believe that in Solidity 9 point something, in some fairly recent version of Solidity, safe math became, I guess, standard. So there are a lot of checks that run under the hood. You can turn off those checks if you're sure that you don't need them, and that'll save gas. But once again, that can be very dangerous. And as far as resources for learning Yule, I think just reading smart contracts and trying to figure out what's going on there is the best way to do it. There are unfortunately no good resources to learn Yule or really EVM assembly, and which is that I wanted to talk. Just yeah.
Sure. Just to follow up on that, have you heard of trim?
Yeah.
Yeah. Okay, so my question is this, right? Like, say for instance, if I'm writing trim and I'm basically, you know, transpiling my smart contract into trim, like, what are the, I guess, like the pros and cons to that as opposed to doing it, you know, Yule style, like within Solidity and then using Yule?
Unfortunately, I can't answer that question because I'm not familiar enough with trim. I do believe that Gilbert was the person that I mentioned in my talk was the person that developed trim, or one of the developers, and I would encourage you to reach out to him on Twitter, but I'm not familiar enough with trim to answer that.
Hey, thanks for the talk. I saw somebody asked about Yule. Today there was an awesome workshop about that. It's like 2 hours long. You should watch that. And then I had a question for optimizer runs. What number do you recommend?
What number? I just choose 200 because it's standard. I know that there is a, or it's not standard, it's just like standard in what I've written. I know that there's eventually a trade-off size between contract size and gas efficiency that you get if you set your optimizer to, like, I don't know, 500,000, a million, or maybe less, but I generally go with 200. I don't work in the DeFi space, so I'm not like too concerned with ultra optimization, but 200 seems to be a good number for what I'm seeing.
If that was it, thank you so much.
Thank you, guys.
I actually made the first ever Yule stickers that were available today at the Solidity Impact booth. If you are very quick, maybe there are some left, but I'm not sure how many. They are even glow in the dark. But yeah, moving on to our next talk, and actually also the last talk already for today, we have Alexandre. He is a data scientist and open source advocate, and a fun fact I really liked about his speaker bio is that he got into Bitcoin in 2013 and actually launched the first Canadian Bitcoin payments processor. But now he's into building high-performance data solutions in the space, and in this session he will introduce the graph substreams for high-performance indexing. So please give a warm welcome to him.
I have this. There. Are we already started? Half a second there. No. Okay. Okay, I'll skip this part. We'll see where we go after. Okay. Hey. Hi, my name is Alexander. I'm CTO at Streaming Fast, and I'm also a pianist, a data scientist, whatever that means. I'm a father of 8 beautiful children, 2 of which are there. I love designing and crafting software, which I've done since I was 12. And I'm here today because one day in 2013, I read the Bitcoin white paper, and that changed the trajectory of my life. And fast forward to today, Streaming Fast, a company based in Montreal, Canada, is now one of the core developers of the Graph. And we joined the Graph a bit more than a year ago in a kind of bizarre M&A 2.0 fashion. Our lawyers still don't understand what happened. But anyway, we said thanks and goodbye to our VCs and shifted our focus to make the Graph the greatest data platform on earth. So today I'm here to introduce Substreams, which is a powerful new parallelized engine to process blockchain data. And before I can do that, I just want to set a bit of context. Perhaps you can raise your hand if you know what subgraphs are. Raise your hand if you know. Oh, wow, you're good. Okay, so subgraphs can be thought of an ETL process, right? Extract, transform, and load. And subgraphs add that little queue there, the GraphQL layer to it. And subgraphs today provide that sort of simple, approachable, end-to-end solution to blockchain indexing. And the graph node is responsible for all of these components, right? The extraction is done through hitting JSON RPC nodes, and then transformation, you provide some assembly script. You guys know that, compiled to WASM, running in a distributed environment. And then you have the load aspect, which the graph node does, puts that into Postgres and offers you a rich, and beautiful GraphQL interface on top. And one of the reasons we were brought in was that so we could push the graph to new height in terms of performances. So to do that, we brought, first thing, the fire hose, something at the extraction layer. Our take to boosting performance by 1, 2, 3 orders of magnitude. The first layer, extraction. It's a method of extracting data from blockchain nodes. Imagine prying an egg open, where the data is exfiltrated as fast as possible, and all the juicy data gets then thrown in a gRPC stream, as well as into flat files. And you can think of that as sort of the bin log replication stream for blockchains, where you'd find in a master-slave replication engine like in databases. So we'll get back to Firehose in a minute. Then Substreams is sort of rethinking of the second box, the transformation layer. Here, instead of the traditional subgraph handlers in assembly script, you will write Substreams modules in Rust, and those can be executed in real time as well as in parallel with unprecedented performance. So let me give you first a primer on Firehose, because there's a lot of benefits of Substreams that come directly from the Firehose. So, at Streaming Fast, for many years, we've been thinking hard about all these indexing problems from first principles. And we needed at first a robust extraction layer. We wanted something that was extremely low latency, something that would push data out the moment the transaction was executed within a blockchain node. JSON RPC was not going to cut it. And we didn't want to have to deal with those large, bulky nodes, right, hanging on a thread, occupied with managing high write throughput. That kept everything in a key value store behind a JSON RPC request, and it was really heavy in RAM and CPU, and you needed super optimized SSDs. This is really annoying, and all these things are much costlier than what needed when our goal was to get to the data inside. So we also wanted proper decoupling between the processes producing the data, so the blockchain nodes and its intricacies and its request response model, and they're all different, and the data itself. We wanted the data to be the interface. And we wanted something also extremely reliable, in the sense that we could avoid hitting load balanced nodes that had all sorts of different views of the world, and that we need to have like client code to like latency inducing code to resolve what's happening there. If there's on a fork, you need to query nodes again. And for reorganization heuristics, for example. But also, we wanted something better than even the WebSocket streams that pretend to be sort of, linear, that the nodes have implemented, because when they would send you a signal that, let's say this block was removed, it could leave you hanging. If you happened to be disconnected for just half a second, you'd reconnect, you'd miss the signal, so the reliability was not built in. So we wanted something to address that. And above all, we wanted something that is able to process networks in 20 minutes. Well, okay, an hour or two, but never 3 weeks or things where we're waiting linearly. And that's still our goal today. And when we say network history, I mean executing geth and extracting data executed into flat files. That's the extraction layer. But also, any sort of indexing after the fact, we wanted to be able to have massive parallelization. Like, there was no other way to have reliable and durable in performance without parallelization. So our solution was the Firehose. And the Firehose solved all of these issues in a radical way. We took a radical approach because we wanted to solve those problems definitively. Like, meaning that there would be no further optimization possible except attempting to bend sort of space-time continuum itself, right? So with streaming, with even multiple nodes pushing out data, multiple nodes are actually racing to push the data. The first sort of consuming process gets the first to get out. Like, you can't really remove more latency there. And there can be nothing faster than immediately when the transaction has just executed from your node. And then, like, regarding the stateful processes and cost, flat files for the win. We have a hashtag for that, right? Flat files are the cheapest, much cheaper than processes. They're easier to work with. There's nothing simpler nor cheaper in terms of computing resources. These storage facilities have been optimized like crazy. And it's also where data science is headed these days. And there's one common thing to every blockchain protocol, and that it processes data. Data is also the right abstraction for this technology, not an API that's common to all chain. Data. So Firehose clearly delineates responsibilities. And the contract between the extraction and transformation layers is, again, the data model. Firehose creates, and for every chain you can imagine the best data model, the most complete. And that's what we've done for for Ethereum, for example. The data model for Ethereum within Firehose is the richest there is. Like, you have in there the full call tree, internal transactions. You have the inputs and outputs as raw bytes. You have the logs, obviously. You have the state changes, like you see on Etherscan, down to the internal transaction level. You have balance changes the same way, with the prior value and the next value. So when you're doing like navigation backwards or forward, you have the data you need. You have also gas costs at different places, and there's that important notion of total ordering between things happening within the logs, state changes, and calls. All of these things happening during execution are totally ordered. So you get in there everything parity traces would give you, and more, and everything you would need to rebuild a full archive node from flat files. And everything there is scoped to the transaction level, not rounded at the block level, which is crucial if you want to index with precision, right? Rounding of blockchain information at the block level is was meant for helping in consensus, right? But it doesn't mean that what happens mid-block is of less value than what happens at the boundaries. So, okay. So that's very interesting. And now regarding reliability, whoops, no, not so fast. Regarding reliability, the Firehose gRPC stream provides reorg messages like new block or undo this block or this block is now final, accompanied by a precious cursor. I think that's really key here. With each message, so if you get disconnected and upon reconnection you give back that cursor, you'll continue exactly where you left off. And potentially receiving that undo signal that you would not have seen were you disconnected, right? So you will get it. So with the guarantees or linearity of the stream. So no WebSocket implementation would do that because it doesn't make sense for a single node to track all the forks possible even 2 days after the fact. And undo messages come with full payloads. So you get all the delta. So you can just turn around to your database and apply the reverse. Or, pluck again in the full payload of what happened in the block and decide what to do. So it doesn't impose on the reader to store what happened, like at that previous block if the signal was just remove block 7,000, right? Okay, and when you commit that cursor to your database, well, you get sort of that, finally some consistency guarantees within your backend. So some of our users told us they could cut 90%, 90, of their code reading the chain because they were relying on that reliable stream. And it also lays down the foundation for massively parallelized operation, files plus the stream. And so this is the future of the graph's unbeatable performance, and it's core to our multi-chain strategy because any blockchain can have that data model. Now let's dig into substreams. Substreams is a powerful clustered engine to process blockchain data. It's a streaming first engine and it's powered by the fire hose underneath and its data models of the chain. So let's dig in. Here are a few quick facts. It's invoked as a single gRPC call, and within the request we provide all the transformation code like you'll have in there. Oh, it's too low, huh? You'll have in there the code, some WASM modules, relationships between the modules, and all the transformations within the request. It's not a long-running process, except if you run it for long. It's not a service you spin up, right? And the backing nodes are stateless, which provide nice scalability properties. Modules for transformations are written in Rust. They compile to WASM, and they're run in a secure sandbox on the infrastructure there, similar to subgraphs. And the ultimate data source being the blockchain data, being deterministic, all the transformation outputs are also deterministic. And the request, if the request you send involves process prior history, even if it's 15 million blocks, well, the substream's runtime will then turn around and orchestrate the execution of a multitude of smaller jobs in parallel, fuse the results on the fly for you, and aggregate the results to simulate a linear execution. So you would see a difference. And all the results are streamed back to you as fast as possible with the same guarantees provided by the fire hose, with a block per block cursor and a transparent handoff from batch and historical processing to the real-time, low-latency, rewards-aware stream of the head of the chain. So let me show you, if you're interested, how we create one of these things. Raise your hand if you're curious. Okay, you're good. Okay, so let's start. We start with a manifest like that. Do you see that down here? Can I move the podium? I can't. So there's package information, some metadata there. You have pointers to the protobuf that you'll use. Again, contracts between modules are about data. So they're protobuf models similar to the protobuf models of the root chain, of the chains, the layer ones. And you have pointers to the binary that you're working on your drive and all that. And you have imports. And imports are actually very interesting because you can import third-party substreams packages. And these YAML can be packaged. And so you can import from someone else's package, you can write your own or combine both. That means substreams enables composition at transformation time, which I think is pretty unique and a pretty game changer. And then follow up, and there you have the module sections, which defines the relation between the different modules. And you see it defines sort of a directed acyclic graph. You have modules that slowly refine the data. And so there's two types of modules. One, the mapper, the first up there, map pools. And this one takes inputs, does transformation, and outputs. It's parallelizable down to its core, block-wise, so massively parallelizable. And then there's the store input. I think it's awesome. This one takes any inputs and outputs a key value store that are sort of accumulated in a stateful way. And stores can then be queried by downstream modules. And okay, so we'll see a bit more after. The name corresponds to the function in the WASM code, and the inputs can be of a few things. Either the raw fire hose feed. So for example, the source here, that means the block with all transactions, for that particular block. And it can be the output of another module, like you see down here, the input of map pools. So you'll get the data as bytes. And it can also be a store, which would be a reference. We'll see in the next slide there. And on the store pools here, you see there's an update policy, which sets constraints on what you can do with the store, and it defines a merge strategy for when you're running parallelized operation. I'll get to that also a little later. And the value type field will help anyone decoding understand what bytes there is in that store. So UI, you can JSONify them, and your code consuming can automatically decode them with protobuf, all languages supported. Otherwise, the key value is just keys, strings, bytes, values, very simple. And one thing to note here is that because it has deterministic input, it's possible to hash a module, like the kind and all of its inputs and the pointers to its parent, and including the initial block. So you have a fully determined and hashable, let's say, cache location for all of the history, similar to Git, right? All of the history of data produced and you'd hash also the WASM code, right? So it makes it for an extremely cacheable system and highly shareable and cross-verifiable output of modules, which opens really interesting possibilities, for collaboration within the graph ecosystem. And imagine that one has large disks and another has large CPUs or sleeping CPUs. They could pool resources together to build something bigger than themselves. Okay, and you see the relation there? So this gets piped to that. And if we add another module here, you see how the graph comes together. This one computes the price. This is Uniswap v3 thing. It computes the price, but you want to get them for certain pools because maybe you want to use the decimal placements in the pool. We'll see a little bit more there. And when you're running, let's say you're running that at block 15 million. Well, you're guaranteed, the runtime guarantees that the store you'll have to execute code at block 50 million will have been synced linearly or in parallel, but you wouldn't know. But it'll give you a full in-memory store, eventually backed by some disk, but whatever. And you can query the key value store at each block. It's guaranteed to be synced for you. That's exciting. No? Okay. So you see the DAG slowly being built, huh? Right? The dependency. So now this leads us to composability. See, each color here means a different author. And modules written by different people, ideally the most competent for each, right, like we would hope, they would analyze what's on chain and refine the data and abstract it to new heights. And the contract between the handoffs is always data. It's a model of data. So you take a module, it's bytes in, bytes out. And so you see here we can get the prices from Uniswap v2 and prices for Uniswap v3 and Sushi and Chainlink and whatever, and have someone write a module that takes his input at transformation time and then averages them out and whatnot, right? And then that you'd have like sort of one beautiful universal price module that you can then hook on top and feed to some, who knows, maybe someone feeds that back onto the chain for some reason. And then soon enough, all of that, well, someone wants to build on top of it. And something like that. Like someone wants to compute, the USD denominated volumes aggregation of NFT sales on OpenSea, You'll take some sales, you merge it with the price. And we see here that little Trader Inc. Maybe he wants to feed that into his trading bot, because this is a streaming engine, we're not storing that in the database yet, right? But this begs the question, where does all that beautiful data land? Where does it get piped? That's where syncs head up. Like, substreams being limited to the transformation stage of the ETL analogy, remember? It doesn't really care where you load it, and that could be anywhere. These are just a few examples. You can load that in databases. We already have a sync for Postgres and Mongo. You hook to substreams, and it just loads it into Postgres with the data model that we've agreed upon, right? If you write it in a certain way, it just syncs over there. Or message queues or whatever, data lakes or some bots or some trading algorithm, some whale detector you want to hook directly on the stream. Or also something, I think, big, for doing some ad hoc data science. Because now you have a really fast engine, allows you to process the whole history in, it can take a few minutes to process the whole of the Ethereum to go and pluck some new insight. So you can write your code, send it to the network, and then, stream out the results. Similar to, for those who know BigQuery, the cluster, the big cluster service by Google, that's what they do. Send the request, they just shard at everything, and they send you back the request. Well, all of a sudden, Substream's engine can allow you to do some things like that ad hoc. And you can write any program that supports gRPC and protobuf, which are many. And the last one here, not the least, subgraphs through GraphNode. Well, so we're working to make substreams feed directly into GraphNode to then provide the same loading experience and then querying experience that you've come to know and love. And you'll be able to deploy a subgraph, this time not containing assembly script, but a substreams package with an entry point, and would process the history in parallel and load that in your database in crazy speeds. So stay tuned for that. That's not out yet, but soon. Okay, and so this is a simple example in Python. It's not really longer than that. You have one or two dependencies like gRPC so that you can use the query, so we're leveraging a lot there. And you can, see that SPKG there? We can use that to code gen Python classes and helpers and all of that, because it turns out that the manifest, sort of the SPKG there, is, for those who know protobuf, is a file descriptor set. It contains all of the things, all the protobuf definitions. So the SPKG also contains all the WASM code, the module graph information, the dependencies, the inputs and all that, and even some documentation. Everything is needed is in there, so you can pass it down to the modules, you take it from the disk, and boom, you send the request to the server and it's running. So you can deploy packages also very easily and consume them very simply this way. There's a few imports we've omitted there, but it's simple, just to show. Okay, And let's look at a simplified data model for Uniswap v3. And then I'll show some code making use of it, okay? So this here, the pool, is a list of pool. This is actually what gets handed off from, our mapper, which finds the pool that were created, down to the store pool, which we're going to look also. And so it has a list of pools, and the pools you can imagine, an address and the 2 tokens that are concerned here. And we have a reference to the token also, which is going to be very useful to enrich the data downstream. We'll have the decimals right at hand. Like, we won't need to do much loading. It's going to be very, very close, so we can enrich all these uints 250, 79,000, and put the comma where it belongs. So let's see what happens in the mapper. So this is sample Rust code. Raise your hand if you love Rust. Oh, ho, 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 ho. Raise your hand if you know Rust. Okay, it's very simple here. I'm going to go through. You have the map pools function corresponding to the manifest there. It has one input, the block. This is the firehose block with all transactions, all logs, all state chains. You can craft your own triggers in there as you wish, but we have a simple version. See that line there, blocks, events. You have a thing that goes through transactions, and it's going to trigger on pool created, and that pool created object in Rust was actually code genned from the JSON ABI. So you can just give it instruction, and we're going to filter it for only the v3 swap factory, and then that beautiful filter map will give us the log. Okay? And then we'll output, we're going to collect some of these things into one list of pools, and it's assigned to the pools object there. And notice that little thing here, the RPC create Uniswap token thing. This actually hits an ETH call on a node behind, similar to what we have in subgraphs. And that's actually very important. It means that once we've processed this layer once, and we've done it for the history, it can be cached very efficiently. So anyone relying on that thing will never need to reprocess it again. You can give the package to someone, and they can access the stores that's been cached by other people immediately. So you could go to block 15 million, and you'll have the list of all pool created that you can query super fast. You can depend on it also. So I think that's pretty cool. And here, that's the store modules. The store module is pretty simple. Here, it receives, the pools from the output of the prior module. And it loops through the little pools there and calls output set. And see, the key there is pool : the address. It's going to store the proto-buff encoded stuff of the pool with the token decimals for both, right? And so, did I say that to be constrained? So the store here is constrained in 2 ways. In order to preserve parallelizability, the stores are write only. You cannot read your writes, otherwise that would make them potentially cyclic. And they expose only the function defined by the update policy. In this case, it's set. So let's see what happens if we run things in parallel. So here we have 2 jobs covering 2 segments of the chain, 1 million block each. And you see those ugly arrows there? They correspond to a pool created event. And so in our code, you've seen we would write a key for each of them. And so in the first partial run, we'd have what we call a partial store with 4 keys, and the next one we have 2 keys. And so when we'd run the merge operation, we would apply the set merge policy, which says basically take one store, take the other store, cycle through keys, and the last key wins. If you do that, you can parallelize endlessly. So we'd have here a complete store with 6 keys, and now at that place we have a snapshot. We can have periodic snapshots, and so if you want to go and explore the chain at any point in time, you have a snapshot plus a little partial. You can have the state synced at any block height. So this one, has the last key win policy, but you have a few others like min, max, add, and another one like first key wins. So if you merge them, you would have set if not exists, and then that allows us to build different aggregations, right? You'd like to see that running live? Okay, I have a few minutes. Now I need to bring that other window up. So, do you see that? Okay, that's good enough, huh? Okay, so let's imagine we want to see that pools created thing. Okay, do you see that? I want to see the output. I'm going to run that. I hope everything is good. The demo guys are connecting. Okay, whoa, not too fast. So this is going through, starting at the beginning, and we have there a pool created event. And see that? We have everything decoded because it's the protobuf thing. We have the thing to decode it. We could feed that. It arrives on the wire as bytes, and properly serialized bytes. And then we see that the token address is there. We have the decimal. We have the address. And so what that means is pretty crazy already. Oh, do I see that? Okay, what that means is that you can inspect the chain with your code at any place in time. For a mapper especially, you can go there, and I could run it again here and say, I want to run the mapper, let's say a block, I don't know, something more recent. Give me a recent block. What's the block yesterday? 15, 7 million, I don't know, something like that, okay? And see, is there anything recent? So there's some stuff, right? Some things that are recent. Can I see that? Someone still created a new pool, and I can inspect my code to make sure it works. Where is that? Come on, right? This one was wrapped Ether in Infinity. They just created that address as a new pool. So you can go and test your code everywhere. And once that's done, well, you're set, right? You can go then to the next data dependency. So this really changes the dynamics for debugging. And this can also work for stores, because you can ask for a store, and it's going to process it in parallel, and then you can inspect all the keys that exist there or see the deltas coming through. Okay, and let me show you something running in parallel. Graph out. Now this is very interesting because, oh no, let's start it at 15 million. Let's say I want graph out at 15 million. I didn't run it again before, and I want, so let's run it. So this starts a whole bunch of parallel processes. And you see up there the number of blocks per second. Yesterday I had that 8,000. On Solana blocks I had 16,000. It depends on the power you put behind there. But this all, like you saw, the pool count is a dependency on the pools. The pools is further down, so we're able to schedule things. And all of that just massively parallel. And once that's ready, let's say everything was done, I would start streaming and get all the content. And so let me show you the graph out. It's very interesting because graph out has refined the data up to entities. Now we're talking about database tables and fields, and you get out of that. Let's see. Do you see it? Do you not see it? Okay, that. Wait a second here. So let's imagine, see, we have token and an update, and you have the field derived ETH, and you have the old value and the new value. I don't know if you've seen this thing in the data science world. This looks very much like change data capture CDCs that can power a lot of large-scale systems, and you have the prior and after, so you can feed that to your, let's say, Postgres, apply the changes, and when you have an undo signal, it gives you back that payload. You then just flip everything, and you have guaranteed linearity, so your store with a cursor, and it's flawless. It's just extremely simple to keep your things in sync. You also want to have a Slack bot. You can have an undo message, remove the message if you have a thing coming through, right? So I think that's pretty cool. What do you think? Oh, wait. Okay. Okay, that's cool. Can I shut that down here? Do I have another window? I'm close to done. Prepare your question. Please ask them succinctly. We have a half a minute. I just wanted to have a final note there. Gosh, can I close that? I'm so sorry. So as a final note, I wanted to share with you a little bit of my vision for the graph. Okay, I don't know where the window is, so whatever. It just says fine. I'm imagining the graph becoming that sort of huge worldwide cluster of processing and storage capabilities, and something like Google's BigQuery, but where people join because it's better together, right? Instead of running it alone, where you need to have all the resources alone. And I see also a new era of composability, which means more collaboration and in a tighter community working together more intimately with those data contracts. And I see also a new mix of collaboration between indexers, like exchanging data or sharing resources in terms of compute and storage and whatnot, therefore introducing new value flows. And also I'm seeing new products, new services being offered directly on the network, to satisfy some needs that perhaps couldn't be addressed before. And I mean, there's a place for you in there as a developer, as an indexer, as someone who realizes the radical benefits of such a platform and who builds on it and promotes it. So my ask to you is, you go try Substream's Put pressure on your favorite layer one so that they do integrate the Firehose natively. That's Pristine's Aptos has done that recently, some other Starkware, I think. So that makes it, everything we've seen today becomes immediately available to them. Sell them on the goodies. So also join our Discord. I would love follow-up questions. And come see me afterward. I love feedbacks on these sort of things. All of this is open source, so let's dig and build something of like together the biggest blockchain platform on earth. Thanks you for your time today. Do we have time for 2-3 questions? We're the last one, so if you have a question.
Hey.
Are they? Oh, okay,
sorry.
go ahead.
Hey, so one question. Modularity and composability of these substreams is super, super powerful. But still, if I look at this compared to SQL and like DBT models, right, it's a lot more complex. So how can we enable people to really kind of learn this and like build these kind of hyper-modular data streams?
So it's a good question, but the transformation layer is not the SQL layer. Like this is powering, going through history, it's an ad hoc transform with stateful storage, but you would pipeline into SQL storage to do other things, right? You would have refinement, you have knowledge from the community as to how to analyze this and that protocol, ever increasing refinements, but then you might store that in your store with off-chain data, and maybe that's best fit for you. Maybe you feed it into a subgraph, that's what you need. You have a total decentralized solution and you don't need to host anything. So this is an enabler at a lower level. It doesn't seek to replace SQL, but it puts itself at a place where we can feed all the systems on Earth with enriched data, which you would need to do in SQL, and it's really not fun. So you leave that to the community, right?
Gotcha. Thank you.
My pleasure. Another question? Yeah? No.
Hey, my question is about when we have an old subgraph which is working without, sorry, can you hear me?
Yeah, go ahead.
Yeah, okay. We have an old subgraph which is pretty slow and we would like to transform it to the new type of subgraph.
Yes.
Should I only read some code on Rust and that's it, or something else?
So it is not the same paradigm. To enable parallelization, you need to distinguish the data dependencies, and that infers the number of stages of parallelization that is needed. It's not easy at all. Actually, it's pretty crazy to try to parallelize the subgraphs. We tried that. That's what yielded us to design substreams by cutting, Uniswap stuff. So you will want to go and write in Rust modules, and it's a different paradigm. So it's not just an easy switch, I admit, but it brings us to the next stage in evolution, of blockchain indexing.
Yeah, I see. Thanks.
I guess then we're wrapping it up. If you have more questions, I think Alexandra will be available for more questions after this. And thank you so much, Alexandra.
My pleasure.
And with this, we are wrapping the program up for today in this room. So thank you so much for joining, everybody. If you want to stick around, feel free to check out the first floor, the second floor, or the hacker basement. And everything will be open until 11 p.m. So feel free to hang around, network, enjoy the happy hour, and have a nice evening.
you.